Hello, my dear students. Welcome to this lecture. So this entire series of lectures, we will be taking this particular plan. Okay, it's one of a residential building which has a ground floor, first floor, and a second floor. Okay, and we'll try to find out the quantities for our entire building. Okay, now first we'll be starting from the substructure activities where we are going to do the excavation quantity, the PCC quantities, and all. Right. So what I'm going to do is right now I'll teach you how the Excel sheet has to be prepared, and after that we'll try to take out the quantities. So whenever we try to take out the quantities, we require the structural drawings, isn't it? Now for the same building, this is a structural drawing what I have. So where you get all the footing details and all like F7, F8, and this is a complete table of that. Okay. And with the help of all these things, we'll try to take out the quantities for this entire building. So before that, if you remember, uh, we need to create a kind of Excel sheet, something like this, right? So unless and until we don't create a sheet, something like this, it is very difficult for us to do the estimation. So here I'm going to teach you how it has to be done. So you might be having a Excel in your laptop. So try to open it, okay? And once you open, this is a blank sheet what you get. Now, whatever may be your project, you just need to write the details there. Like I've written it here. See, I've written the client name, then I've written the name of the work, I've written the name of the project, what is the project number, and name of the consultant. So we'll try to write the same thing here. The first is a client name. So let me write the client name here. So start from here. Okay. So CLI client name. Okay. Client name is done. So once this is done, no, this part is coming out, isn't it? You just keep your mouse here and try to drag it in this way. Okay. Keep your mouse there and drag it in this way so that you can see this particular column has been separated. Once the client name is done, what is the next thing what we have? Name of the work, right? What is the work you're supposed to do here? So right here, name of the work, or you can even leave one space there, or not an issue. So name of work, okay? Or even you can write scope of the work. Anything is okay. Then we have name of the project. What is the project name? Okay, name of project. Okay, and then the last is a project number. Since this is the first project if you're doing, so you can start with project number. You can mention it as 1. But if you're working on a consultant, I mean if you're working consultant, and when you get a lot of projects, you need to give a separate number to that, right? In that case, you can keep on giving the number like 1, 2, 3, and 4. So the client name will start, I'll give a name, something like this. Maybe it's a Nayak residential. Okay. Client name is, let us say, Nayak. Okay. You can give anything. Let me see what name I had given it here. Yeah, Nayak Bungalow. I'll write here client name. So the client name is, let us say, uh, Satish Nayak. Okay, this is the name what I have given. He's a client name. What is the name of the work? So name of the work is civil and structural work. Okay, so civil and structural work. Okay. Next one is that name of the project. What is this project about? It's a ground story. I mean, it's a ground plus 2-story residential building. Residential building. Okay. Yeah, residential building. And after that, last one what you have is a project number. Since it's a first project, I'll make it as 01. Okay, done. So once all these things are done, next we need to add one more thing. What is that? That is called as name of the consultant. Okay, who is a consultant? Let us say if you are a consultant, you can even write it here, name of a consultant, or even you can do it here. Anywhere it's okay. I'll write it here, name of consultant. Okay, that is your company or whatever your company name you can write here. So I'll write here Kamath Consultants. Yeah, Kamath Consultants. Okay, done. This much thing you're done. Now it's not looking good, isn't it? You need to make it a bit colorful and the font and also look good. So what you can do, you drag entire thing in this way. Okay, come here. Now here you have a lot of different font. Okay, see if you keep it in this way, this also looks good. This looks good. I usually prefer keeping this particular thing. Okay, You can try whichever you want. Okay, this looks good. So this is what I have done. Next, we'll make this entire thing bold. If you want to make it bold, there's option here called as bold. Click on the bold. Okay, everything got bold. And now this alignment is not, it's on the side, right? I want to get it at the center now. So you select, see, whenever you want to do anything on the Excel, you just have to select everything, and you can see one option here. This is center point. Okay, the moment I do this, it will come at the center. Okay, this is how it is. If you don't want, then you can go with the this part also. This part also looks good, like client name, name of the work, name of the project, project number, and name of the consultant. What I can do is I'll yeah, it's okay, not an issue. Okay, and now this row sizes you can increase. Instead of this, I'll right click here. See, I'll keep here. I'll select everything. I'll right click. There's one option here, row height. Okay, select that. 14, instead of that, you can keep it as 20. So now you see that space has increased, isn't it? This entire space has increased. Now it's going to look good. Okay, then again, if you want to color this, you can do all those things. You can see here the color part. You can give a color something like this. Okay, it all depends how you want to do it. Okay, yeah. And then again, now individually I'm going to this thing, I'm going to put a boxes here. I'll click everything. I'll select this column. Come here, there's one option here, isn't it? Bottom border. Click on this part, and there's something called as all border. Click on this all borders. So now you see everywhere the border has come. So in this way, you can make it wonderful. And even if you want to increase the size of like, I'll select this. You can see the 11 number, isn't it? I'll increase that. Either you can select from here, or even you can click on this. See, you can click on this. So this is how it looks. Yeah, now it looks good, right? So in this way, you can try to do all these things. So once these things are done, next what you are supposed to do, we're supposed to start with the estimation work. Okay, now you can see the same thing I've done it here, right? Yeah, yeah. So we could have done one more thing also. I have given this thing, what is that, a column here. Otherwise I could have done it in a single name, like client name, that Satish should have come here only. That also you can do, like you see here. I'll not do that again. See, client name I've written Nayak Bangalore. No, what I've done, this entire thing I've made it as a single, this thing, what you call a column. Okay, you could have done in that way also, but not an issue. You can do in this way also, right? What I'm trying to tell is, instead of doing this way, I'll tell you, select everything, copy, I'll paste it here. Okay, and now let me, yeah, you can select this, Control C. I'll give a space. I'll put Control, yeah, Control C. Okay, this won't work out. Let me Control C. Yeah, it will work out. Okay, I could have done in this way also. In single column, I could have written everything instead of giving a row to that. This also would have looked nice. So if you want to do that quickly, I'll do that. Okay, it will take time now, but it's okay. You can do in that way also. I'm selecting everything, and let me paste that here. Okay, and then this thing, Control C, Control V, Control C, Control. Okay, I'll write this one only, 01, and this thing. Yeah, you can see this is how it has been done. Now, if you don't want this, no, I'll delete everything. Okay, and now what I can do is I'll merge everything. I'll select this. I'll say merge at center. Let me try to do that. Okay, it won't work out. Not an issue. I'll take out all these borders again. See, now you put this border, isn't it? If I don't want that, again, you select everything in this way. This way you select everything. Okay, go back here. This option called as no borders. Select on no borders. All the borders will go now. Okay, and now I need to shift this. I'll select this. Let me say Control C, and let me go with Control V. Yeah, it works out. So again, this part I don't require. I'll delete it now. And now this, let me drag it in this way. Okay, and this border is not required. Select here, no border. Okay, even this also no border. Okay, everything is gone. Now it looks good. Now if you want, you can drag it in this way. Try to drag it, or you can increase the size. Okay, so in this way, this is how your entire thing is gonna look. Okay, looks great. So in this way, you first create such kind of report. I mean, this is how you are supposed to do it. Once this is done, next we'll start with the this part, that is a measurement sheet. Right now, whatever estimation I'm going to do, takeoff quantities, what I'm going to do, it will be a measurement sheet. We call it as a MS or measurement sheet. So let me write down that. I'll start from here. Okay, so I'll write here. Okay, this. Okay, we'll do one thing. Hmm. Yeah, now we'll start with the measurement sheet. I'll write it here, measurement. Okay, measurement sheet. So you also can do the same thing along with me. So I've written a measurement sheet here. After that, what all things I require? One is serial number. I require item description. I require unit, number of members. Then I require length. Then I require width or breadth, depth or thickness, quantity and total quantity. So this is a format you're supposed to follow. So you'll quickly note down all these things. So again, I'll start from here. So again, if you want to make this bold, what you're supposed to do, okay, see, now it's not looking good, isn't it? What I can do, I'll try to merge this much cell. I selected that. I'll go to this part called as merge at center. Okay, now what has happened? This entire row has become, I was saying, one single row. Okay, I mean, this entire thing has become one single column. Now I'll select on that. I can make it bold. I can increase the size of that. Okay, and now if you want to change the font, you can keep it this measurement sheet or whatever you want. No, you can follow that. This looks good. Okay, I'll keep it as measurement sheet. Okay, it's looking good. And then if you want to give a kind of a color, you can give it something like this. It all depends on you what kind of arrangements you're supposed to do. Measurement sheet. And then if you want to give a border to this, select here and click on this. There's one option which is called as thick outside border. Click on that. Now it looks good. Now if you want to change the color of this measurement sheet, click on that. You can see this A, and here you can make it as a red color measurement sheet, yellow or whatever. I'll make it as yellow color and let me increase the font. Yeah, this looks great. Okay, fine. Now we'll start from here. What is the first thing? Serial number. Okay, serial number. Then we have item description. Item description. Then we have units. So this will uh, do in this way. Then we have units. Okay. After that, number of members. See, you can follow anything. If you're following something else other than what I've written, you can even follow that, not an issue. But this is a standard format, what you can follow. Okay. There's no hard and fast rule that you have to follow the same thing what I'm giving. Number of members. Then comes your length. Then comes your length. Yeah, leng length. So always the length, you mention what is the unit you're supposed to follow. You're following the meter part, so I'm writing meter there. Okay, then I require width. So again, width, sometimes we use the word width, sometimes we use the word depth, not sorry, breadth. Okay, so you write both the things, so there is no confusion. And now see, now what has happened, this has come outside, isn't it? Come here, select this and then drag it. Again, you write the unit here, open the bracket, write meter and close the bracket. Okay, this looks good. Again, increase that size. Then the next one is depth. Again, depth or thickness, because if you're doing it for the column, it will be a depth. But if it for PCC thickness and all, it will be thickness. So I'll write both thickness also. Again, that will be in meter or mm. But here we'll write in meter only. Okay. So again, this okay, thickness, and this you keep it as capital meter. Done. And then the last part is quantity and total quantity. So quantity is for the single unit. Okay, quantity means for the single unit. quantity. So quantity will be, okay, quantity. And then the last one is a total quantity. Total quantity. Quantity. So once you prepare this, no, it's enough. Okay. Initially, it will take some time, but it's okay. So done. Now it's not looking so great, isn't it? Even though you have done it, it's not looking great. Now you can try to decorate it. How do you try to decorate that? Again, very simple. Select everything first. Once you selected, try to make it bold since it's a heading. Then come here. You can increase the. You can keep the font the way you want. Again, I'll go with this. Yeah, this looks good. I'll go with this Arial Unicode MS. You can go with anything. I'll go with this. Okay. And now you see this part again. I need to, yeah, drag it, quantity and total. Now it's looking good. Again, you see everything is not at the center, isn't it? This one is at the left. This is at the left and all. So now let me bring everything at the center. I selected everything. Again, there's one option here called as center. Click on the center. Now you can see everything has come at the center. Again, will increase the size of this so that it looks good. Now you see the moment I'm increasing the size, no, everything is disappearing, isn't it? It's going inside. So you have two options. One option is you can increase the row height. Otherwise, you select this. There's one option here called as wrap text. You can see it here, wrap text. Actually, what happened? You see, I'll select everything. I'll decrease the size now. When I'm decreasing the size, everything is coming in a single line. But when I'm increasing the size, what is happening? Everything is going inside the column. So what if such things happen? You select everything, and there's one option here called as wrap text. Click on that. So now you can see how it has come. So this way you can try to keep it. Now again, this is not looking good. Try to drag it so it will come in a single unit. Try to drag it, it will come in a single unit. Again, try to drag it, it will come in a single. Now everything looks good. Now again, click on that and try to make it center. It's already at the center. Yeah, now it's okay, right? This looks good. If you don't want to do it in this way, no problem. You can even select this thing you do, and then let me try to increase the row height here. Row height, already it has gone to 23. What will happen if I do 30? No, it won't work out. Okay, so that is the only option that you have to go for the wrap text. Else, otherwise you decrease the size or you can do the wrap text. Okay, I'll keep it in this way only. It looks great. So once this is done, we'll give a border to everything. I'll select this, and you can see this part come here. There's one option here, thick outside box. So in this, what will happen? Only the outside part will get a border, whereas this inside we are not getting any border. So again, click everything, select. There's one option here called as all borders. Click on all borders. Now what has happened? Everywhere the border has come, isn't it? This looks good. Now you can do one more thing, because anyhow entire thing we are going to, okay, we'll do that later, not an issue. Okay, this much is understood. Whatever I had done it here, no, the same thing you can see, everything has been replicated, right? So this is a basic sheet that you're supposed to follow. And after this, we'll try to do out all the quantities one by one. We'll start with the excavation, the PCC, and all those things, right? And this part you can increase a bit, so that because I need to write it later, the earthquake excavation and all. So you can increase the size of this, okay? Yeah, rest all things good. This much, and this part you can bring at the center now because it has gone to the corner. What you can do, select this. Again, you say this part, this, I'll bring it at the center. What I can do is, yeah, uh, I'll select this. I'll bring at the center this part. Okay, let me try. Yeah, I brought at the center. Uh, hmm. I can keep it here. I can keep it at the center also. Yeah, now it's okay. But this entire thing is not required. I'll change the color. I'll put the color black to, this white looks no fill. We'll go with no fill. No fill means no color will come. And now it's okay. Again, this, let me unmerge it. If I want, I can, okay. Okay, no problem. We'll keep it in this way. Not an issue. Okay, this looks good. Okay, okay, this fine. Measurement sheet, and this part is looking great. So I hope up to here you are able to understand how this Excel sheet has to be prepared. Try to prepare up to here, and from the next lecture we'll try to do all these excavation quantities one by one. Okay, so I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you. Hello my dear students, welcome back to the lecture. So here we'll try to find out the excavation quantity for the footing. Okay, so before we start that, we need to write down the names of the footing, isn't it? See, this is a structural drawing what I have. So it's a foundation layout. So here everything is mentioned, like this is F1 footing, then this is F6 footing, F8, F3, 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 F2, and so on. Okay. So this is one way. Other way is that you can find the size. Like size is not mentioned here. For the size, you have to refer the table. Okay. So the same thing they mentioned it here called as schedule of tape footing. In that again, the serial number is given. Name of the footing they have written like F1, F2, F3, and so on. And how many F1 footings are there, that is also written. And the size of the footing is written. Now, what we are supposed to do is we'll write the same thing in the Excel sheet for our understanding. Otherwise, every time I have to come to the AutoCAD and do that, which is practically not possible. Okay. So first, what we can do is directly we'll write the name like F1 footing, this particular size, that is 1200 by 1200 by depth also I can write there, which is 400. Okay, 400 So what you can do, I'll do one simple trick now. I'll go to the Excel sheet and I have to write it here. Okay, like item description. The first one is a excavation quantity. Okay, excavation, uh, yeah, quantity. Excavation quantity. This is the first item what I have. The same thing I written it here. So you can write here like earthwork in excavation. That also you can write. Instead of writing excavation quantity, you can write earthwork in excavation. Right, earthwork in excavation, and I'll bring it at the center. This is my center, and then you can increase, you can change that, increase the size of that, and then you can make it as bold. Okay, so this is my first quantity. I'll write serial number 01. I've written 01. We can bring at the center also. So this is at the center. Now this is that quantity. I mean, this is the main heading now. Under that, I have to write F1, F2, F3 footings and all. Okay, so quickly, let me write that. Now, every time I'm going to write it here, it's difficult, isn't it? So what I can do, the best practice, what you can do is go to this again. You take a screenshot of this. Screenshot in the sense, you have to click the shift. Let me do that. Yeah. Okay. Okay. What you can, yeah. So what you can do, shift, then the window page and the S button you have to click. Okay. I'll take a screenshot of this so that it is easy for me now. I'll click. Okay. I selected that. I'll go to the Excel and I'll say Control V. So I'll paste it here. So now it is easy for me to, look here and directly do the input here. I'll repeat that once again. You go to the AutoCAD. Okay. So here, see your two options. Otherwise, you can go to the search option. There's one option called a snipping tool, SNI. Click snipping tool here. Click on that snipping tool. It will open up. Okay. And go to this option called as new. Select on that. Now this, the screen will get freezed. And now from here, you drag your mouse in this way. Okay. So once you drag in this way, done. It will be selected. You say Control S here. Keep your mouse and say Control S. So once you do Control S, this is not required. You don't have to save this. Directly come to the Excel and you paste here Control V. You can see it has got pasted here. So this is what you can follow. So that now quickly, okay, I'll do that now. Yeah, I'll do it here. Okay, I'll start from here. What is my first footing? F1 footing. Okay, and what is the size of that? See, size, I'll write in this way. Length is 1200, breadth is also 1200, and depth is 400. So you can write like 1200 cross 1200 cross 400. Okay, F1 is done. Similarly, go for F2. Similarly, go for F2. Again, what is the size of F2? Again, it is 1400. For multiplication, use this multiplication. Use the X symbol on your keyboard. Okay, X. Okay, 1400. Again, this is also 1400, and this is 400. Okay, so it will take some time, but you try to do the Excel sheet on your own. I won't be sharing my Excel sheet because this is my second course on the quantity estimation where I want you to have a hands-on experience on this. So that is why I won't be sharing my Excel sheets. You have to prepare your own Excel sheet so that when you go for any interview or when you get a job anywhere, they'll definitely ask you to prepare all these Excel sheets on your own. Okay, there won't be anyone to help you out, or there won't be anyone who will come and do this Excel sheet on behalf of you. It is you who have to do all these things. That is why I won't share my Excel sheet. Okay, you have to prepare on it. It will take time. That is why I'm doing right in front of you, and I'm not missing anything here. Okay, I reached up to F5, then I'll go F6. So for F6, he has written see the plan. I'll come to the F6 part later. I'll go with F7 now. Okay, go for F7. Again, it is 1300 cross 1300 cross 400. Next, F8. So F8 is yeah 1550 plus 1550 and multiply by 400. And the last one is F9, isn't it? The last one is 1100 cross 1750 cross 400. Done. Everything is done. F6 is missing. What they have mentioned for F6, you have to see the plan. So maybe it's a kind of a irregular footing, or it may be a rectangular footing. In that case, they will write in that way. They have written C plan. No problem. I'll go to the plan part. So this is my F6 footing. Okay. So you can see it here. This is F6. They're not given the size. So since I'm using AutoCAD, I'll go to this option called as, you can see linear, or there's one option called as dimension. You click on this dimension and you select the dimension. See, already it is showing 3000. I can select from here to here. Okay, and I'll drag my mouse down. So this is 3000. In the same way, I need to check this part also. So in AutoCAD, you can go back to the same option called dimensions. Otherwise, make use of a space bar. Okay, the big button what you have on your keyboard, it is called a space bar. Whenever you click a space bar, it will take the previous tool what you have taken. We took the measurement one, right? Again, I'll click on the space bar. Again, directly I'll keep my mouse here. I'll keep my mouse here also. I'll bring it here. So it is 3000 by 3000 is your size of your footing. Okay, that is how it is. Otherwise, even they have given a dimension here, 1900 plus 550 plus 550. 550 plus 550 comes out to be 1100. 1100 plus 1900 comes out to be 3000. Again, 2000 plus 500 plus 500 comes out to be 3000. So size already I've got from here. So what I'll do, yeah. So what I'm going to do, I input the same size in the Excel sheet now. Go back to the Excel sheet. So my F6 footing is 300 cross by 300. Sorry, 3000 cross by 3000. And what is the depth? Depth part is already mentioned, no? Depth is 500. So write it as 500. Done. Got it? So all these things are done. This is no more required for me. I can delete this part. Okay. I'll say delete. I'll click on, I'll delete. Now again, it's not looking good, isn't it? I'll select everything. I'll bring them at the center. This is at center option, bring them at the center. Then you can make it as a bold. And if you want to change that, this thing, font, you can go. I'll go with this part. Okay. Now it looks good. If you want to increase the size, increase the size. Okay. Now it looks good, isn't it? Now, coming to the units part. What is the units of the excavation? Always the excavation units will be done in cubic meter, because you have a length, you have a breadth, and you require a depth. So it comes out to be in cubic meter. So I'll write cubic meter as CUM. CUM means it's called as cubic meter, or even you can write meter cube in this way. Okay. You can write, you can write yeah, you can write meter cube. How do you write that? M, and to the power you have to write. So for the power, you can write in this way. Okay. Otherwise, you write it in the word format and you can bring it here. So both the way you can write. Either you write CUM cubic meter, or you can write this as cubic meter. Okay. One and the same, doesn't matter. So once you've written that, I'll write only CUM. It's understood. Okay. CUM is understood. I'll select that and then I'll drag it in this way so that everywhere it will come. You can see. Again, I'll do it. I've written for one. I'll click here. Okay. This particular portion and drag your mouse. Now you can see everywhere cubic meter has come. Again, this has gone to the side, isn't it? Select everything and then bring it at the center. See, you can do it now in this way, or once everything is done, then also you can follow that. It all depends on you. Okay. Now coming to the members, this is very important. What is this number of member? Like F1 footing, how many F1 footings are there? For that, again, I'll go to the AutoCAD plan. So you have two options. If you're lucky, few people mention that here. Like you see, numbers this guy has mentioned. Like F1, there's one number. F2, there is three number. F3, there is four number. F4, there is two number. F5, 3. F6, 1. F7, 3. F8 3, F9 1. That means F9 1 footing is there. F6, F7 3 footings are there. So not all the structural consultant are going to mention all these things. In that case, as a quantity surveyor, we're supposed to come and do the checking here. So right now I'll do that for you. Okay, I'll start with F1 footing. So now see, whenever you're trying to find, no, you have to follow one pattern. Either you start from left to right, or you start from right to left. Okay, that is what you cannot randomly go like F1 is one F1 is here, okay, second F1, that you cannot do. You start from the bottom left and go in this way, left to right, left to right, you go left to right, from bottom to top you go, or you start from the top and come to the bottom. It all depends on you. We'll start from the top only, not an issue. I'll start from the top, first footing, from left to right I'll go. Okay, I want to find F1 footing, how many numbers are there. You see, this is F7 footing, this is not required for me. Next I'll come to the next footing. This is F8, this is also not required. This is F2, not required. F9, this is also not required. Again, once see, left to right are done. Next I'll come here. F7, not required. Okay, here there is nothing. Next I'll come here. F3, F5, F5, this is also not required. Then next is F7, F8, this is also not required. Then F2, F4, F5, F4, not required. Why? Because I require F1 footing, no? F2, F3, 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 this is also not required. Now you see here, is one F1 footing, no? So this is one F1 footing, count it. But here, this is F6 footing, this is F8 footing, done. That means in the entire plan, only one F1 footing is there. That is why this guy, the person who prepared this drawing, he has given 1. So now what we'll do in the Excel sheet, we'll do the same input here. I'll say 0, 1. Okay. Now I'll go for F2 footing. Again, for F2 footing, come here, come to the F2 footing. Again, see, by default, this guy has written 3, but we'll count it. Okay. I'll teach you for 1 or 2. Rest things you do it. I'll be sharing this AutoCAD file with you. You can practice it. I'll search for the F3 footing. Again, same thing. Start from the top left. F7, F8, F2. Okay. F2, there is one footing. Remember, 1. Otherwise, yeah, 1. Next, this is F9 footing, not required. F7, F3, F5, F5. Again, F7, F8, F2. So 2 footings are done. 2. Okay. F4, F5, F4. Again, another footing is there. F2 here. 3 are done. Rest all F3, 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 F1. This is F6, F8. That means this entire plan, there are 3 F2 footing. That is why the same thing was mentioned here. 3. So what I'm going to do, I'll go to the Excel sheet. I'll say 3. Got it? So in this way, now you take a small assignment. What you do, I'll be sharing this plan with you. You try to count everything and you then come and input it here on your Excel sheet. But now, in order to save the time, I'll copy the same thing from here onwards, because I don't have to waste so much of my time in doing all those things. So I'll copy from here. Okay. But let us verify for F3 footing later. Again, I'll copy this. So what I can do quickly, yeah, again, I'll take this screenshot. Okay. So that it is easy for me. I'll go to the Excel. I'll say Control V. Now directly it is easy for me, no? Yeah. F3 how much? 4 is there. F4 there are 2. F5 there are, yeah. F5 there are 3. F6 there is 1. F7 there is 3. F8 there is 3. And F9 there is 1. Done. Easy, simple. I'll delete this now. Okay. Now, yeah. Yeah, this is done. Up to here, your concepts are clear. Now let me verify for one footing. Quickly, I'll verify for one footing. I'll go with no. I'll verify F3 footings. F3 has mentioned 4, no? I'll quickly verify F3. Okay. Is there any F3 footing here? No, there is no F3. Here, yeah, there is one F3. Again, there is no F3 here. There is another F3 here, 2. Another F3 here, 3. Another F3 here, 4 are done. Okay. Then is there anything? Yeah, F1, F6 and F8, nothing. So there are 4 F3 footings. That is why the 4 has come here. Very simple. Try to do it on your own. Up to here, your concepts are clear. You can even bring this at the center. Okay, bring at the center, no problem. Yeah. Now coming to the length part. See, for the length part, what you're supposed, this is a footing size, but we are trying to find the excavation quantity. You can make it in a different color to separate it from that. I'll keep it in blue color. Okay. And let me make it a bit bold. Yeah, excavation, earthwork in excavation. So I require the length now, isn't it? So this is a footing side, but whenever we do the excavation, I always told you that we have to take a PCC offset, and we have to take the working space, and then we have to measure the length. Similarly, for the width, we are supposed to do that. Okay. So in the next lecture, I'll explain you with the help of a photograph how this length, the width, and the depth has to be taken care of, and then we'll try to find the entire excavation quantity for this footing. Okay. Try to prepare the Excel sheet up to here, and also try to complete this particular thing without copying from here. Try to manually count the number of footings from the AutoCAD file, and try to do that. Okay. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So here we'll try to understand what is the working space all about. Okay. See, now whatever we had seen, no, the footing size and all, this is actually the footing size. This is the size of the footing what we had, F1, F2, F3. But excavation quantity is not this one. For the excavation quantity, you need to add the PCC offset. So this is a PCC offset. Okay. So this is your PCC. I'll show you what is exactly the PCC. And after that, we'll add something called as working space. So this is my working space. Okay. That means what I'm trying to tell, I'm actually supposed to find this particular size. I'm supposed to find this particular length from here to here, and I want this particular breadth. Okay. Then how do I find that? For that, you're supposed to add this additional working space on both the side. I mean the PCC offset, and then the working space from this side and also from the this side. Okay. That means you can see, this is a footing size what we have, but you can see a kind of a PCC which has been put up. So this is that extra portion of PCC on all the four sides. And after that, this much is a working space. This much is working space. First question, how much should be this PCC offset? How much should be this PCC offset? For that, you have to go back to your drawing, and I'll delete this. So this is my cross section of the footing. Whenever you refer any structural drawing, you get such kind of cross sections here. Okay. Now you observe here. Other things I'll explain you later. So this is a footing what I have. So this is a footing what I have. Okay. This is that footing. Now below that you put a PCC, which is called as plain cement concrete. Okay. Now from here to here, there's some extra space. From here to here, there is some extra space, isn't it? Okay, see, actually, to put it in a better way, the same part will come down. This much part will come down. That is okay. This much PCC is already there. No portion, no problem. But there is something extra, no? This is extra portion what we are taking care of. From here to here, this is extra. From here to here, this is extra. This will be on all the four sides. Since we are seeing a cross section, only two side I'm able to see. How much extra is mentioned? See here, 50 mm from this side and 50 mm from this side. Okay, so this is mentioned here. 50 you have to take extra. That is called as PCC offset. So now I'll go back to this drawing again. Okay, so this extra, I'll take it out. Okay, this extra what is mentioned, no, that is 50 mm. I'll write 50 here. Is it okay? 50 from here. Okay, and this is also 50. Got it? Okay. Next, after that, this how much it is? How much should be this distance from here to here? It is not mentioned in the drawing. From here to here, it is not mentioned in the drawing. Okay, so actually these things will not be mentioned in the drawing. So if you refer CPWD code book, I'll write here, that is Central Public Works Department. Okay, it is mentioned there. You can take 300 mm as a working space. Okay, you can take it as a 300 mm as a working space. Okay, so this thing won't be mentioned in your drawing. Again, this will be written in your BOQ, or you can, if it is written in your BOQ, it's well and good. If not, you have to refer CPWD, and it is mentioned 300 mm, and you can take it as 300 mm. But on your site, if your site manager says will take 150 or 200 mm, then you can consider 200 mm and you can do the calculation. But the standard what you're supposed to follow is 300 mm. Okay, great. Now this 300 mm is a working space. So this much space you can see here, no? This space, and this is called as working space. Why it has to be given? For the very same reason, when we do this footing and all, no? I'll show you one image. Yeah. Yeah. See, these people have put up the shuttering, isn't it? But the working space what we took, no, this is that 300 mm. You can see from this shuttering, This was 300 mm. From here also we took 300 mm. On this side also it will be 300. On this side also it will be 300. Okay. So why this is called as working space? So that these laborers, when they try to put the shuttering board for the footing, no, they need space to stand, isn't it? So it's called as working space. Second thing, when you're putting this shuttering, you need to support that. You have put up a props, the wooden bullies and all. Again, in order to support that, you're supposed to give a space, no? Hence, it is called as working space. You can see how the support has been given, no? So it is called as working space. So how much it has to be taken? 300 mm. That is why we are going to do. Because when we do the excavation, we need to mark the same thing on the ground, and then only excavation will happen. Excavation won't happen only up to your footing size. Okay, but footing will happen to the footing size only. Footing will be only this much portion only. But this additional space, we are going to do the excavation. This much is clear. See, all these things I have covered in my site engineer course and all. Okay, you can learn from there also. The same few things I've explained there also. Okay, in this way I've explained you all those things, how it has to be done and all. This much is clear. So this is how your excavation will be done. Okay, now we'll quickly do the calculation. I hope up to here your basic concept is clear. Now how we are supposed to do that? Yeah, yeah. Okay, now this much is clear. No, quickly I'll do all those things now. Okay, this won't work out, no problem. I'll quickly do it. Okay, yeah, this part. Okay, so I told this will be 50 mm. I'll quickly write 50 here. Okay, this also will be 50. It is there in the drawing. This 50 will be written in the drawing, whereas the working space 300, you have to assume it 300. This is also 300. Okay, so this is same on all the four sides. On this side also it is 300. Here also it is 300. Okay, and this PCC offset is 50 here also, 50 here also. Okay, this much is clear. Now we'll take one footing and I'll explain you for that. I'll take one footing. The footing size is 1200 by 1200. The length is also 1200. The breadth is also 1200. So what we can do now, I'll write this as 1200 by 1200. So this is 1200 and this is also 1200. Now quickly calculate and tell me what will be your excavation length and breadth. So I'll quickly have to add everything. Okay, this is 1200. I'll add 50 from the left side. I'll add 50 from the right side. 1300 plus 300 on the right side I'll add, it comes out to be 1600 plus 300 on the left side, it comes out to be 1900. So quickly I'll write it here. It will be 300 from the left side I'm starting. Okay, plus 50. Okay, plus 1200 plus 50 again and plus how much? 300. So try to do it. You should have a calculator with you when solving these things so that we can manually verify. 1200 plus 300 plus 300 plus 50 plus 50. Yeah, 1900 I'm getting. Okay. Remember this answer. We'll do the same thing in the Excel sheet. So since my length and breadth is same, this is also 1200. This is also 1200. Here also I'm going to get 1900. But still we'll do the calculation on the breadth side also. Again for the breadth side, it will be how much? I'll start from here. See, this is 300. This is 50. This is 1200. Again, this is 50. And from here to here, it is 300. Right? I'll write it here. Again, it is 300 plus 50 plus 1200 plus 50. Okay, 50 plus 300. Obviously, it will be how much? 1900 mm. Done. So in this way, you are supposed to do it manually so that you get an idea. Okay, this much is clear. The same thing we'll do on the Excel sheet now. Okay, I've explained you for one footing. Same thing you have to follow here. Now, whenever you input that in the Excel sheet, no, always remember, come to the length part, you have to make use of a equal to sign. Okay, otherwise your Excel sheet won't work out. You can see this equal to sign. You have this on your keyboard, click on equal to. And now what we'll do, we'll first write PCC offset. What was that? I mean, working space will start 300, okay, mm plus 50 plus 1200 plus 50 plus 300. Agree with me? Click enter. How much it's coming? 1900. But what has happened? I've written here meter, but the value what I've input is in mm, right? So what you can do quickly, I'll change it. Instead of this thing, I'll put it in meter only. So 300 mm comes out to be 0.3 meter. plus 0.05. Okay, 50 mm in terms of meter is 0.05 plus how much it is 1200 in terms of meter is 1.2 plus 0.05 again plus 0.3, and now you click enter, you can see 1.9 has come. Okay, similarly on the width also you have to follow the same thing. Now you can again do the same thing, that is again equal to sign, that is how much 0.3 plus 0.05 plus 1.2 plus 0.05 plus 1 plus 0.3. Okay, plus 0 point and hit the enter button, you get 1.9. Got it? So this much is clear. So I did it for F1 footing. Similarly you have to do it for F2, F3, F4 up to F9 footing. You're supposed to do it. Yes, it's a bit tedious task, but you don't have option, you have to follow the same thing. Okay, quickly we'll do that. Again I'll quickly do that. Again there is one more thing what you can do. No, see here. Now for example, let us say your site manager has asked you for the quantity estimation sheet. Okay, so then you gave it to him, then you are directly written 1.9 here. Now maybe someone doesn't understand what is this 0.3, someone doesn't understand what is this 0.05. In that case what you can do, you click here, right click, and there's something called as new note. Okay, new comment, click on the comment. Okay, and not comment, let me, yeah, right click, new note. Yeah, there's something called as new note. Here you mention that 0.3 is working space. Okay, and then your 0.05, this is your PCC offset. See, it's not mandatory to write, just in case if you want to write, you write it. Done, I've written. Now if I come here, no, see, the moment I keep my this thing, what is that, uh, mouse, it's showing me what is this 0.3 here. If somebody comes and clicks here and is not able to understand what is 0.3, he can keep his mouse here and 0. Okay, now he understands. Okay, 0.3 is a working space and 0.05 is PCC offset. Same thing you can do it here also. If you want, you can add it, not an issue. Okay, now we'll do for F2, F3, F4, F5 and all. Okay, quickly we'll try to do that. What I'll do, no, I'll use a very simple trick. Since you have understood this, I'll use a very simple trick. The simple trick is that, see, this 50 mm offset is common for all the footing, F1, F2, F3, and 300 mm working space is also common for all the footing. I'll try to add everything, that is 0.3 plus 0.05 plus 0.3 plus 0.05. Okay, try to add it and tell me how much is the answer you're getting. So it is 0.3 plus 0.05 plus 0.3 plus 0.05. So we are getting 0.7. So this is 0.7. Now 0.7 is constant, no? So what you can do, instead of writing this every time and wasting your time, like, every time you write 0.3 plus 0.5 and all, not required. Directly you take the footing size, say equal to sign, footing size is 1.4, and directly add 0.7 to that. Enough, done. Got it? Same thing you do it here also. You can make use of plus sign also. Again, what is the footing size? 1850 is your length. So 1.85 plus 0.7. Done. Okay. Yeah. Okay. Yeah. Next here also. Again, equal to sign 2 plus 0.7. Okay. Next, how much? 2.25 plus 0.7. You're able to understand? So in this way, you're supposed to do it. So always you should do smartly and also correctly. So that is why first step I told you how it has to be done in a better way. This is this one. Now you do it in a smarter way. Instead of writing every time 1 point plus 0.7, done. Again here 1.55 plus 0.7. Okay, so it's easy. Again 1.1 plus 0.7, done. Yeah, now again here again you can write the same thing, but since your length and breadth both are same, here also 1850 1850, 1400 1400, you can even select this and drag it in this way. Same thing will come. Okay, you can see here. See what I did, I'll do it for this also. Now you see my F3 footing length is 1850 and breadth is also 1850. In the length part I've written, in the breadth part again I need to do the same calculation, right? Equal to 1.85 plus 0.7. Instead of doing that, select this part and drag your mouse on the right side. Same value will get copied here. Okay, again you can do this, but it will not work out in all your projects, because sometimes your length and breadth will be different. Since here every time the length and breadth is same, you can copy this. Okay, I'll do the same thing for here also, because it is 2000 by 2000. I'll copy the same thing. Again, this is also same, I'll copy the same thing. Okay, this is also same, again I'll copy the same thing. Again 1300 by 1300, this is also same thing, I'll copy the same thing. But here again 1500 by 1500, I'll copy the same thing. But here it doesn't work. Why? Because your length is okay. This should have been, no, we did one mistake. What I can do is I'll make this as 1750, and this is 1150. Okay, what is that? See, always remember, whenever you are writing this table, no, this table, the length part should be more compared to your breadth. Okay, so the length should come first, followed by your breadth. So this should be actually 1750, 1750, and this should be 1100. Okay, 1100 breadth. Okay, and in the Excel sheet also you write it in the same way. So now I'll change this I'll write it as 1.75. Okay, and this I cannot copy. Why? Because my length is 1750 and breadth is 1150. So for this I'll do the calculation. Plus 1.15 plus 0.7 I'll do. Done. I got 1.85. Got it? So my length is done, breadth is also done. Now if you want to make it bold, you can do it. Now coming to the depth or the thickness part, we are trying to find the excavation quantity. That means I want to find this height now. This particular height is what I require from here to here. This height I require. Okay. So how do you find this height? Again, you have to refer your structural drawing. I'll go to my structural drawing here. So this is my structural drawing. You can see here, this is your structural drawing. Okay. Now you can see something written here, NGL. This is your natural ground level. What is this natural ground level? See that in the picture. Okay. So see that in the picture. So this is your natural ground level. Wherever your soil is there, firm soil is there, from where the excavation has happened, that is called as your natural ground level. Okay. So in the cross section, it is showing that from the natural ground level, you have to do an excavation of how much? 2500 mm. Okay, but where it is up to the top of the PCC. See, this is your PCC. Okay, this is your PCC. Your this 2500 is from natural ground level up to the top of your PCC. But whenever we do the excavation, this is my complete excavation. I have to do the excavation completely, and after that only PCC will come. But in my drawing, what has happened? These people have given me the drawing to the top of the PCC. That means my actual requirement is from where? My actual requirement is from the natural ground level to the bottom of the PCC. But these people have given up to how much? Up to the PCC top. That means that means I need to add this thickness of the PCC. Whatever is my thickness of PCC, that I need to add to 2500. How much is your thickness? It is mentioned here. See, 50 thick PCC. That means 50 mm is the thickness of your PCC. So I'll add 50 mm to the 2500. Try to do it manually. 2500 plus 50. Okay. So it comes out to be 2550. So 2550 mm is the excavation depth you're supposed to right there. Okay, this much is understood. Let me verify. 2500 plus 50. Yeah, 2550. This much is understood. Always remember, excavation will happen from the natural ground level to the bottom of the PCC. So in some drawing, they'll give you directly up to the bottom of PCC. Then you don't have to add your thickness of PCC. In some drawing, they'll give you up to the top of the PCC. In that case, you're supposed to add the thickness of the PCC. So always check your drawing correctly, and then only we'll proceed. I'll give you 2-3 different assignments where we'll have take care of all these cases, so that you'll have a hands-on experience on that. Okay. Now it's very simple. The depth or thickness, I'll directly write it as 2.550. Written. I wrote it for one footing. So for all the footing, it remains the same. I'll drag it in this way. Okay. Got it? This much is understood. Again, I'll bring this at the center part. I'll bring at the center. Okay. This much is understood. Again, remember, this thickness what is mentioned for this particular footing, for this particular building, this is a typical. That means for all the footing, the excavation is 2.55. Okay, but this may not be same with all your projects. In some projects, what will happen? this much part, let us consider in some projects. See, I'm taking all the worst conditions which will happen. In some projects, it will happen that from here to here, your footing depth will be 2.5, your excavation. And this much footing from here to here, it may be up to 3 meter. So in that case, you have to check your cross section properly. In that case, what they will do, they'll give you cross section 1 and they'll give you cross section 2. In that case, you have to take care of this, and accordingly, you have to fill your Excel sheets. Okay. Why that variation will happen? Sometimes what happens, maybe in this particular area, some other structure may come which is having a more load. Because of that, your depth of excavation may increase. So that is the reason, in some projects what will happen, one side will have one depth and other side will have a different depth. Okay. So it all depends based on the projects, but you have to take care of all these things. So whenever you do this thing estimation, you try to understand how the entire drawing is given, and then only you proceed with that. Okay. Yeah, I think this much is done. So once these things are done, next I'm supposed to find the quantity. How do I find the quantity? So it's the excavation quantity. I need to multiply the length, the breadth, and the depth of my excavation. So I'll write equal to sign. What is my length? Length is how much? 1.9. Multiply, use the star symbol. Okay. Breadth I'll multiply this by thickness, and I'll give enter button. Okay. So I'll give enter button. So this is a total excavation quantity, that is 9.2005 is coming. So I'll click here. Okay, I'll do that later. Okay, this much is coming. But again, what we did, this I did for how many footings? Is only one footing. No, I need to multiply this also. Okay, so actually what I should have done, again you do this, you multiply this by number of member is very important. If you don't do number of member, no, you'll miss out. Okay, so when I'm linking this number of member, I say enter. Now also it becomes 9.20, 9.2055, doesn't matter. Okay, done. Similarly, do it for this F3 footing. I'll do for F3 footing. Okay, yeah, check this particular column. I'll do how it has to be done. Yeah, equal to sign, take the length, that is 2.55, multiply that by 2.55, multiply that by depth. Okay, this is also 2.55 here. Okay, fine. And now you multiply this by number. This is important. If I don't multiply this by number, it will do calculation for only one footing. But F1, F3, how many footings we have? F3, we have 4 footings. So I'll multiply this also and I'll say enter button. Now you can see 66.3225 answer has come. Now you don't have to do for all the footings. One you're done, no? Keep your mouse here and drag it in this way. Okay, once you drag it, no, everywhere the answer will come. You can see I didn't do the calculation for all the footing. I need to do for one, and then drag your mouse. I'll do it once again. See, keep your mouse here and you drag it in this way. Okay, you drag it, all the answers will come. But again, you can see after the decimal is lot of this thing, no, 9.9055. We don't require all those things. Then what you do is select everything, and then there is one option here. You can see this one, decrease decimal. Click on this. Yeah, after the decimal we'll keep 2 units. Okay, that is 30.60, 38.730. It's understood. Okay, if you want to increase, you can increase from here. See, increase decimal. In this way you can increase. If you want to decrease, no, select this option and decrease. Okay, we'll keep 2. Now it's done. Again, it has gone to the side. No, again I'll click on this. Yeah, I did one mistake here. Okay, let me bring it to the center. I did one mistake. The mistake is that, see, in quantity, no, actually we are supposed to do length, breadth, and depth. What I did, I took the number also. So in total quantity, it doesn't make any sense. So what I'll do, I'll delete this. Okay, what I'll do, no, equal to take the length, take the breadth, and take the thickness. Okay, fine. Now you drag it. You don't have to multiply the number of members. In quantity, we'll find it for only one quantity, single quantity. Okay, now I'll drag it in this way. Okay, sorry for that. Okay, yeah, now it's okay. So in total quantity, what you do, total quantity, come here, equal to sign, quantity, you multiply this by number of member. Now you'll get the total quantity. Now it is good. Okay, again you change this sign, I mean this decimal point, we'll change it later. Again, you don't have to do it for everything. Okay, just tell me how you are going to do it for F6 footing. You tell me for the F6 footing. So this is my F6 footing. Okay, tell me how it has to be done. So how you'll do? Equal to sign, exactly, equal to sign 34.91, that is single quantity. You multiply this by how much? Number of member. Okay, wait, we'll not do for F6. F6 doesn't make any sense. I'll go for this one. Okay, I'll go for F7. Explain me for F7. Yeah, how much it will be? Yeah, equal to sign 10.20 exactly. Multiply this by how much? Number of member. How much we have? 3 number we have, F7 footing, and then hit the enter button. 30.6 we got. Okay, you don't have to do for everything. Just click here and drag your mouse in this way. You'll get the total quantities. Okay, again, there's a lot of decimal. After the decimal, there are a lot of numbers. Select everything. Always you have to select in this way. Then go to this portion, and now it's okay. Now I can bring everything at the center. I'll select this. I'll bring it at the center. Now it looks good, but still it doesn't look good. No, what we'll do? I'll select everything. Okay, in this way, I'll select everything. I'll say this thing, all borders. See, now it looks good. Yeah. Now, if you want to give this see, total quantity you got, but you have to differentiate it. No, you select this part and give a different color to that. Okay. I'll go with the red. Okay, red looks good, and make it bit bold so that you get the quantities here. Okay, now it looks good, no? Fine. So this is the total excavation quantity we have got. But now I need to find the total excavation quantity. We have individually I have found it, but totally how much it is required. For that, I'll write it here. Okay, I'll write total excavation TOTL. Okay, total excavation quantity. Okay, quantity. That you can write here also, not an issue. I'll do that also. What I'll do is I'll delete this so that it will look. See, you can write anywhere, no issues. I'll write here only. Total excavation quantity. Okay. So yeah, total excavation quantity. Unit will be in cubic meter only. Okay, cubic meter. And this what to do? Keep your mouse here. There's one option here called as auto sum. You can see auto sum here. Wait, I'll tell you. Equal to sign and auto sum. Okay, we'll not do in that way. What we'll do? Keep your mouse here. Equal to sign. Put sum here. Open bracket. And now select from here. From here, you drag your mouse in this way and close it. Okay, and then hit the enter button. Yeah, you can see total excursion quantity is 328.8161. What we can do is again decrease the decimal number. Okay, fine. So 328.82 is my total excavation quantity for all my footing for this particular building. Now again, what I can do, I'll select this in this way. Okay, I can make it as bold. I'll increase the size so that it looks good. Okay, and if you want to make some other arrangements, I mean, if you want this to be colored, select this, come here, you can color that. You can color that in red or some other color. Okay, I'll color this in this way, yellow, and this I'll put it in a thick box. I'll select this, and there's one option here, thick outside box, and do that. It looks good. No, again, you can separate this also. Select that, come here, all borders. Now it looks good. Yeah, it looks good now. Now we'll try to manually verify this quickly. Okay, I'm not sure what is the answer we're getting. Quickly we'll verify that. 9.21 plus 33.74 plus 66.33 plus 37.18 plus 66.57 plus 34.91 plus 30.60 plus 38.73 plus 11.56. Okay, I'm getting 328.83 in my calculator. Same thing I'm getting it here. So few times you try to verify with your manual answers so that no you don't go wrong anywhere. Now we have done the calculation. So this is my earthwork in excavation. So this much amount of excavation I'm supposed to do in this particular this thing. What is that? Project. Okay, great. So I hope you have enjoyed my lecture up to here. I've explained you the complete thing, how the excursion quantity will be taken care of. Again, if you want to, you can increase, you can make this font bit bold and all those things you can do. Okay, I'll not do that. You can do it. Now we did for one quantity. Serial number 1 is done. Next we'll do the PCC quantity. We'll do the footing, shuttering and all those things. Okay. So I hope you have enjoyed my lecture up to here. Try to practice up to here and we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So here, after the excavation quantity, next we'll try to see which quantity we are supposed to find. I missed one point, that is, say, whenever you're finding the number of members, no, it's always good that you try to verify this number. Like now you're written the number, isn't it? Instead of doing this, what we can do, no, come here, say equal to sign, and no, say sum, and then open bracket, okay? And now you add all these numbers, okay? And then you close the bracket. So in this way, what will happen? And now you bring this at the center. In this way, what will happen, Yeah. In this way, we are making, we are trying to be more safe. The thing is that there may be some chances while you're inputting it on the Excel sheet, you may miss one or two number. Instead of 3, let us say somewhere in a hurry, you made it as 2 here. So what happened now? Quantity also decreased. Number also has come to 20. Now, when such situation happens, you can always go back to your drawings and try to verify from your drawing. For example, I'll try to count here now how many numbers are there. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21 footings are there in my drawing. And now I'll verify on the Excel sheet. But in the Excel sheet, I'm getting 20 here. So now I understood that I made some mistake in my Excel sheet. Then let me try to verify. Somewhere I might have made a mistake. Where was that mistake made? Yeah, right. In F2 footing, instead of 3, I had done an input of 2. Now I'll go and make it as 3. Okay. So when you try to cross verify in such a way, you're not going to go wrong anywhere. Okay, done. Now, one more thing. This quantity is done. After this, usually what we do, we put PCC, right? You've done the excavation. I'll show you. You've done the excavation. Okay. Yeah. Let me show you the PCC part only. Yeah. So after that, this is a PCC what we try to put, isn't it? We have done the excavation. After the excavation, we'll do such kind of PCC. But in few of the construction project, before the PCC, we do stone soling work. So what is this stone soling? I'll show you that also. See here, these people, you can see these people, they've done the excavation. They've not put the PCC. They've done the stone soling work. And after the stone soling work, we'll put the PCC. Why these things will be done? In few cases, your soil will be very soft. Okay, you may not get a very hard strata. And when your soil is not very hard, in that case, what we do, we try to do this stone soling. And then over that, we put a this thing. What is that? PCC. Okay, that is the usual practice what we do. And sometime when you do the excavation, if you get lot of water, even though you do the dewatering, even though if there is a water coming, in that case also what we do, we try to do this stone soling so that you get a firm soil or you get a firm ground so that you can put your PCC over there. So that is why we do this stone soling. Now we need to find the quantity of this also. So what we'll do, again I'll show you the drawing for that. Okay, the drawing which I am referring right now, no, here it doesn't have a stone soling. You can see this is my footing and directly beneath that we have a PCC. But I'll show you for the same drawing. I've done one more drawing. Okay, this is another drawing what I've prepared. Now let us consider you're doing a project where you have a PCC. This is my PCC, but below that you have this stone soling work. You can see stoning, and what is the thickness of that? It is 150 mm. So in that case, you need to take out the quantity of this also. Very simple. I'll show you another few more drawings. Okay. Anyhow, I'll give you certain assignments also. Here also you can see this is one more project. Okay. Here you can see what has happened. You can see here, 300 mm thick rubber soling is given. Okay. So here the thickness is 300 mm. Previously it was 150. And then I'll show you one more drawing. See here. Here also they have done. You can see this much part. This much part you observe. What is this? What is mentioned in the drawing? So again, it is mentioned here. 200 thick stone soling. So in that case, you're supposed to find this particular quantity. Okay. Now I'll assume that in my particular building, in this particular project, even though it's not there, I'll consider, so that we'll not miss any quantities. Let us consider that there is a stone soling to be made, and the thickness of the stone soling is 150 Only this much thing will be mentioned here. Okay. So what we are supposed to do, the answer in the Excel sheet, what we will do, we have to copy the same thing. All these things you have to copy the same thing. Again, you'll not write. Okay. You'll not waste your time. Copy everything here, and then you have to input it here. Before that, the first serial number was an excavation. Now I'll write my serial number 2, that is 02. Okay. What is the name of that? I'll copy from here. What's written? Yeah. Stone soling work below the plain cement concrete. I'll copy this part only. I can copy this, or you can write. Okay. We'll write or we can copy. I'll copy for saving time. But what you people do, you people write it. Okay. Stone soling work below plain cement concrete. Okay. And make it bold, and then you can change the font of that. I'll go with yeah, this font, and this is enough. Okay. And then I made this in blue color, and also I increased the row height of that. I'll do that also. I'll select on this. I'll go to the row height. I'll make it as 18. Okay, fine. I'll bring it at the center. See, now it has gone down, isn't it? If you want to bring at the center, you can see this particular option, middle align, click on that. It will come at the center. The color what we kept was blue color. I'll go with the blue color. Okay, you can increase the size of that. Now it looks good. Great. Yeah. So done. This is my serial number 2. I'll write it here. Okay, this is serial number 2. Okay. Again, you can align it at the center. Done. This much is clear. Yeah. Now what we'll do, we have to copy the same thing. These things you can copy. Whatever you are written, no, only this much will copy. That is all the footing size I'll copy. Control C. Okay, you have to select that and say Control C. Bring it here and say Control V. Done. You have pasted everything. You don't have to write it again. Now coming to the units part. Now you see one thing, you have to observe one thing. Units, I've written it here. But the moment I'm scrolling my mouse down, you can see I'm not able to see this number of member, length, width, and all those things, right? So in that case, what you're supposed to do, the best option is that always remember. Now you see, I went down, I cannot see which is my length column. I don't understand which is my width column. For that, we have one trick. The trick is that whichever row you want to freeze, you have to select below that. For example, I want this particular row to be freezed. So I'll select below that. This particular option I've selected. I clicked on this and I'll go to the option here. I'll go to insert, not insert, page layout, formulas, data, review, view. Yeah, you go to the option called as view. Okay, what you have to do, see, serial number I've written it here. Below that I'll select this particular portion because I want this entire portion to be freezed. Okay, this entire portion has to be freezed. I selected here. I went to the view option here. There's one option here called as freeze panes. Click on that and say freeze, the first one, freeze panes. So once I do that, now you see I'm scrolling down, but what has happened? This entire thing is visible, isn't it? And even the measurement sheet is visible for me. This entire thing is visible. Now if I unfreeze that, I'll go back here. Okay, I'll select that. I'll go to freeze. I'll say unfreeze now. Now if I scroll down, no, you see everything is gone, isn't it? So that is why whenever you work, no, try to select this, go to the freeze and say freeze panes. Done. Okay, done. Now it is easy for me to identify. Okay, now stone soling, whatever you work you do, no, what is the unit of that? The unit of that is again cubic meter. That is again cubic meter. You can either write from here. Yeah. It is again cubic meter. You can either write it here cubic meter, or again what you can do, you can again copy from here also. Come here, select all these things, say Control C, and then come here and write here. Say Control V. Done. Okay. Now coming to the number of members, again it remains the same. Again you can copy this part. Okay. Copy. Otherwise you could have copied everything in the beginning, but not an issue. You can copy it separately. I copied everything. Say Control C. Come here and do Control V. Okay. Everything is done. Now coming to the length part. So how do you find the soling quantity? How do you find that? For that, we need to understand a small concept here. Okay, the concept is that I'll show that concept here. Okay, through the drawing only. Yeah, see, what is the concept? This PCC offset you are taken 50 mm. This particular offset, was 50 mm. This particular offset was 50 mm. So offset you have to take 50 mm. But again, in stone soiling quantity, you don't have this. You don't have to consider the, what is that, working space. Very simple. Whatever is a footing size plus 50 mm on the right side plus 50 mm on the right side, you're supposed to add. That's it. Very simple. Why not the working space? Because working space is not required. Already for the excavation, I have taken that. For soiling quantity, what you have to do, footing size plus right side extra, this thing, PCC offset, left side PCC extra offset. See, again for the soiling, they won't mention you offset. Already for the PCC, they have mentioned that 50 mm, isn't it? This 50 mm they are mentioned. If you don't understand here, I'll take you to the original drawing. See, here it was mentioned, no, that this is 50 mm and this is 50 mm. Beneath that only your soiling work will happen. So that is why, okay, pretty simple. So what we'll do, first again, we'll write the footing size here. Okay, that is 1.2, no, equal to sign 1.2 equal to sign 1.2. Why it's not coming? Wait, yeah, equal to sign, yeah, 1.2 plus left side 50 mm 0.05 and right side 50 mm plus 0.05. Done. Okay. Similarly on the width also again same thing. I can copy the same thing because my length and breadth is same. So my soiling also will remain same. Again, I'll write for this time 1.2 plus 0.05 on the left side plus 0.05 on the right side. Okay, done. I'll select this. I'll bring them at the center now. Yeah, okay. Now you go for the next quantity. You tell me. Next, how much it is? 1.4. So 1.4 plus 0.05 plus 0.05. Now, here again, you don't do the same thing. What you do? Just come here and drag it in this way. You can drag it in this way because even your breadth is also 1400. Okay. Now you make use of that your smart work. What is that smart work? We know 0.05 plus 0.05 is 0.1. 0.05 plus 0.05 50 mm is 0.1. Now directly add it. Okay, that is plus 1.85 plus zero point 0.1. Done. This answer you got. Next, 2 plus zero point 0.1. You're getting my point? Okay, 2.1. Next, how much it is? Next, it is 2.25 plus zero point 0.1. Okay. Next, how much it is? 3 plus 0.1. Okay. Next, how much it is? 1.55 plus zero point 0.1 plus 0.1. Next, how much it is? 1.55 plus 0.1. Okay. Okay. Here I made a mistake. No. See, sometimes I also may make a mistake, but whatever I'm telling that is correct. Here, that may be a mistake. Okay. Yeah. So 1.4, this is also correct. This how much? 1.75 plus 0.1. Done? Yeah. Now here we'll drag the same thing because it remains the same. Here also it is same. Here also it is same. Here also it is same. Okay. Just verify it. Yeah. Here also it is same. Only the last portion, no? Yeah. This it won't be same. Oh, here I'll do plus 1.15 plus 0. Plus 0.1. Enter. Done. 1.25 we got. Now coming to the depth or thickness. What is the thickness of your rubber soiling? In this drawing, it was written 150 mm. Okay, it was written 150 mm. So I'll show you one more drawing also. So here in this drawing, how much it is written? It is written 200 mm. So if you're doing it for this particular project, you're supposed to take 200. But right now, I'll consider my stone soiling will be 150 mm. So what I'll do, I'll come here, I'll write 150 mm. So it is 0.15. Okay, I'll write 1 and I'll drag for everything because for all other footing it's same. Okay, now I'll bring everything at the center. Yeah, center I brought it. Okay, now come to the quantity. How you will find the quantity? It is in cubic meter. So I require my length. I'll multiply my length with my breadth. I'll multiply that by the thickness of it, and I'll say enter. I got 0.2535. Again, I'll drag it in this way so that it will do the calculation for all other footing. Again, these values you can say after the decimal point. So I'll go here, selected, I'll go here, and I'll make it as two values. Okay. Now come to the total quantity. Yeah. So total quantity will be equal to sign 0.25 quantity multiply by how many? Number of member, and say enter. Okay. Then again you drag it in this way, you'll get the answer. Again, this value I'll decrease it after the decimal point. Good. So you can see all the answers I have got. Now finally I need to make one more table. Yeah. I need to make one more table where I can list down the total soling quantity. Okay. I'll write it here. I'll make it here. Okay. This again, select everything. Okay. Then go to this part, all borders. Okay. It looks good. This quantity you can make it in red color like I did it here. Make it in red color. Okay. Now it looks good. You can even make it bold. You can increase the size. You can do whatever you want to do. Okay. Yeah. Looks good. This entire thing. Now last thing here. So total soling quantity. Yeah, total soling quantity. Okay. Then this answer will be in cubic meter only. Cubic meter. This number you have to do equal to sign, say sum, bracket open, and add all these things. So that will not go wrong, and bracket close and say enter. Okay. Yeah. Now this answer will write equal to sum, bracket open, and now you drag all these things in this way and close the bracket and say enter. 11.25 is the total soling quantity what you have got. Now if you want, you select this and say merge at center. Okay, this won't work out. Yeah, no problem. I'll increase this size of this. Okay, select this, increase the size of this. Okay, this row height, if you want, you will increase the row height, make it as 25. Okay, yeah, and then you can put that border part, all border, so it will look good. Okay. Yeah, so the total soling quantity again, you can make this in a different color. Yeah, this color looks good. Okay, this was black color. This I'll keep in black only. Depends. Okay, this much is clear. This, if you want, bring it at the center. Yeah, 11.25. How much I had got here? I had already done it. Yeah, 11.24 I had got. Same thing I got here. 11.25 cubic meter. Done. This much is clear. So in this way, you're supposed to find the stone soling quantity below the PCC. Okay. Now, whatever project you get, same thing you have to adopt. There won't be any change in this. Right. So I hope you have enjoyed my lecture up to here. You got an idea how this soling quantity has to be taken care of. In the next lecture, we'll try to see how the PCC quantity will be done. After that, the shuttering, the footing, and other part we'll try to cover. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. In this lecture, we'll try to take out the sand filling quantity and also the PCC quantity. So again, in this particular drawing, directly after the PCC, directly we have a PCC. Even stone soling was not there, but I took it. And after that, we have the PCC quantity which we are supposed to find. But in some projects, I'll show you one more project here. Okay, so that we'll not miss anything. In few of the projects, what happens is that after the stone soling, they'll put the sand layer. Okay. And after that, the PCC will be done. You can see it here that this bottom part was a, this bottom part. Okay. This was a 300 thick rubber soling, which you already found. After that, you can see 150 thick, well compacted sand layer. And after that, you have a 100 thick PCC. So usually it depends on the soil condition and depends on the consultant how he's trying to plan to do all these things. Okay. Now we'll assume that in our project we have a 150 thick sand layer also to be done. How we'll find the quantity? Again, the quantity remains the same like we did it for the rubber soling. Only the difference is in the thickness. That is, here 150 is there. How much we had taken previously? Previously for the stone soling quantity, let me check how much we had taken the thickness. Of course, we took 150 mm, then there is no changes at all. What we can do is that directly I'll copy the same thing. I'll write here description number 3. Okay, I'll write 03, and this is sand filling. Sand filling, yeah, sand filling. I'll write above stone soling. Okay, stone soling. I can write in this way, and then of course all those decoration part I'll do. Then I'll bring it the center and I'll make it as this thing. Okay, yeah, done. So again, now see, I don't have to calculate separately. What I'll do, I'll select everything from here. Okay, I'll select all these things from here. I'll say Control C and I'll bring it here, and just I'll paste it here and say Control V. Done. Everything is done. So this, instead of writing total soling quantity, you write total sand filling. Okay, sand filling quantity, and nothing will change. Why? Because even the thickness for the soling we have taken one, because see, wherever the soling will be done, no, over that only your PCC will come. I mean, over that only your sand filling will come. That means whatever length, whatever breadth you have taken, it remains the same. So that is why I'll not recalculate, I'll just copy that. Now coming to the thickness, since we had taken the stone soling as 150 mm, and in this particular drawing, luckily it is also 150 mm, so we don't have to change. Now let us consider, instead of 150, no, I'll make it as, for our calculation, okay, I'll make it as 250. Instead of 150, let us say, I'll make it in this way. Yeah. Instead of that, I'll make this as 250. 250 mm thick. Now what you'll do? Very simple. Nothing. Since it's 250, come here. Instead of 0.25, no, instead of 0.25 in the thickness part, make it as 0.25, and then you drag it simply. Only for one footing I have done. You have to drag it for all the footings. Done. The quantity will increase. It has gone to 18.75 cubic meter of a sand filling has to be done. Very simple. Done. Okay. So now once this is done, again I'll shift back. Okay. Let us keep it as 0.25 only. No problem. Now I'll do it for PCC. Again, this is my serial number 3. This was my serial number 3, and that color, I think, yeah, it was to be blue color. Blue. Okay. This also will make it blue color. Now I'll go with the serial number 4. So this is PCC, plain cement concrete of grade. You have to mention the grade also. Okay. Grade M10. Okay. This is what you're supposed to do. Let me see what I written it here. Yeah, plain cement concrete work PCC below the footing. They have written M15 1:2:4 grade is given here. Okay, no problem. I'll go with M10 grade. No problem. PCC of grade M10. You can write the ratios also if you want M10. Right, ratio for M10 it will be 1:3:6. Yeah, it is 1:3:6 for PCC. Now again I'll make it bold and all those things. Yeah. Okay. Great. The color also will change. Yeah. Okay. Yeah. Now again, what you'll do? Very simple. Nothing. Just copy everything from here. Everything you copy. Say Control C. Bring it and just place wherever you want. I'll place it here, and I'll say Control V. Okay. Okay. Nothing will change. Now what will change? Only the thing is, I'll go back to the drawing. Check what is the thickness of PCC. What is given here. So here it is mentioned you're supposed to provide 50 mm thick PCC. So only the thing what will happen is, instead of this thing, yeah, this will be total PCC quantity. Okay, total PCC quantity. If you want, you can mention for our understanding. You can mention here M10 grade. Okay, just to make sure that you're following proper format. Else it's not required, but I'm writing it. I'll write M10 here. Okay, done. Understood? Yeah. So PCC is done. Huh. What is the thickness we got? It is 0.05. 50 mm is 0.05. So instead of 0.25, I'll make it as 0.05. Enter. And now I'll drag it in this way everywhere. Done. Your answer is ready. You're supposed to make use of 3.75 cubic meter of a PCC quantity of M10 grade is required if I want to do the PCC for 21 footings here. Let me verify my answer here. I come here. Yeah, I got 3.746. Here I got it as 3.75. If I keep it as if I keep 3 digits here, then 3.76 will come. Doesn't matter. Okay. This much is clear. So in this way, you're supposed to find the sand filling quantity and also the this thing. What is that? PCC quantity. So 4 things we have done. Excavation we did, rubber soling we did sand filling, and then we did the PCC quantity. Okay. And now for this particular PCC, 3.75 cubic meter, how much cement, sand, and aggregate is required? That we'll try to do it later. Now it's not required. Later, I'll do a separate Excel sheets where we can try to find out the individual materials required for the PCC and all those parts. Okay. Now we'll just concentrate on doing the takeoff quantities, right? Yeah. So I think most of the things I have covered it here. Only the thing is the pain will be initially, the pain will come only in the initial part where you have to write this F1, F2, F3 footing. After that, no, everything is like Control C and Control. You just have to copy, paste here and just make certain changes there. Okay. That is how you're supposed to do it. Great. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So the next quantity, what we are supposed to find is the footing shuttering quantity. You can see here, the footing has been prepared. Of course, the concreting, everything is done, but you have to put this shuttering, isn't it? So this shuttering quantity I'm supposed to find. So I'll go to the Excel sheet now. So the next activity, 4 is done. I'll start here. I'll write 05. So that is footing shuttering quantity. Okay. You write the same thing and then you can decorate it. Yeah. Make it- Then blue color. Yeah. Okay. So footing shuttering quantity. Okay. Done. So again, what will happen? Same thing. Whatever footing names you have written, no, just copy this. This time you'll not copy the cubic meter because shuttering quantity will be in square meter. So I'll select this part. I'll say Control C. Come here, paste it here and say Control V. Okay. First task is done. Now coming to the units part. Shuttering will be always in square meter. So you write it as square meter. Okay. Square meter. You can get it at the center, merge at the center, and this will make it bold and a bit, yeah. Okay, fine. So again, everywhere it is the same thing. I'll drag it now. Done. Now coming to the number of member. So this number of member will remain same. So I'll copy this number of member. I'll say Control C. I'll bring it here and I'll do Control V. Okay, this is also done. So once this is done, next you have to come to the length, breadth, and the depth part. See, first you need to understand how the shuttering quantity is calculated. For shuttering quantity, I require the perimeter of my footing, and if I multiply that by depth, I'm going to get the shuttering quantity. So here, instead of length, I'll write the perimeter part. So just for understanding, I'll write perimeter. Okay, I'll write perimeter. For footing, will not for footing. Whenever for shuttering quantity, you should calculate the perimeter. Okay, so I'll write perimeter. I'll say merge. I'll make it a bit bold so that no, it's easy for us to understand. Okay, you don't have to do this when you really work on the projects, but since we are here to understand the concept, so I'm writing it here. Yeah, instead of length, I'll write perimeter. Okay, so how will you find the perimeter? I'll do it for first footing. That is F1 footing, the size is 1200 by 1200 by 400. Okay, I'll go with one live example. So let me consider this is my footing. Okay, let me consider this is my footing. Okay, so this is it is 1500. Yeah, 1200. Okay, the footing size is 1200 by 1200 by 400, I guess. Let me check it out. Yeah, 400. No problem. Done. So we'll find the shuttering quantity. So yeah. So the first thing what I'll do is I'll find the perimeter of this. How do I find the perimeter? So this is my 1200. This is 1200. From this outer to this outer it is. From this outer to this outer it is 1200. Plus from here to here it is again 1200. From here to here it is again 1200. From here to here it is again 1200. So you can add it in this way. So what we can do is 1200. 1200 I'll write in terms of meter. Okay, 1.2 plus 1.2 plus 1.2 plus 1.2. How much it comes out to be? So it comes out to be 1.2 into 4. 4.8. So this is 4.8 meter. Okay. For this, I'll multiply by the depth of my footing. So what is the depth? So this 400 is the depth of my footing. So I'll take it as 0.4 meter. This is a depth. I'll write depth. Okay. This is perimeter. Perimeter. Yeah. Okay. Done. The perimeter is 4. Now I have to find the area. Okay. Because shuttering is in square meter. No. So area. So area will be how much? Perimeter into depth. I'll write perimeter multiply by depth will give me what? Area. Okay. Perimeter is how much? 4.8. And if I multiply this by depth is 0.4. Yeah. So tell me how much is the answer you're getting? So answer will be 4.8 into 0.4. I'm getting 1.92. Okay. 1.92 square meter. Okay. So this is my area of shuttering. Okay. This is one way of doing. Otherwise, instead of doing this calculation, you can adopt one more method, that is the simple formula 2 into length plus breadth, multiply this by depth. So if you do this also, you'll get the same answer. That means 2 multiply this by length. What is the length? It is 1200, which is 1.2 meter, plus what is the breadth? That is also 1200, that is 1.2. And this you multiply by the depth. Depth is how much? 400 mm. In terms of meter, it is 0.4. I'll write 0.4. Try to do this calculation and let me know what answer you are getting here. So I'm doing it manually. 2 into 1.2 plus 1.2 multiply by 0.4. I'm getting 1.92. Exactly. Whether you adopt the perimeter and multiply by the depth of the shuttering, or you adopt this formula, your answer remains the same. Okay. It totally depends on you how you want to adopt it. Got it? This is clear for us. One footing I've explained you. Now, what I'll do, directly I'll go to Excel sheet. So in the Excel sheet, let me do all these things. Okay. So here I'll directly write perimeter. So perimeter will be how much here? I'll directly write 4 sides. Okay. 4 into 1.2, 4 into 1.2. Wait. Yeah. Uh, 4 into 1.2. It won't. Oh, yeah. 4.8 I'm getting. Next it is 1.4. Okay. What I can do is again. Okay, I'll directly write this 1.4 plus 1.4 plus 1.4 plus 1.4. Okay, this is perimeter. Next is 1.85. 1.85 into I'll multiply this by 4. Okay, you can 1.85, 1.85, 1.85, 1.85. I'll multiply directly by 4. Okay, next again 2 meter it is. So 2 into 4. Okay, next is 2.25, 2.25 into 4. Okay, 2. So into, you have to use that star mark. Okay, this one only, then the multiplication will be taken. Okay, next one, plus 1.3 into 4. Next, 1.5. 1.5 into 4. See, you may get confused. I'll tell you few things. See, why I'm putting plus here. See, either you can put plus or you can put equal to sign. Okay. Don't think that I'm doing plus 1.5 into 4 and all. Plus or equal to, I'll make it as equal to here. So it is 1.55 multiplied by 4. Okay, 6.2 I'm getting. I'll do this again. Instead of, I'll do it here again. Again, if I use this plus mark and if I say 1.55 into 4, then also I'll get same answer. Okay, don't get confused. You can use plus mark or equal to sign. Your answer remains same. I think we made a mistake. So this should have come here. Okay, equal to sign 1.3 into 4. Okay, 5. Okay, I think everywhere it has gone wrong. No, yeah, 1.2, 1.4, 1.85, 2, 2.25. Okay. Okay, this should have been 3, no? This should have been 3. 3. So in the Excel sheet, when you work, no, try to be a bit alert, because sometimes calculation may go wrong, like I did it here. Okay. 1.55 into 4. And then the last part. See, here I cannot take 1.75 into 4. Okay. I'll go wrong. Why? Because here you see the size is different. Your length is 1.75, your breadth is 1150. So I need to take perimeter. In that case, what I'll do, I'll say 1.75, I'll say plus 1.15 plus 1.75 plus 1.15. Or you can, okay, I'm getting 5.8. I'll adopt that formula also, equal to 2 into length plus breadth also you can adopt. Okay, I'll write 2 into, okay, bracket open. What is the length? 1.75. What is the breadth? 1.15. Close the bracket here. Okay, then also I'm getting 5.8. Okay, into depth I'll do it here, and then I'll get the total quantity. Okay, even though the formula is, see, shuttering formula I told 2 into length plus breadth into depth I told, isn't it? This is a total formula. Okay, but for perimeter you just have to use this formula, 2 into length plus breadth. Okay, and then for area you'll multiply this by depth. Okay, understood? That is why I got 5.8 here. I'll delete it, not required. Okay, just for your understanding I've done it. Got it? Now width or the breadth part, this part is not there, because shuttering, no, perimeter we have found and we want the depth, so this part is not there. You can either do this dash here, make this as dash, it signifies that is nothing, and then you can drag it in this way. Okay, and next you bring it at the center, select and bring it at the center. Yeah, okay, done. This will come at the center. Yeah, okay, it's already at the center. Now coming to the depth. So depth, what you do, already it is mentioned here, 400 mm. I'll write 0.4. Okay, this is also 400 mm, 0.4. This is 500 mm, 0.5. For shuttering, whatever is the depth of your foundation, that you have to take. Here it is 600 mm, I'll write 0.6. Next it is 0.6. Next also it is 0.5, because 500 mm, 0.4, then again 0.4, then again then again 0.4. Okay, done. Now come to the quantity. Quantity equal to how much? Your perimeter, I'll multiply the perimeter by the depth, I'll get the quantity. Okay, and then I'll drag it in this way. Done. Okay, now come to the total quantity. Total quantity equal to quantity of one footing, I mean quantity, multiply by number of footing. Number of footing is how much? Number of member is 1. I'll do it here, and then I'll drag it, because here of course it is 1.92 only, since number of footing is 1. Whereas here 2.24, I'll drag it here, and then 1 will verify. Yeah, how it is 6.72? Because 2.24 multiply by 3, you will get 6.72. That's it. And now you just do all the decorations. Just select everything and put them in the border, and then you can even, this part, like we do, you can make it as red in color, you can increase the size of that, and all those things you can do. Okay, done. Think we'll decrease this size. Okay. Now finally we have to write the total shuttering quantity, isn't it? Yeah. You can even copy this same thing, Control C, and then you paste it here, Control V, and now this is not PCC quantity, this is total footing shuttering quantity. Okay. Now you see it has gone on this side. No, select here. This part will delete because it is shuttering quantity. Grade is not required. Yeah, now it's going. Again, this is not cubic meter. This is square meter. Select this. Control C. Paste it here. Control V. Okay. Fine. You can increase the size also. And number of footings is how much? 20 or 21? 21. I think somewhere we have missed it. No. How come it is 20 here? So what we'll do? We'll take it out. We'll delete this. Okay. What is happening? Not required. No. Equal to sum bracket open, and I'll copy from here to here, and close bracket and enter. Yeah, 21 footing will come. Now shuttering quantity 69 we have got. Yeah, same answer will come. If okay, 69 it's coming. We'll verify. Yeah, 69 it will come. Still, if you want, I'll verify this again. Okay, bracket open. I selected from here to F9 footing, and yeah, bracket close. Wait, wait. Yeah, sum bracket open. Yeah, select from here to here, bracket close, and enter. Okay, it's 71.24. We'll verify this. I'm not sure. 1.92 plus 6.72 plus 14.8. You also can verify along with me so that we don't go wrong anywhere. 6 plus 6.24 plus 7.44 plus 2.32. I'm getting 71.24. Same thing I got on the Excel sheet. Okay, got it. So in this way, you can find the shuttering quantity for the footing. Okay, we got it as 17.24. It is in square meter. Let me verify that answer. How much we had got for this particular previous. I had already done one. Okay, here I'm getting 213.6. Okay, see this mistake we have, no, not 61. Now it should be okay. Yeah, 69.6 we are getting, no. We are getting 71 point. Let me verify that. Okay, 1.92, 6.72, 14.8, 14.8. Okay, we got 9.6 here. Let me verify that. Yeah, here we got 8. I think this small mistake is here. Yeah, okay, 8 we got here. 8 we got. Depth is 0.5. So it will be 4, 2. So it is 8 there. Okay, fine, fine. No, it's correct only. I think there we are taking F4 footing. Let me verify. Okay, see, sometime we'll verify what is F4 footing size. Yeah, F4 footing, the depth is 500 mm only. Okay, then it's fine, no problem. Whatever we have done, everything is correct. F4 footing. Okay, okay. See, we did one mistake, no? This should have been 500. So if this is a mistake here, I think everywhere that mistake might have come then, or only here that mistake has come, because see here, F1, F2, F3, and F4. In okay, 500 mm, no? 400, 400, 500, and 500. F4 footing, the size is 500. We took 500. Then I think everywhere that mistake has happened from the beginning itself. But anyway, uh, yeah, see here, this again we need to change then, isn't it? This is 500 again, F4. Okay, no problem, fine. Such mistakes happens, it's okay. We rectify them in the initial stage only, 500. Okay, fine. Again, this is also 500. But anyway, there won't be any changes in your calculations since we haven't touched the foundation part, no? Not an issue. So even before that only we rectified it. 500 F4 and footing shuttering 1, 2, 3, 4, 500. If this is 500, then this will be 0.5. So if this is 0.5, so 69.64 and 69.6 exactly. Now it's okay. Yeah. We got 8 there. 8 is there. 16.2, 16.2, 6, 6.24, 6, 6.24, 7.44, 2.32. Exactly. Yeah. So this is 2.28 we got here, no? Final answer. Okay. Why that changes? 1.75 into 1.1. Okay. Here we have taken 1.75. Okay, correct. No, then. Yeah. 1.75. Yeah, this we have taken correctly. It should be 5.8. Here they have done a mistake. 1.75 plus 1.1. Okay, see what mistake. Okay, anyhow, no, whatever we have done is correct. This mistake, it should be 1.15. And this should be 1.15. Then it's okay. 69.64. Exactly. See, it's matching. Okay. Don't see whatever you have done, you follow that. Okay. Nothing is wrong here. Sometimes in the Excel sheet, answers will go here and there. You just have to be alert. That's it. 69.64 is the total quantity. Try to verify this manually. You'll get the same answer. So perimeter is done. The small mistake we were making in F4 footing, that 500. So now everything is rectified. Still, let me quickly try to verify the footing sizes once again, so that no, we'll not make any such mistakes again. I'll quickly take it. I'll paste it here. Yeah. So F1 it is 400, 400, 400, 400, 500. Then again it is 500, 600. So I think in F5 footing also F6. F6 is 500. This is 600. Correct. Then F8, F7. F7 is 400. Okay. F8 is also 400. F9 is also 400. Fine. Everything is correct. No mistake. Okay. Done. So footing shuttering quantity for 21 shuttering, for 21 footing, I need to have 69.64, let us say 70 square meter of my shuttering is required. Okay. Yeah. So I hope you have enjoyed my lecture up to here. So in the next lecture, we'll try to find the quantity, that is a footing concrete quantity, then the column shuttering quantity, and then the column concreting quantity. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So in this lecture, we'll try to see how the concrete quantity has to be taken care of for the footing. Okay. Again, we'll try to understand that. See, wherever the shuttering was done, there we are supposed to do the concreting. You can see a lot of concrete has been placed. How much concrete has gone into the footing, that we are supposed to calculate now. So one thing always remember, wherever you are done the shuttering, no, that much part will be your concreting. Okay. So again, for that, what you are going to do, we'll write it here again. So up to 5 we did, no. So this will be my sixth quantity, 0.6. Or I can do one more thing. I'll just copy this part only. Okay. So that my work will be reduced, and I'll just paste it here. Now this I'll make it as 0.6, and this I'll make it as footing concrete quantity. Okay. Footing concrete quantity. So in this, you can write the grade of a concrete. Usually for RCC and all, no, minimum M20 grade we are supposed to use. But here I have to refer the structural drawing. Let me check whether they have mentioned those things or not. Yeah, in here there is no such thing mentioned. But usually M20 is what we are supposed to do. Usually they mention, but this is not the final drawing, but it's not an issue. Okay. We'll consider M20 is a grade of concrete we are supposed to use here. Okay, I'll write M20. Okay, I wrote M20. Now for M20, if you want, you can write a grade also. I mean the ratio also, but not required. Okay, done. Next step is what? You're supposed to, yeah, you're supposed to copy all these things. Okay, copy all these things up to here. Okay, and say Control C, and let me paste it here, Control V. Okay, now what changes I need to do? Exactly this concrete quantity we are finding, so it will be in cubic meter. So instead of square meter, I'll write this as cubic meter cum, and now I'll drag everything. Okay, I'll drag everything. Done. Okay, everything is fine. Now coming to the other portion, that is a length, width, and all. So here directly I have to do a input. So let me finish this particular area. Yeah. So how we'll do? Length we know, footing length I know, breadth is also known, depth is also known. Just you have to multiply all the three quantities. Very simple. Okay. If you're not understood, quickly I'll explain you. I know my length of the footing. I know my length of my footing. This length you know, footing length you know, footing breadth you know, and if you multiply this by the depth, you'll get the concrete quantity. Okay. Got it? Clear? Still, if you have doubt, last one thing I'll explain you. Okay. I think okay, fine. This one I'll explain quickly. And yeah, you understood, it's okay. But for someone who doesn't understand, for them, okay. Length I know, footing, footing breadth I know, and this depth I know. I'll multiply all the three quantities. I'll get this particular concrete quantity for the footing. Okay, quickly we'll do that. It's very simple now. Just input it. 1.2. I'll write 1.2. Here also I'll write 1.2. And what is the depth? Depth is 0.4. Okay, it is 400 mm. No, yeah. Next, what it is? 1.4. Next, it is 1.85. Okay. Next, it is 2 meter. It is 2.25. It is 3. It is 1.3. It is 1.55, and it is 1.75. Okay. Here also it is same thing. You have to just drag this. No, this also you have to drag. Same thing. So you can do in this way also now. Select it, and then I think you should drag. It should happen. Let me try. No, it will not. It will not happen. Okay, drag it. No problem. Drag it in this way. Drag it, and this is also same. No, last this will be, yeah, this will be 1.15. 1.15. Great. So depth, quickly you tell me how much it is. 0.4. Good. Then 0.5 exactly. 0.5 exactly. 0.6 exactly. 0.5 exactly. 0.4, then 0.4, and then 0.4. Right? Good. Now let me bring them at the center. Yeah, done. Now how do you find the quantity? Very simple. Equal to sign or plus sign. Length, you multiply that by breadth, multiply by thickness of the footing. I mean depth of the footing. See, one thing you remember, most of the people make mistake, even people having 10-year experience and all. Okay. For footing, it is depth. You don't call thickness. Footing, it is depth. What is thickness? Whenever that size is very less, we call it as thickness. Like for example, PCC thickness, because PCC is usually 50 to 100 mm. So we should not say PCC depth. It is PCC thickness. Okay. But footing, it is not thickness. Footing, depth. But whereas for slab, I don't say depth. Slab thickness, I say. Why? Because slab thickness is usually 150, 200 mm. So we say slab thickness and not the slab depth. Whereas for the beam, I don't say beam thickness, beam depth, because beam depth will be usually 300, 400, 500 and all. Okay. Try to understand certain things. I'll drag it. Okay. And this I'll reduce it. Because you people are engineers, so technically you should speak. Okay. So now total quantity will be 0.58. Multiply this by number of member, and I'll say enter. Done. Now you just drag it. Very simple. Done. All your concrete quantity is ready. Okay. Again, you reduce this. Done. Okay. Now what we'll do? We'll write that final part. Okay. This part, whatever we have added, no, I'll say Control C. I'll bring it here. I'll write Control V, and yeah, this will be in how much? Cubic meter. Okay. Cubic meter. And this one problem you are facing, no, It is 21 there. So I should select Control C. Then why it's not happening? Control V. Okay. I think sum from here to here and close the bracket. Enter. Yeah, 21 will come. Okay. So that you have verified that. Now concrete quantity, we'll see again. Sum. Okay. Bracket open. Select this point, drag your mouse and close your mouse. I mean, sorry, close the bracket. Yeah, you're getting 33.10 cubic meter of a concrete is required. If you want to do 21 footing concreting, I require 33.10 cubic meter of a concrete. Let me verify what answer I got here. Yeah, 33.07 I got here. How much I got? 33.110. It's okay. I think we'll check out the quantities also. 0.58, 2.35. Okay, then 6.85 for 9.11, 6.85 for 9.11, and 4.5 2.03, 4.5 2.03, and 2.88 and 0.77. Okay, last one, there is one problem. Okay, problem is this only. Here I taken this 1.1, it should be 1.15, isn't it? Let me check out. 1.15. So this will be 1.15. Then your answer will come correctly. Now it should match. Yeah, 33.10, 33.10. This already I had created. Okay, but this I'm creating right in front of you. That is why I'm trying to verify it. Okay, you got the concrete quantity done. So in this way, whatever drawings if I give you, you are in a position to do the concrete quantity for that. Yeah. So one thing we made mistake. This is total footing concrete quantity. Concrete. Yeah. Hmm. Concrete quantity. Okay. Done. Cubic meter 21 33.10. Okay. Fine. Great. So I hope you have enjoyed my lecture up to here. So we understood how to find the footing concrete quantity. Everything is done. After this, we'll try to find out the shuttering quantity for the column, then the column concrete quantity. So if we do up to there, most of the part will be done. And after that, the plain beam portion, and then we'll go floor wise. Okay. Yeah. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So in this lecture, we'll try to see how to find the column concrete and the column shuttering quantity. So if you remember, see, we are done up to here. We have done the excavation, then we did the PCC. After the PCC, we have done the footing concreting, right? And one thing I hadn't shown you the footing, the PCC part. I'll quickly show you the PCC one. Okay, in the while explanation, I missed that part, but I'll just show you. If you know, it's well and good. If not, for someone who doesn't know that, I'll show that. Yeah. Okay. So once you're done with the excavation, then once if you're doing the soling also, after that, no, you have to do the PCC. I'll show you the PCC part. Yeah, so this is your PCC part, okay, which we had done, okay. So this was the length of your PCC, this was your breadth of the PCC, and this part is your thickness of the PCC. And the length, you know how we calculated, whatever was your footing size, both the side we have taken the offset, which was 50-50, and on the breadth side also we did the same thing, okay. So in this way, you're supposed to, what you do, do the PCC quantity, and we had done it, but since I not shown you the image, that is why I'm showing you here. Yeah. Okay, now we'll go to the column part. So column footing is done. After the footing, you can see this column has been put up, right? I need to find the shuttering quantity for this footing, for this column, and then the concrete quantity. This is what I'm supposed to do. Okay, so how do you do this? Again, same thing. For that, I need to refer my drawings. I'll go to the drawing again. So this is the drawings what I have. So in this drawing, if you observe, no, on each footing, the column number has been given. Like say, this is my F7 footing. On this F7 footing, I have C27 column, right? In the same way, this is my F8 footing. On that, C28 column is given. See, whatever number they have written inside, no, this is a column number. And this is my footing number. F2, we have C25. Okay. F9, we have C26. And then in this way, everywhere the number has been given. Now, before we start with that, we need to group them. Why is that so? Because you see, whatever height I want to find, no, it depends on the depth of my foundation. That means I'll show you the cross section part. See, so now actually I'm supposed to find this particular height. Which is that height? This height I require. From here to here, this height is required for me. Okay, this height I'm supposed to find. I can find it, but this height depends on the depth of your foundation. Okay, so in few foundation we saw that like F1 footing. If I go back here, see here, like this F1 footing has a depth of 400, whereas the F3 footing has a depth of 500, F5 footing has a depth of 600. That means the column height is going to vary based on the foundation. Whatever footing we have, over that we have column. So whatever is a footing dimension, depth, based on that, my column length is going to either increase or decrease. So that is why we need to group them now. So what we are going to, we'll try to find all the columns here. So like for example, we'll start from F1 footing. Okay, so where is my F1 footing? Yeah, I'll write in this way. This C1 column is resting on F1 footing. So I need to write in this way. You're getting my point? For once this is done, next I'll find F2 footing. So again, I have F2 footing. Where I have F2 footing? Okay, I'll explain you all these things. Just understand. Here I have F2 footing. So on this F2 footing, I have C25 column. Again, there is another F2 footing. So another F2 footing is somewhere here. See, on this F2 footing again, C12 column is there. So here C12 column is there. And on this F2 footing, C25 column is there. Okay, fine. Next, after that, again on F3 footing, this is my F3 footing. I have C20 column. Then again on F3 footing, where is my another F3? So another F3. Yeah, you see here, this is also F3. On this I have C9 column, another F3. On this we have C10 column. So now what you're supposed to do, you need to write the footing on F1 footing, which column is coming. On F2 footing, which column is coming. F3 footing, which column is coming. F4 footing, which column is coming. This you need to identify first, and only then we can find the height of my column. Otherwise it's difficult for you to do. So that is why, to make our task easier, what I have done, I already made those things. Okay, so if I come to this sheet number 8, or maybe sheet number 1, yeah, sheet number 4, yeah. So you can see here, I already done all these things, right? C1 column on F1 footing, then C8, C12 and C25 column. These columns are resting on F2 footing. Then C9, C10, C11 and C20. This column are resting on F3 footing. Then C13, 16. This column are resting on F4 footing. In this way, I've made this particular thing. Okay. Now quickly I'll explain you how it has been done. Okay, fine. First we'll start with F1 footing. Okay. Okay, I'll go with F1 footing. So first tell me how many F1 footings are there? There is only one F1 footing, so no problem. Directly I can say wherever is my F1 footing, no, there my this particular column is coming. So my F1 footing is here. So what is that? This is F1 footing. Which column is coming? C1 column is coming. So I've written it already. I already written that on F1 footing, C1 column is there. Okay, you write it down separately. Fine. Next we'll go with F2 footing. Again, I'll go back here. Now this is my F2 footing. Again, I'll start searching from here. How many F2 footings are there? 3 footings I need to find. That means 3 columns will come. 3 footings. On each column, 1 column will come. On each footing, 1 column will come. So 3 columns should come. So there is no F3 here. Yeah, 1 F3 is here. Where is that? 1 F3 is here. What is the column name? C20. I'll write it down here. Okay, C20. Okay. After that, again, where is my F3? Where is my again? I'm finding F3, right? Wait, I think I should find F2. Sorry, F2 I'm supposed to find. Okay, yeah. So see, one F2 footing is here. Which column is coming? C25. I'll write C25 here. So C25. Okay. Next, after that, again, where is your F2 footing? Again, there's no F2 footing here. There's no F2 footing here. Yeah, there's another F2 footing here. Okay. Which column is coming? C12. So write down here again, C12. Then where is your another F2 footing? Another F2 footing. I don't have any F2 footing here. Yeah, I have another F2 footing here. And on that we have C8 column. So I'll write here C8. Understood? So 3 footing we wanted and 3 columns we got. Okay. So same thing I'll write it here in Excel sheet. You can see here C8, C12 and C25 column on F2 footing. So I written the same thing, C8, C12 and C25. Got it? Yeah. Now we'll go for the next again. So it's a bit tedious task, but this is very important. Otherwise, it's difficult for us to find the quantities. Now, on F3 footing, F3, there are 4 footings. Okay. So we'll quickly try to find where is my F3 footing. So there is no F3 footing here. There's one F3 footing here. Can you see that? Here. So which is that column? C20. I'll write C20. Okay. You note it down separately. Then again, there is no F3 footing. Okay. Then again, there is no F3 footing here. No F3 footing here. Yeah, there is F3 footing here. You can see F3, F3 and F3. What is the column here? On this it is C9. On this F3 it is C10. On this F3 it is C11. So I'll write it down here. So it is C9. Then we have C10. And then we have C11. Gone. Fine. 4 footings we wanted. C3. 4 we got. I'll go to the Excel sheet. See here what I've written. C9. C9 is here. C10, C10 is here, C11, C11 is here, C20, C20, column on F3 footing. Got it? So in this way, you're supposed to find it for all the footings. Okay. Next, quickly, I'll do everything. Don't worry. You have to just concentrate and do it. I'll not skip anything. Okay. F4. There are 2 number of F4 footing. So quickly, let you also do it so that it will be fun for you. There is no F4 footing here. There is no F4 footing here. There is no F4 footing here. Yeah, there is one F4 footing. Which column is coming? C13. Write it down. C13. Okay. And then, yeah, then another F4 footing is here only. Which column is coming? C16. Write it down. C16. Okay. 2 are done. Done. Because there are only 2 F4 footings. Yeah, you see, C3, yeah, C13, I got it here. C16, I got it here. Column on F4 footing. Now, F5, F6, F7, F8, and F9 is left out. So I'll not do this now. Okay, anyhow, let me do that. Quickly, I'll do that. Okay, I'll not verify. Quickly, I'll do that. I'll not write this time. Okay, F4 is done. I'll find for F5 now. F5, how many are there? F5, there are 3 footings. So on F5, there are 3 footings. There is no F5 here. Yeah, C21. Remember, C21. I'll write it down. C21. Then again, we have here C22. C22. And F5, F5. C22. Then F5. Yeah, C15. Okay, C15. And F5 is done. Then again, where is F5? There's no F5 here. This is F3. And yeah, done. There's no F5 again. Okay, now we'll verify. F5. Okay, fine. C15. Yeah, C15 is done. C21. Yeah, C21 is done. C22. Yeah, C22 is done on F5 footing. Done. Okay. Next, after that, we'll go with F6 footing now. Again, go back to the drawing. F6, you first see how many footings are there. F6, there should be only 1 footing. No problem. Quickly, we'll find that. 1 footing of F6 number. So there's no here. I mean, there's no footing there. No footing there. F6. F6 should be somewhere here. Yeah, you see on F6, this is that combined footing. Okay, this is a F6 footing. On this footing, how many columns are coming? C2 column is coming, C6 column is coming, then C7 column is coming, and C3. That means C2, C3, C6, C7. Remember, we'll see here. Yeah, C2, C3, C6, and C7 on F6 footing. Now last another 2 footings will do. F7 footing will find. So again, where is my F7 footing? How many numbers are there? F7. F7, I have 3 footings. Okay, quickly I'll start. F7, yeah, 1 is here. So what is the column name? It is C27. Okay, then again, after that, no F7, yeah, another F7 is here. Okay, which column is coming over that? C23. All these things will not be given in the drawing. Okay, when you start to work, it will be not given. So you need to spend your time, and F7 is here, C17. And try to do all these things. That is why I'm spending so much time here. If you understand for 1, it's simple. Yeah, 3 are done. So I'll go back to the Excel sheet. So on F7 footing, C27, yeah, C27, C23, yeah, C23, and C17, done. Last 2 footings are there F8 footing I'll find. So F8 footing, first you try to see how many footings should come on F8? I mean, how many F8 footings are there? 3 are there. So quickly we'll find that F8. We'll start from here. So 1 is here, F8 footing. Which column is coming? C28. So write C28. Okay. Then F8. Yeah. Okay. Another F8 is here, C4 column. So it is C4 column. I think one we have missed, no? We have to see F8. F8. This is, where is my another F8? Yeah, another is here. See, this is F8. So C18 column. C18 column. Done. Everything is done. Go back to the Excel sheet. C4. Yeah, C4 is matching. C18. C18 is also matching. C28. C28 is also matching. Right. Last one footing is there. That is F9 footing. And obviously there is only one footing on F9. I mean, there's only one F9 footing. Yeah. F9. There is only one. So obviously you see here on F9 footing, there is C26 column. Okay. That's it. So I written that here. That is on C26 column on F9 footing. So this task you're supposed to do. So once you're done, 50% of your work is done. Now you just have to copy this, okay, and come and paste it here. Okay. So now what we are trying to find, we are trying to find this thing, which is that shuttering work for neck column till the plinth beam top. Okay. I'll copy this. So the next activity is here. Which one? Seventh one, right? Seventh one. And what is the activity name? It is a, okay, Control C. Yeah. So this is that activity, shuttering work for neck column till plinth beam top. So this is very important. This particular point is also important, till plinth beam top. Okay. So this will make it bold. Okay. And this I'll use a different color. This blue color. And this is no fill. Fine. Okay. This is also not required. No borders. If you don't want to remove the border, you have to go for no border. The border will go. Okay. Fine. Yeah. So this is done. Now you have to write all those things. See, already I've written it here. Same thing I could have copied. This I could have copied. Else already I've written here. This thing I'll copy. Okay. So this thing I'll copy one by one. So yeah. Else I have to write it down. Anyhow, I'll write it down. It will take some time. Okay. I'll quickly copy and put it here. Okay. The font is big here. Yeah. So it looks good. C1 column on F1 footing. First one. Then after that, C1 this much footing. Okay. This much column. I'll write it in second line. Again, this size we have to reduce. Yeah. Wait, let me reduce all this size first. Okay, you write it because already I have written it. So I'm just copying it. But you need to write it on your own. Only then you can, I know. Yeah. Then you can understand all these things. Next. Three is done. Fourth one. One, two, three, four. Fifth one. One, two, three, four. Sixth one. I'll reduce the size later. Let me first copy everything. So this is seventh one. Then this one. You have to write the column size also so that it is easy for us to do the estimation. So I'll tell you how to write the column size also. First you copy up to here. Okay. You have to prepare the Excel sheet. I won't be sharing my Excel sheet. Already I've told you that. Okay. Yeah. Fine. If you want, you can increase this thing, row height of this. Try to keep it as 18. Yeah, now it looks good. And this size also you can increase it. 14 looks good. 12, 14 is good. And then you try to increase this part. Okay, not an issue. I think, yeah, some more. Now it's okay. Good. Now, if you want, you can do the alignment of this so that it's exactly at the center. Yeah, this looks great. Um, no field. Yeah. Now you understood what I've done. Everything, whatever I had written it here, no, this part I've copied there and I've written it here. Only the change is that the C1 column size I've written. That also you need to write. How you will write that? Very simple. Go back to the drawing. Here, for all the column, the sizes is given. You have to go to the column schedule. See, this is my column schedule. Okay. Here the column schedule is given. Like what is your C2, C3, C6, C7 column? What is the size of that column? Okay. Then C8, C9, C10, 12 and 13. What is the size of that column? Then C11, C1, C11, C17, 18, 25. The column size is this. You can see for all the column, the sizes has been given. So in this way, you need to differentiate first and write down all the column at once. Okay, all the column size you're supposed to write it here. The same thing I've done it here. I've written all the column size here. Okay, like C1 column, C8, C12, C25 column, the size is 200 by 350. So C26 column, I'll verify for two columns. I'll verify for C26 column what is the size. So C26, I'll go here and let me check for C26 number. So C26, yeah, C26 is here. Okay. And what is the size of the column? It is 200 by 500. So same thing I've written it here, 200 by 500. Again, I'll verify for this column, that is C8, C12 and C25. I'll write it here. C8, C12, C25. Yeah. So first is C8. So where is my C8 column? C8, it is not here. C8, C8 is here. What is the size? It is 200 by 350. Okay, it is 200 by 350. What is C12? So C12 is also again 200 by 350. C25, C25 is here. Again, it is 200 by 350. Fine. So all the three columns, the size is same. So that is why I will put it here. Okay. That is how you're supposed to do. Now, here there might be one problem. For example, that we make it bit complicated. So sometime what will happen? Now let us consider your C8 and C12 column. That is C8 and C12 column was 200 by 350. Whereas your C25 column was actually, let us consider, instead of 350, no, I'll consider this to be 450. I'll consider this to be 450. In that case, what will happen? You cannot put that in this combination. You cannot put that in this combination. For that, you need to provide, yeah, yeah. For that, what you need to do? You need to come here. Yet, see, I'll click here. I'll say control and enter. Okay. So I'll insert one more row here. I'll repeat it again. See, I want to insert one row after this. Okay. So I'll go to 114. I'll select that. Control and enter. Sorry, control and plus. If you do control and plus, you'll get one more row here. Otherwise, the other option is like what you're supposed to do. You have to come here, right click. There's option here, insert. Instead of doing that, the shortcut is come here, keep it 114, control and plus. Done. One row is inserted. Now what I will do, I'll copy. I'll take out this C25 column. I told for C25, right? Yeah. Yeah. C25 was 200 by 450. Now in the Excel sheet, I'll write here C25. Okay. Column where on F2 footing only. On F2 footing only. But this time, the size whatever you have, no, it is 200 by 450. So in this way, you need to differentiate it. Why? Because the moment this column, because here what has happened, it is 350, but here the footing size is 450. So a column will vary. That is why I made another row here. Okay, so whenever you do the quantity estimation, these things you need to keep in your mind. But now we'll not make it complicated. I'll go with the same thing, that considering that this is actually yeah, this is actually 350 only. But there may be certain cases when you try to do, you may get certain columns, even though they fall on the F2 footing only, the size may be different. Okay, very simple. In that case, you have to follow this. Okay, otherwise, rest all things, whatever I have written, they all are correct. You can go with that. Okay, fine. So this is done. Next, coming to the units, I'm finding the shuttering quantity. So I'm finding the shuttering quantity. So it will be exactly, it will be in square meter. Okay, it will be square meter. Make it bold, and then this thing, yeah, and then you drag it in this way, and then this will make it to the center. Okay, fine. After that, next is number of item description and all those things I'm supposed to do. I'll copy this in this way. Let me put a yeah, done. I'll give all borders. I'll make everything at the center, and then yeah, 14 is what I need. Okay, and this I'll keep it as this portion. Okay, fine. Now number of members. Yeah. Now again, number of members. You're supposed to add number of members. So it is very simple. How many columns are there? C1. So I'll write 0, 1 here. Okay. Again, that you cannot find from the drawing. It won't be written. Okay. I think it might be written in some drawing. We'll check out if you're lucky. Yeah. You're lucky that it is already written here, but this is of no use to us. This is a column number they have written. I'll directly take it from the Excel sheet only. Now again, here how many columns are there? 1, 2 and 3. So I'll write 0, 3 here. Here how many columns are there? 1, 2, 3, 4. So I'll write 4. Here how many columns are there? 1 and 2. So 2 columns. 1, 2, 3 columns. Fine. Here 1, 2, 3, 4 columns. Fine. Here 1, 2, 3, 3 columns. Here 1, 2, 3 columns. 3. And here only one column. Fine. So totally, can you count how many columns are there, so that we'll verify? Okay, how do you do that? Equal to sum, I'll write open bracket, and let me count from here to here. So there are 24 columns altogether. Now how is that columns has increased? Because footings we had 21, but how is that the column you have got 25? Pretty simple, because we had one combined footing, and in one combined footing there are four columns. If there are, okay, we'll quickly do that. Simple calculation you need to understand. That's it. See, I'll try to count the column now. 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and this is 20. Okay. Now come here. 21, 22, 23, and 24. Done. And on the Excel sheet also I got 24. That means my calculation is correct. Now come to the shuttering part. Length, width, and depth or thickness is given. How you'll find that? Again, it's a shuttering quantity. It will be in square meter. Remember the formula. Take the perimeter of the column, multiply by the height of the column. You'll get the shuttering quantity. So that means this width part is not required for us. I'll cut it. Okay. This width part. Yeah. This width part is not required. I'll cut it in this way. Sorry, not this one. This part. I'll go to the shapes, and from the shape I'll take it. Okay. This is not required. That means not required in the sense. Then you copy that. Keep it here this time. And then you copy. Okay. Fine. Done. Or you can even put dash. No problem. Now come to the length. So length, again, this is shuttering quantity. Right. For your understanding, I'm writing it is perimeter. Okay. Perimeter. Done. For our understanding, we have written it as perimeter. Make it bold if you want, and then if you want, color it. Okay, we had given red color last time. We'll try to keep the same red color. Now it's understood that it is perimeter. Okay, so how you will find that? So again, simple. 200 and 350. 200 is the breadth of your column, 350 is the depth. So shuttering I want to find, that is perimeter. I'll explain for one column. Yeah, yeah. This is 200. This is 200. What is the size of that? 200 by, yeah, 200 by 350, no? Yeah, yeah. So this is 200, this is 350, again 200, and this is 350. Find the perimeter of this. Very simple. 200 plus 350 plus 200 plus 350. Okay. Uh, you can tell me in mm also. So 200 plus 350 plus 200 plus 350. So 1.1, that is 1100 meter. Okay, this perimeter I got. So whatever perimeter I got, if I multiply this perimeter with the height of this height, if I multiply from here to here, I'll get the total shuttering quantity. So this height I don't know. How will I find this height? It's very simple. How will I find? You have to go to the cross section. Now in the cross section, they mentioned this part. Okay, they mentioned this part. That is, you can see from here I want the height. From here to here. Okay, that means from the top of my foundation, from the top of my foundation to the top of the plinth beam, I need to find my column height. Now remember one thing, in one of my earlier course, I told you to take the height of the column till the bottom of the plinth beam. Since many students had doubt, this time what I'm doing is I'm going to take it till the top of the plinth beam. Not a problem. You can even follow that method also, but that method is little difficult to understand. So what you do this time, you'll take it up to the top of the plinth beam. That is also okay, not an issue. Okay. So what we'll do, from the top of the foundation to the top of my plinth beam, this will be my height of the column. Now how it has to be found, I'll explain that in the next lecture. Okay. Now you understand the concept again. This height I'm supposed to find. So in the next lecture, I'll explain you how this height has to be found, because there's a lot of calculation to be done. And then we'll try to find the shuttering quantity for this particular column. Okay. So I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So now we'll try to find out the this thing, that is a shuttering quantity for this. Okay. So first what I'll do, I'll calculate the perimeter quickly, and the depth part I'll explain you later. Okay. Yeah. So anyhow, I'll explain you the depth part first, and the perimeter is very simple. Now coming to the depth, for the depth, no, this already I explained you, right? So my shuttering quantity will go from here to here. Okay. Shuttering or concrete quantity, both are one and the same. This top of the plinth beam, from there to the top of my this thing, what is that? Foundation. I'm supposed to, yeah, this much is my shuttering and the concrete quantity. Okay. But how do I find the height of this? One thing I know, that is from a natural ground level to the bottom of my foundation or the top of my PCC, this is 2500. Okay. But my idea, or by my intention of finding the height, is from where to where, that we need to understand. My intention is from here to here. That is from the top of the foundation to the top of the plinth beam. How will I do that? One thing we understood, this overall height 2500, in that if I deduct this particular thing, I'm going to get this height. Okay, I'll do that here. See, so if I deduct this height, from this height, from natural ground level, if I deduct my footing depth, I'm going to get the height from the top of my foundation to the natural ground level. Do you agree with me? This will get. But my intention is from where? Again, my intention is from the top of the foundation to the top of the plinth beam. That means if I add another this part, that is a plinth beam height, if I add to this, will I not get the complete height of my shuttering? Obviously, I'm going to get. So this is what I'm supposed to find now. Okay. Yeah. So that means for every foundation, for every column, I need to consider 2500 minus whichever foundation is coming on that column. No, that foundation depth I need to reduce. First thing, along with that, I need to add the height of the plinth beam, or the depth, not the height, the depth of the plinth beam. So for this, luckily in this particular project, I'll take you to the depth of the plinth beam. See, this is a plinth beam schedule. Okay, this is your plinth beam schedule. Where is that? Yeah, so it's written ground floor or plinth beam level layout. Remember, few people write this as plinth beam. Actually, plinth beam is what we write most of the time. Few people write this as ground floor. Both are one and the same. And this is that layout. But this is that entire plinth beam layout. But you see the depth here because I require the depth of the plinth beam. No, for GB1 is a ground beam one, or let us say plinth beam one. The depth is 350. Luckily, in this project, all my beams depth is 350 mm. So I don't have problem. I'll take everywhere 350 only. Just in case if there's variation, then every time we should come and see the what is the depth there. But that I'll take in the next lecture, how it has to be taken care. Now you just think that whatever depth we have, no, it is 350 mm everywhere. Now you understand 2500 minus the depth of the foundation plus I'll add the plinth beam depth, and plinth beam depth is already 350 here. This much is understood. Yeah, we'll go back to the depth part. Now I'll take this part. I'll say equal to sign 2.5 is that overall depth minus the foundation depth I need to do, minus sign I'm putting. Now directly I need to find what is my F1 footing depth. So again, one thing I need to do here, I'll deduct this, I'll delete that because the certain things we need to remember. So this is 400 and all. So this depth, no, if you write it here, it's well and good. So what you can do, I'll do one option. I'll go to this part, Excel part. Here I'll take this foundation depth. I'll take a screenshot of this so that it is easy for me to identify. Okay. Yeah, this part I'll take so that depth I can easily understand. Okay. For time being, it's also not possible. Uh, yeah, I'll keep it here. Now it's visible. Yeah, now it's visible. No. Yeah, we'll start in this way. Okay, fine. So you tell me equal to 2.5 is the overall depth minus the footing depth. Here, which footing is coming? F1 footing. Okay. Okay. On F1 footing, what is the depth of F1 footing? It is 400. So that is minus 0.4 plus what I need to do. The plinth beam depth was 350 mm, so plus 0.35. Okay. I'll hit enter. So I'm getting the depth as 2.45. Now come to the second part. The second part is C8, C12, C25 column. It is resting on which one? F2 footing. Again, I'll write here equal to sign 2.5. Okay. Minus depth of the foundation. Which footing it is resting on? F2 footing. What is the depth of my F2 footing? The depth of my F2 footing is again 400. So minus 0.4 plus 0.35. What is that? Depth of the plinth beam. So again, this remains same. Now again, come to this part. Here also again, same thing. Equal to, equal to 2.5 minus which footing it is resting? F3 footing. And F3 footing, what is the depth? 500. So minus 0.5 plus 0.35. Okay, done. Next is F4 footing. Okay, equal to 2.5 minus which footing? F4. F4 footing, it is again 500. So 0.5 plus 0.35. Yeah, next. Okay, I hope you are able to understand. Next, again, equal to sign 2.5 minus which footing it is resting on? It is resting on F5 footing. And what is the depth? Okay, this I need to this I'll take. This I'll take to the top now. Now it's okay, fine. So equal to 2.5 minus this is resting on which one? F5 footing, and F5 footing the depth is 600 mm, 0.6, and this height is plinth beam 0.35. Okay, just in case if your plinth beam height was different, then you should have taken a different thing here. That I'll explain you in the upcoming lectures how it has to be taken care of. Okay, yeah, again equal to 2.5 minus, now this is resting on F6 footing. F6 footing is 500 mm. Okay, minus 0.5 plus 0.35. Done. Okay, and next is equal to 2.5 minus, this is resting on F7 footing, and F7 footing is 400 minus 0.4 plus 0.35 plain beam. Okay, and then equal to 2.5 minus, so this is resting on F7 footing. Okay, yeah, uh, yeah, it's already done. No, yeah, this is resting on F8 footing. So F8 footing is 400 mm, so minus 0.4 plus 0.35. Done. And this last one also will same answer will get again 2.5 minus, what is that, yeah, it is resting on F9 footing, and F9 footing depth is 400, 0.4 minus how much, not minus, plus 0.35. Done. So this is how you are supposed to, this I'll delete now. Okay, I'll delete this. So this is how you're supposed to get the height of your shuttering. Okay, this much is clear. Now this part is very simple. You have to write a perimeter 200 by 350. I need to add everything, so I'll quickly do that. 0.2 plus 0.35 plus 0.2 plus 0.35. I have to give this equal to symbol here. See, if you don't give equal to symbol, it will not work. 1.1. Okay, next it is this part. Okay, next it is again equal to 0.2 plus 0.2 plus 0.35 plus 0.35. Done. Yeah, next equal to sign again 0.2 plus 0.2. Okay, it is same thing. No, then I'll copy the same thing, no problem, because you see the size of this column. Okay, this column size is same. No, I'll drag the same thing because perimeter also will be same. Okay, where it is on 350, 200 by 350, 200 by 350. This is also 200 by 350. Okay, fine. This is 200 by 500. Okay, now it will change. Equal to 0.2 plus 0.2 plus 0.5 plus 0.5. Fine. Now this is 200 by 300. So perimeter will be 0.2 plus 0.3 plus 0.2 plus 0.3. Done, no? Yeah. So again, this one is 200 by 300. So 0.2 plus 0.35 plus 0.2 plus 0.35. So 1.1. So this is again same thing. I'll drag the same thing. Okay. And now this is 200 by 500. So it is 0.2 plus 0.5 plus 0.2 plus 0 plus 0.5. Done. Okay. It won't work. Equal to sign. Fine. So it is 1.4. Understood? Now quantity is very simple. You're finding the shuttering quantity equal to perimeter. You multiply the perimeter by the height of that. You'll get the answer. You got 2.695. Drag it here. You'll get everything. Okay. Now this will reduce it to 2 digits. Now total quantity will be equal to sign quantity of column into number of column. Number of column is how much? 1. Fine. So in this way, try to drag it everywhere. You'll get the total quantity and then the conditional formatting. Done. Next, total shuttering quantity up to the plinth beam top. What you'll get? Equal to sign sum bracket open, and now you add all this quantity and close the bracket. Hit the enter. So this is the total shuttering quantity. We'll bring it at the center and then we'll align it. Okay. Yeah. Now it's okay. You can give one thick box. Yeah. Okay. 64.74 square meter is a total shuttering what I require. Which color we had given? Okay. This color I'll give. Yeah. Fine. So 64.74 square meter of my shuttering is required if I want to do 24 shuttering, 24 number of columns for all the sizes of the column. Okay, got it? So this is how you are supposed to understand how the shuttering has to be done. After this, the column will be done. Column is pretty simple. Okay. Now I hope you have understood how it has to be done. Okay. I'll quickly move this. See, this is what we have found now. Okay. This height we have found now. From the top to this part, we have found the height for all the columns. Okay. The same thing practically I'll show you what we have actually done. So practically from side point of view, This height we wanted to find, we have found the height, and this shuttering, how much was required, that also we have found. And finally, once that concreting and all will be done, this is how your shuttering will look practically. Okay. Yeah. This is how it looks. So this next, once I do the concrete quantity, I'll show you this is how it looks finally. So this is your natural ground level, and the natural ground level, to the top of the plinth beam your column will be going. Okay, to the top of your plinth beam your column will be going. Actually on the site we'll do up to the bottom only. We'll do, actually on the site this column will not be casted to the top of the plinth beam, it will be casted till the bottom of the plinth beam. That remaining part we have, no, that plinth beam part, this part. Okay, this part what we have, this part you can see, that will be done along with the beam concreting, plain beam concreting time. This much part will be filled with the concrete, but for our calculation I'm taking it till the top of the beam, not a problem. Okay, and the previous course I had taken it till the bottom, then many students had doubt, so that is why this time I'm taking it to the top, and not an issue, you can go with that. Okay, yeah. So I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you. Hello civil engineers, welcome back to the lecture. So in the previous lecture, we got the total shuttering quantity up to the plinth beam top, which was 64.74 square meter. Now what we're supposed to do, we're supposed to find the concrete quantity for that particular column up to the top of the plinth beam. Okay. So again, what I'll do, I can copy the same thing from here. I'll copy the same thing. Yeah, I'll copy this Control C and I'll write it here. This will be Control V. Okay. Now instead of shuttering, I need to write this as concreting. Okay, concreting uh, work for neck column till plinth beam top. Okay, so again, since it's a concreting work, it's always good that if you mention the grade of the concrete, it's always a good practice to be done. So what I can do, I'll write here M20 grade. Okay, previously we had used M20 only, no, for the footing. In my entire structure I'll use M20 only. Let me drag this. Yeah, so if you see here M20 I had used, so here again M20. Okay, fine. So this will be my, see now what has happened, this particular row is little big, whereas here it is individual. This part is individual, isn't it? Individual in the sense, see, this is one row, second row, third row, whereas this part is a one complete row. So if you want to make all the three row as a single row, select all the three row and go to this option called as merge and center. Now what will happen, this entire thing will be one unit, okay, or one cell. So this is 08 I guess. Yeah, it was 07, this is 08. Okay, select this, bring it to the center, make it bold, and then you can increase the size and you can even get that color. Okay, done. Now again, next thing is very simple, try to copy this. Okay, up to here you copy everything and say Control C, because for the same shuttering, wherever the shuttering is done, there your concreting will come. No, that is why. So only the thing is the unit will be in cubic meter, mention this as cubic meter, and now you drag it. Done. Here we'll put this yeah, and make it as all borders. Okay, done. Next, what you're supposed to do, very simple. Whatever is your length and breadth of your column, that is the length and the depth of your column, and the height of your column, that we are going to write it here. So one thing, wherever the shuttering is done, whatever height we got for the shuttering, there only concreting will come. Again, select all these things, Control C, bring it here and place it here, and Control V. Done. Now, whatever size you have, no, column size is already mentioned, 200 by 350, 200 by 350, 200 by 350, and so on. So just mention here 0.2. Okay, and this is 0.35. Okay, next this is also 0.2. This is 0.35. Okay, you're able to understand? Yeah. Next again, column size is 200, so 0.2 by 0.35. Okay, so this column is 0.2 by 0.35. Same thing, this column is 0.2 by 0.5 because 500 mm. This is 0.2 by 0.3. This column is 0.2 by 0.35. This column is 0.2 by 0.35, and this column is 0.2 by 0.5. Done everything. We'll bring at the center now. Click here, bring at the center. Okay, now coming to the quantity, all you know that I'm finding the concrete quantity, so I require the length. multiply that by the breadth or the depth, multiply that by the height. Okay, I mean the height of your column. So just do that. I'm getting 0.715, and then you drag it in this way. Done. Your concrete quantity you have got for a single column, you can make it. And now coming to the total concrete quantity, multiply this by the number of member. I have only one number in C1 column. Then I'll drag it for all things. Done. And now I'll reduce that. Done. Or everything I got. Now what is left out? I need to find the total concrete quantity. I'll again select this part. Okay. I'll say Control C. I'll bring it here. I'll paste it here. Okay. I'll paste it here. Done. Okay. So total, this will be total concrete quantity. Concrete quantity up to plinth beam top. Okay. So this will be again cubic meter. Control C. Say Control V. Number of column is 24. This will try to see how much value I'm getting. So sum from here to here, drag it and close the bracket, hit the enter button. 4.19 cubic meter of a concrete is required if I want to do 24 columns concreting. Okay, let me verify how much answer I got here. You got 4.18186 here. 4.19, good, no problem. There we had taken 3 digit, I had taken 2 digits here, no problem. Okay, okay. Why these things happen? This should have been 2 digit, no? Yeah, 4.19. Okay, this you can make it in red color. I didn't do that. You do all this decorations. Okay, so in this way you can make your Excel sheet to look good. And if you want, you can make it bold also in this way. So in this way, we have got the concrete quantity also for the column up to the plinth beam bottom. I require 4.19 cubic meter for concrete. Now we haven't found how much cement, how much sand, water, a coarse aggregate is required. That we'll do it later. I'll explain you how it has to be done. Then for the entire project, I'll tell you how it has to be taken care of. We can put that in the abstract sheet also. Okay, done. So shuttering quantity is done. And then this quantity is also done, concreting quantity. Okay, finally, we have got that all this concrete quantity like no C1 column, C2 column, C3, C4, C5, C6, whatever may be. We have found all the concrete quantity now. After this, we are supposed to find the backfilling quantity. What is that backfilling quantity? I'll explain you. What is that backfilling quantity? So if you see here, if I go back to this, you have done this. Now, whatever soil you excavated, you need to refill that soil. That is called as backfilling of the soil. That means you can see it here. See, in this way, you're supposed to put back the soil. Okay. Again, all these things I've explained in my construction methodology course or a site engineer course. All these things in a step by step. So in this way, you're going to do the backfilling of the soil. How much backfilling of the soil you are supposed to do? For that, we have a formula, or you can remember a thumb rule. The thumb rule is that I'll write the thumb rule here. Thumb rule is that. Okay. Remember the thumb rule. Whatever is the excavation quantity, 80% of that, 75 to 80% of that will be your backfilling quantity. That means what was my excavation quantity initially? Total, initially I got 328.82 cubic meter was my excavation quantity. Out of this, 80% of the soil will go back into the foundation. That means if I put 80% of this, I'll do that 80% here only. Okay. Equal to 0.8 into multiply by 328. So that means almost 263. Okay, you can see this 263.05 cubic meter of a soil has to go as a backfilling soil. So we'll try to verify this whether the thumb rule will work out or not. Okay, so what I'll do, I'll tell you how the thumb rule you understood. I'll write it here. Thumb rule: 75 to 80% of excavation will be backfilling. Backfilling quantity. Okay, this I can wrap the text, and yeah, I can do it in this way. Like merge it center. Yeah. This you have to remember. Now I'll explain you how it has to be done. So always remember, if you want to find the backfilling quantity, whatever is the excavation quantity, from there we'll deduct the which all. First we'll deduct the rubber soling, we'll deduct the sand filling, we'll deduct the PCC quantity, we'll deduct the footing concrete quantity, and we'll deduct the column concrete quantity. If you deduct all these things, no, you're going to get the backfilling quantities. Okay. So what we have to do? What we have to do? I'll tell you that. So equal to sign. I'll do it here only. I'll do it here. Backfilling. Okay. Equal to sign. What is my total excavation quantity? My total excavation was 328.82 minus. I've done a minus symbol here. So in this, I'll take out my stone soling quantity minus, because that is already filled. No, there your soil is not going to go. Minus my sand filling quantity 18.75 minus my PCC quantity minus my concrete quantity, footing concrete quantity, and minus your column concrete quantity. Column concrete quantity is how much? 4.19. Now everything I've done, I'll hit enter button. See how much I'm getting? I'll make it bold. 257.78. What is this? Cubic meter. Okay. This value is in cubic meter. I'll write the value here itself. Okay. So that there's no doubt. So this is in cubic meter. Okay. 257. Calculation I have done. What was my thumb rule? According to my thumb rule, what I'm supposed to get, what I was 263.05. But here how much I'm getting? By calculation 257, almost near. Even if you don't do the calculation, if somebody asks you, let us say you're working in a construction field, somebody asks you, see this much soil we had excavated, how much soil I need to do the backfilling, and how much remaining soil will be there so that I can transport it to the other place. What you'll do, you'll directly say almost 75 to 80% of the excavation soil will go back into the backfilling. Very simple, done. But there is one catch here. The catch is that I'll explain that in the next lecture. This is not the actual calculation. This is one small calculation which you need to take care of. Okay. Other than that, most of the things we have understood, that how the backfilling has to be done, and how the calculation should be done. Okay. Now I'll ask you one more question. Now, whatever backfilling soil we have done, no? Okay, this is fine. Let us say, see, this soil will be stored in some other place. Now you need to bring in the truck, and through a truck you're going to do the backfilling. Now how much truck is required to, how much truck, how many number of loads will be required to do the backfilling of this soil? Okay, always remember, I'll show you one image. Yeah, so remember, see, this is a truck what we use to do the backfilling, because you need to bring in the soil, right? So the capacity of this particular truck is almost 14 cubic meter. This particular truck can carry 14 cubic meter of the soil. So how many such loads is required? We'll try to do that. Very simple. So whatever quantity you have got, now that you have to divide it by 14. One truck can carry 14. So how many such number of loads is required? Not the truck. Truck, if you have one or two, that is enough. But how many times it has to go do the backfilling, come back, that I'm going to find. Okay. So now I'll write here number of loads. Number of loads required for 14 cubic, for 14 cubic meter truck. Okay. So that will be very simple. Whatever is your backfilling soil, you divide it by 14, because that is the capacity of one truck. So almost I'm getting 18.41. I can take it as 18, or I can take it as 19 also. I need to round up, not an issue. Just think that you require 18 trucks. I mean, not 18 trucks, 18 loads is required. That 18 loads you can deploy 2 or 3 trucks. It depends on you how it has to be done. But 18 loads is required if I want to do the backfilling of the soil. Understood? So this is how we are supposed to understand. Up to this, we have finished all the part. Up to the backfilling part is done. And after that, in the next lecture, we'll try to see how the plinth beam PCC, the plinth beam concreting, the shuttering will be done. Okay. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So one thing what I told is about the backfilling is, right. So we did everything correct. One thing, if you observe, if you remember, I'll go to the cross section part. So what we had done, we had taken the column concrete quantity up to this part, isn't it? That is up to the top of the plinth beam. We had taken the column concrete quantity. That is correct. But when you do the backfilling, your backfilling you're going to do only up to the NGL level. This backfilling, whatever you are doing, no, that will be done only up to the natural ground level. You're getting my point? Whereas, I'll show you that. This portion, okay? So this is my natural ground level. This portion, okay? This portion. Yeah, this portion is very good. See, this portion is your natural ground level. So when I do the backfilling, no, I'm going to do the backfilling only up to this portion, okay? Up to this portion. So I'll show you that part also. Yeah, you can see up to this portion, this column, whatever you have, no, up to this portion only, we are going to do the backfilling, okay? But column concrete quantity till where did we measure? Exactly, till top of the plinth beam. That means later I'll show you how that plinth beam looks. But now you understand, we actually calculated the concrete quantity up to the top of the plinth beam. So yeah, we actually calculated the concrete quantity up to the top of the plinth beam. That is up to this portion also we calculated. This portion, this extra portion you can see, okay? This extra portion we calculated, that concrete we calculated, okay? Column concrete quantity. But backfilling, where you do, you can see this backfilling, it has been only done up to the column, that is plinth beam bottom. That means whatever plinth beam size we added, no, that we need to deduct, and then we have to do the backfilling quantity. So what I'm trying to tell is very simple. Whatever column concrete quantity you had got, no, this column concrete quantity, this is not actual quantity. For calculating the backfilling, column concrete quantity is correct, but for backfilling, this additional 0.35 what we added, no, we should not take that for the backfilling. So what you are supposed to do, you calculate this, I mean, you copy the same thing, I'll say control C, okay, and bring it here. I have pasted it here. This is only for a backfilling concrete quantity, okay? Okay, very simple. Now here what we'll do, we'll take out this 0.35 from everywhere, 0.35, okay? Because backfilling will be done till the bottom of the PCC, sorry, bottom of the plinth beam. So that is why whatever plinth beam height we added, no, I'm deleting those things, okay? That's what I'm trying to do, so that I'll get the exact concrete quantity which has gone, so that the backfilling concrete quantity will come almost, I mean, we'll get a correct answer to that, okay? So the small changes you have to do. Other than that, everything whatever you have done, it is correct, okay? But one thing, this problem would not have come. This problem would not have come. I'll tell you when this problem would not have come. Now it's fine. Yeah, this problem would not have come if you had calculated the column height till the bottom of the plinth beam. Since we calculate the top of the plinth beam, that extra plinth beam portion concrete we need to deduct. So that is why I removed all that height. Okay. So, but if you had calculated up to the bottom of the plinth beam, then there is no problem. Whatever concrete quantity you had got, no, that is correct. And whatever backfilling we got, that was correct. Okay, fine. Now, finally, we have got this concrete quantity. Yeah, now it is correct, 3.57. Now you do the backfilling quantity again. So I'll tell you backfilling quantity. Okay, same thing, no changes. Only the thing is this column concrete quantity has decreased now for the obvious reason, because we are doing till the plinth beam bottom only. Okay, yeah, backfilling quantity equal to, how we'll do exactly, total excavation quantity, which was how much, 328.82 minus stone soiling quantity minus sand filling quantity minus PCC concrete quantity minus footing concrete quantity you have to take, not the shuttering, concrete quantity minus, this time it will be column concrete quantity, not this one, the one which I did now, that is 3.5, and hit the enter button. There won't be much change, hardly there is any change now. Let us say that, unless the height of your plinth beam is too much, 258.39, and here we got 257.78 exactly. Okay, so there is no change at all, almost 257.78, and this is 258.39. 39. Now why this has increased? Because that height has increased, no? So backfilling has increased now. Okay. Is it correct? No? Yeah. Yeah, backfilling will increase because in the previous case, your column height was more, no? That is why this decreased. Now it is 257, it is coming 258. Not a problem. Okay. I'll try to manually verify this answer so that will not go wrong. Okay. 328.82 minus, yeah, minus stone soling is 11.25 minus 18.75 is PCC. Sorry, sand filling. PCC is 3.75 minus footing concrete is 33.10 minus concrete column. Okay, that is this one, 3.57. Yeah, 258.4 is what I'm getting. So 258.39 is what I'm getting. Okay. So in this way, you need to take care of this. Even though if you don't take care also, it's okay. I mean, when it comes to the building part, then you need to take care of that properly. Otherwise, for the not rough estimate, otherwise you can give this estimate also, not a problem. Okay. We'll see what answer we got here. Yeah, 276 we had got in the previous case. Okay, no problem. Yeah, got it. So this is how you're supposed to find the backfilling quantity. Only thing is, remember, if you're taking up to the top of the plinth beam, then you need to deduct that plinth beam depth from the overall height of your concrete quantity, so that you'll get the exact backfilling quantity. Okay, even if you don't do also, it's okay, but always better you do that. Okay, you so that you get a proper estimate. Yeah. So I hope you have enjoyed my lecture up to here. You got this particular point, how this backfilling has to be taken care of. Okay. And we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So, in this project, I'm giving you this as a kind of assignment. Try to do it on your own so that you get a hands-on experience on this particular building. Okay. So again, this is a building what I have. Okay. And they have given a footing layout here, or a footing plan like F1, F2, F2 and all. Okay. And then similarly, we have a column layout, like which column is coming, C1, C2, C3. And then we have this complete details. Okay, that is the footing name is given F1, F2, F3, and the size is given, column size is also given, depth of the footing is given, and the reinforcement, which we don't require now. Now the section, the cross section part also they have given, like you can see it here. In the cross section part, they are given from your ground level, you have to do an excavation of 1800, and your PCC thickness is 100 mm, and your rubbers and the stone soling, that is 150. Okay. Now what you do the assignment for this particular building, how much excavation quantity is required, how much concrete quantity and all. Okay. How we are going to do? Very simple. Already you have created an Excel sheet like this. Now what you do, you just right select here, like whatever Excel sheet you have created, no, right click on your mouse, and there's one option here called as move or copy. Okay, move or copy. And now here you write create a copy and say okay. So one more copy will be created, like sheet 7, third copy is created here. Okay. Okay. Now what you do, there you change all the name. So and then you can work on this. Why is that so? Otherwise you have to write everything. Now you don't have to write anything here. Much of the things is already written. The format is ready. Only the values we are going to change, that we'll do it later. Okay, fine. So I'll quickly try to do it now. Okay. So what I am going to do, I'll just take a screenshot of this for my understanding. Okay. So there is no much footing. Quickly we can finish this. I'll take this. Yeah, I'll go to the Excel sheet and let me paste it here. Okay, fine. So quickly write it down. I think only F1, F2, only F5 footing is there. Rest all things are not there. No, you can delete it out. Okay, I'll delete it and delete it. Okay, and now F1, you quickly write the footing name. So 2900 by 2900 by what is the depth of your footing? It is 500. So F1 is done. Similarly, write for F2. Again, F2 is 3200 by 3200 and by your depth. See, this is a depth. Okay. This D you can see, no, it is a depth I'm taking 600 mm. Similarly, go for F3. F3 footing is 3500 by 3500 by 600 mm. Okay. Next, F4 footing. No, again F4 footing. After this, I'll tell you one more trick where you can do even simple Excel sheets where you don't have to change, where you don't have to write all these names every time. Okay. So I'll tell you after that. Once let us finish this. 3350 into 3350, multiply this by 600. Done. I think all the footings have written 500, 600, 600, 550, 600. Yeah, just you have to verify. Okay, whenever you write something, try to cross verify it. Yeah, done. So this will be in cubic meter. Now number of footings. We don't know from here number of footings. I'll go back to the drawing again. So here I'll count how many F1 footings and all are there. It's not mentioned here. So go back to the drawing and now you count 1, 2, 3, 4, 5, 6. So there are 6 F1 footing mentioned here, 6. Okay. Now the Excel sheet is changing everything. Okay. Because already we have done the linking of that. No? F2, 1, 2, 3, 4, 5. Yeah, there are 5 F2 footings. So I'll write F2 is 5. Now go for F3 footing. So F3 again. No F3 here. 1, 2, 3, 4, 5, 6. So there are 6 F3 footing. 6. Now F4. 1, 2, 3. Yeah, there are 3. So write F4 3. And the last one is F5. 1, 2. There are 2. Okay, good. So I think there are 2, no? 2. Now automatically this number also will change, isn't it? See, 22 footings I'm getting. Let me verify that whether there are 22 footings or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Done. So 22 footings are also done. Everything is done. Now next what you're supposed to do, this thing. Okay. Now here what we can do, we have two options. I'll tell you. First you have to look into the drawing, like what is the this PCC offset we have taken. No, see, working space will remain same for all the drawings, most of the drawings, unless there is a change. Otherwise you can take 300 this PCC offset, no, it depends from consultant to consultant, but we'll try to see whether they have given anything here or not. So in this particular project, no, in this particular project I don't see that any of the PCC offset is given. You see, these people have not given any PCC offset. Why? Because see here, this is a footing. Agree with me? And beneath that only these people have put the PCC, and beneath that only they have put the stone soling. Actually, how it should have been? It should have been something like this, isn't it? You should have got a offset something like this, and then it should have been something like this, isn't it? And this extra, whatever you can see, this part extra, and this would have been your PCC offset. Actually, you have to take in drawing, it's not given, but now what we'll do, we'll consider, not an issue, we'll consider it to be 50 only. Okay. Otherwise, see, usually we have to do, even though it's not there in the drawing, we have to consider the PCC offset. That is the criteria, or that is the way we try to do. Okay. Now, in order to save our time, I'll consider that here the PCC offset is given 50 only. See, this is not that PCC offset. This is the thickness of the yeah. Let me check out what is mentioned here. See, this is PCC. What is this 50 then? Okay, this is clear cover. Okay, this is clear cover for the foundation, and this is your top portion clear cover. They are not mentioned. So for my easiness, what I'll do, no, I'll consider that in this project also they have given the PCC offset of 50 so that my calculation will remain simple. Okay, what all thing I need to change now here? See, instead of 1.2, no, I'll input 2.9. You got the answer? I'll write 2.9. Why is that I done 2.9? Because previously it was for the other footing, no? So now you understand 0.3 working space, 0.05 PCC offset plus 2.9 is my length plus 0.05 PCC offset and 0.3 working space. Now you just drag the same thing on the right side. Done. Okay. Now again come here. Here what will happen? So this is not 1.4. I'll make this as 3.2. And how did this 0.7 come? 0.3 plus 0.3 plus 0.05 plus 0.05. So totally I've taken 0.7. Okay, done. 3.9 I got. Now here also not 1.85, so it will be 3.5. Done. Okay, this you just drag it on because all the footing sizes are same, no? Yeah. Next is 3.1. So this is 3.1. Yeah, this is 3.35. So I'll make this as 3.35. Done? Yes. You do it manually also, no problem. And try to verify it so that you build a confidence. Now coming to the depth of your excavation. Okay. So how you are going to find the depth of your excavation? Now you see here. My ground level is here. And here already these people have mentioned from the ground level, you are supposed to do an excavation. From the ground level, you are supposed to do an excavation of how much? 1800. But where these people have given, no, they have given it till the top of the PCC. They have given it till the top of the PCC. But where we are supposed to do? We are supposed to do the excavation till the bottom of the PCC. That is, till this bottom we are supposed to do. That means we need to add the PCC thickness. So this will be, I'll write it here, 1800 plus, I'll add the PCC thickness. This 100 mm I need to add plus 100 plus, what is the depth of a stone soling? This is 150. Are you able to understand? This is 150. So now you do the calculation. Now if I do this, very simple, 1800 plus 100 plus 150, I'm getting 2050 mm. So this is your actually excavation depth. Okay, got it? So always be careful whenever you're looking into the structural drawing, whether that depth is given till the bottom of the PCC or the bottom of the stone soling or till the top of the PCC. Here they had given it till the top of the PCC. So I added this 100 mm extra, that is a PCC thickness, this point, and then I added another 150 as a stone soling. So I'm getting 2050. Now very simple. Come here, just input 2050, 2.050. Okay, and now you drag it. That's it, finish. And answer is ready. So the total excavation quantity is 688.34 cubic meter. Okay, you have not done anything wrong. You try to do it manually also, so that even though time goes, no problem. Try to do this manually. You should get 688.34 cubic meter. Let me verify the answer once again. 159.41 plus 155.90 plus 216.97 and plus 88.81 plus 67.25. That's it. 688 I'm getting. Good. Got it. So in this way, you're supposed to do the um, excavation quantity. Now quickly I'll do the stone soling and the other part also. Okay. Now what you're supposed to just copy the same thing. Okay. No changes. Copy this entire thing. Control C. Bring it to the stone soling and paste it here. Control V. Okay. Everything. Now what you're supposed to do in the stone soling, few things will change. Okay. Okay. Stone soling. Okay. Otherwise we could have kept the previous case only. Anyhow, I'll do that. No problem. Stone soling, what will happen? Come back to the drawing now. We need to do this stone soling. How it will happen? Footing size plus only the both sides the PCC offset will remain. Working space we have to take out. Okay. So again, I'll go to the Excel sheet. What I can do is here I'll take out those things. Okay. This part I'll remove. And this part also I'll remove. Now it's fine. Yeah, 2.9 plus 0.05 on the left side, 0.05 on the right side. Done. So 3 will come. You just drag it here also. Done. Here, yeah, yeah. Here I'll directly write 3.2. Okay. Plus it is 0.05 plus 0.05. It should be 0.1, no? 0.05 plus 0.05. It is 0.1. Good. Done. Just drag it again. 0.1. Done. Drag it. 0.1. Drag it. then 0.1. Okay, fine. See, if you don't understand anything, you can always ask me. Okay, 3.45. Yeah. Now this one, this is very simple now. What we'll do? What is the height of your stone soling? You have to refer the drawing. It is mentioned your stone soling you're supposed to do 150 mm. Okay. So what we'll do? We'll directly input 150 here. That is 0.15. 0.15. Enter. Done. And just drag it here. You'll get the answer. That's it. You got the answer. 36.11 cubic meter of a stone soling has to be done. 8 plus 8 is 16. 16 plus 11 is 27. 27 plus 4 is 31. 31 plus 3 is 34. And then this point comes out to be 36.11. Done. Now, sand filling, you don't have to do. Why? In this particular drawing, there is no sand filling. Soon after the stone soling, directly these people have done the PCC work. So what you'll do, anyhow, you have to prepare a new Excel sheet. But since we already prepared this Excel sheet, I'll just delete all these values. I'll say delete. Now there is no sand filling quantities. Okay. Directly we'll go to the PCC part. PCC is again simple. What you do, just copy everything from here because stone soiling and PCC there is no much difference. Only the thickness difference will come. So instead of 0.15, go back to the drawing. So this is your PCC. What is the thickness of your PCC? The thickness of your PCC is 100 mm. You can say 100 mm. Stone soiling was 150. Your PCC thickness is 100 mm. So nothing will change. Only wherever you have put this 150, no, make it as 0.1 and then you drag it 0.1 and just drag it in this way. Done. Finish. Your answer is ready. 24.07 cubic meter. You just have to make this as PCC. Okay. Total PCC quantity. PCC quantity. Yeah. 24.07 cubic meter. This you make this as stone soiling quantity. Total stone soiling. Got it? This much is understood? Yeah. Stone soiling is done. Even the PCC part is also done. Next is footing shuttering. Now for the footing shuttering, what we'll do? For the footing shuttering, I'll again copy this same or original size. Okay. This is the size of my footing. I'll copy this. And the number also I'll copy. This much part I'll copy again. Control C. And for the footing shuttering, I'll paste it here. Okay. F5. No, this restings is not required. I'll take it out. Done. Only how many are there? F1, F2, F3, F4, F5. Good. So this answer will be in how much square meter? Since we are doing a shuttering quantity, just change the value, scroll it down. Done. Number remains the same. That is 22 numbers everywhere. Now coming to the perimeter. So perimeter, how we are going to do? We know. So everywhere the size is same here. Understand the concept. 4 multiply by, it's 2.9. No, I'll multiply this by 2.9. 2.9, 2.9, 2.9 and 2.9. So 4 sides. Done. Next is 3.2. Here. Here also 4 into 3.2 I'll do. Okay. Or you can do 3.2 plus 3.2 plus 3.2 plus 3.2. Or simple you can do 4 into 3.2. Done. 12.8. Next again 3.5. So already 4 is written. I'll make this as 3.5. Next is 3.1. So 4 into 3.1. Okay. Done. No? Correct. Yeah. Next is 3.35. 3.35. Done. That's it. Finished. Now coming to the depth of the foundation, it's already here. 500 mm. Make this as 0.5. Okay. This is 600. 0.6. Next is 600. 0.6. Next is 550. 0.55. Next is 0.6. 600. Done. The shuttering quantity is ready. You will get 160.14 shuttering quantity. How it will come? 11.6 into 0.5 will give me 5.8 and 5.8 into 6 will give me 34.8. So this is the benefit of doing the Excel sheets. You do it for one and then just copy it. 34.6. Okay. 34.8 I'm getting. Good. Okay. Now coming to the footing concrete quantity. Again copy the same thing. First let me delete. Okay. This total footing shuttering quantity. I'll delete this part. And we'll copy this part. Yeah, and this is total footing concrete quantity. Okay, concrete quantity, and this will be in cubic meter, and this also will be in cubic meter, and then just drag it. Done. Okay. Hmm. So how it will happen now? Very simple. Delete all these things now. This also you delete, and then you just have to write 2.9. That side also it is 2.9. We are doing the concrete quantity, no footing. 2.9, 2.9, and the depth of your footing. Okay, done. 3.2, and this is 3.2. 3.5, 3.5, 3.1. So this is a bit easy for us, no? Because all the footing are of same size, the length and the breadth. So there is no much difficulties. Done. The concrete quantity is ready. You require 40.04 concrete quantity for this 22 footings. Now the last part is the shuttering work. Now in the shuttering work, this particular thing will not work out for us, because in the shuttering, you have to go back to the drawing again here, and now you need to check, right, on which column which footing is coming. Like on F1 footing, how many columns are coming? So I have one F1 footing here, one F1 footing here, and then there is a another F1 footing somewhere here. So how you are going to do? You need to check the column also, which column is coming on which footing. So for that, in the next lecture, I'll explain you how these things should be taken care of. Okay, so I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you. Hello civil engineers, welcome back to the lecture. So here we'll try to see how to take care of the column part. Okay, now in this particular drawing, they have just mentioned the footing here, and they have shown a column here, but haven't mentioned the column name there. But they have given one more drawing where only the column is shown. Now what you need to do, you need to take two separate drawings, and then you need to check on which footing which column is coming. So what I've done, I've taken a screenshot of this, and also I've taken a screenshot of this, and then I'll put it here. Okay, I'll show that. I'll put it here, right? This is my footing screenshot, and this is my column screenshot. Now I can directly write, no, on F1 footing, this is a column. I'll write C1 here. Okay, shall I write in front of you? I'll write C1 here. Done. Okay, yeah, this is C1. Okay, on F1 footing, this is C1 column. Okay, then on C2 again on F2 footing, this is C2 column. Okay, we'll quickly write all these things. Already I've written it here. See, I'll show you one more picture. See, already I've written all those things. Okay, I'll be attaching this also. Else you can do it, because I'll not spoon feed you everything. You need to try to work out on these things so that you get a hands-on experience. Okay, so on F1 footing, C1. See, it's very simple. I'll tell you how it has to be done. Whatever column you have, no, just write on the footing. That's it. F1, no, write C1. This is second, you write it here. This C2, you write here. This C1, you write here. This C2, you write on this footing. This C3, you write on this footing. This C4, you write on this footing. This C3, you write on this footing. C1, you write on this footing. In this way, I've done it. I've written it in this way. Now it's easy, no? Everything is written. Now you need to write this in the Excel sheet. So you count on F1 footing how many columns are coming. This is F1 footing. On this C1 column is coming. This is also F1 footing. Here also C1 column is coming. Then again, where is F1 footing? This is also F1 footing. C1 column is coming. Again, this is F1 footing. C1 column is coming. Again, this is F1 footing. C1 column is coming. Again, F1 footing. C1 column is coming. That means on all the F1 footing, C1 column is coming. So what I'll write here, I'll go to the Excel sheet now. Yeah, this is the Excel sheet. Yeah, I'll take it out. Okay, I'll take out all these things. I'll write here C1 column on F1 footing. See, always remember, when you do this column part, no, you should take footing as your base. Okay, that means F1 footing is a base. On F1 footing, how many C1, C2 columns are coming, that you need to take care of. How many C1 columns are there, we'll write it later. Okay, fine. Now F1 is done. Now we'll go to the second part. Now I'll try to check for the F2 footing. So this is my F2 footing. On this C2 column is coming. This is also F2 footing. C2 column is coming. Again, you check if there is any other F2 footing. No F2 footing here. No F2 footing here. And there is another F2 footing here. But here also C2 column is coming. Here also we have another F2 footing where C2 column is coming. Here also we have another F2 footing, C2 column is coming. That means what I'm going to write now? Exactly. C2 column, C2 column, C2 column on F2 footing. Okay. You should also mention the column size here. We'll do that later, no problem, because we don't have much columns here. Okay, done. Now again, we'll go to the third part. Now we'll search for F3 footing. So next we'll search for F3. Okay, F3 footing is here. On this we have C3 column. Yeah, now you see, here we have F3 footing, but here we have C4 column. On one F3 footing we have C3 column, and one F3 footing we have C4 column. Now we need to write two times. Okay, first we'll try to check on F3 footing how many C3 columns are there. F3 footing, one C3 column. Then again your F3 footing, C3 column. On F3 footing, C3 column is there, and F3 footing, C3 column is there. So that means 1, 2, 3, and 4. So now I'll write C3, C3 column on F3 footing. Okay, one thing is done. Still, my F3 footing is not done. Still, I have that. See, F3, F3, this F3 part I did, this F3 part. Again, I have F3 here. So on this F3, we have C4 column. On this F3, we have C4 column. So now what I'll write? I'll write C3 column, C3 column on exactly F3 footing. Okay. Wait, not, it is not C3 column. The column name should change now, because this is, yeah, C4, C4 column. Yeah. Mention this as C4 column. C4 column on F3 footing. Got it? Now after this, F1 is done, F2 footing is done, F3 footing is done. Now check for F4 footing. No F4 footing here. See, one F4 footing is there. On that we have C2 column. Again we have F4 footing. No. We have another F4 footing here. C2 column is there. Then no more F4 footing. Another F4 footing is here. C2 column is there. Another F4 footing. No more F4 footing. No more F4 footing. That means 1, 2, and 3. So that means which column is that? C2 column on F4 footing. So I'll write here C2, C2 column on F4, F4 footing. Okay, done. After that, so F4 is done. Next, we'll search for F5 footing. So again, F3, this is F5, right? So on this F5, which column is there? C3 column is there. Again, F5 we have. Yeah, we don't have any other F5. Here there is an, yeah. So this is F5 here. On this we have C3, and then there is no more F5, right? So there is no more, yeah, another F5 is here. So we have C3 column on that, and then there is no more F5, I guess. Yeah. So we'll write C3 column on F5 footing. So we'll write here C3 column on F5 footing. Okay. Can make this as F5. Fine. So I think F1, F2, F3, F4, F5 is done. Is there anything left? No. Only F5 footing was there, right? Yeah. How many footings were there? F5. Everything is done. Done. So this shuttering work, so it will be in square meter only. This will take it out. Now we need to count the numbers. Okay. That we could have done parallelly, but not an issue. First, we'll count how many C1 columns are there on F1 footing. On F1 footing, how many C1 columns are there? Okay. C1 column on F1 footing 1, 2, 3, 4, 5, 6. So we'll write 6 here. 6 number. Next, C2 column on F2 footing. C2 column on F2 footing 1. C2 column on F2 footing 2. Then C2 column on F2 footing 3. C2 column on F2 footing 4 and 5. So we'll write 5 here. Okay. Done. Next, C3 column on F3 footing. C3 on F3. So C3 on F3. So F3 we have here C3 1, then again C3 F3 2, C3 F3 3, C3 F3 4. So 1, 2, 3 and 4. So we'll write here 4. Okay. Yeah. Now we'll search for C4 column on F3 footing again. Okay. C4 column on F3 footing. So this is one C4, second C4 on F3. So only two are there. We will write directly 2 here. Okay. Fine. Now C2 column on F4 footing. C2 column on F4 footing. So C2 on F4. So this is C2 on F4 1, C2 on F4 2, C2 on F4 is 3. Yeah, so 3 are there, right? C2 on F4 1, C2 on F4 2, C2 on F4 3. So 3 are there. Yeah, we could have done this in the initial stage also, but it's okay, no problem. Okay, next last one is C3 column on F5 footing. C3 on F5. So C3 on F5 1, C3 on F5 is 1, and C3 on F5 is 2. Okay, 1 and 2. So there are 2. So now we count how many footings we have got. 22 footings, I mean 22 columns we should get. That should match the footing number, and obviously it will match. Okay, we'll count it still. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Exactly. So 22 we have got. So 22 footings have come. Now coming to the perimeter part. Perimeter you can do it very simple. For that I require the column size like C1, C2, C3, 4 and C5 column, right? I think yeah, columns are only up to C4. I'll go back to the drawing. So for that, where you have to go, this drawing is already provided. You see here, okay, already I've given this column. See, wait, let me come here. I'll check the column part. Yeah, see here, those things are given, okay. Actually, they should have given it in the table, but not an issue. They are given it in this way. You can see it here. So this is C1 column. The size is 450 by 450. C2 column 450 by 450. C3 column 450 by 450. C4 column 450 by 450. Right? So all the columns are 450 by 450. The same thing is mentioned here also. In this particular table, this table you can see 450 by 450, 450 by 450, 450 by 450, 450 by 450. So it's very simple. Our calculation will be very simple now. I'll just write equal to sign 0.45 into 4 side. Okay, done. So my perimeter is done. 0.45, 0.45, 0.45 and 0.45. I'll just drag it everywhere. Okay, done. All columns C1, C2, C3, C4, C2, C3. Okay, done. Now any of this part will now come into the height of your column. Shuttering work, you have to go back to the drawing. See again, remember this shuttering, whatever we are going to do now, the shuttering will do till the top of the plinth beam, isn't it? I told you, you have to take it up to the top of the plinth beam. See, this is your ground level. You can even take up to the bottom of the ground level. I mean, bottom of the plinth beam. But again, then later you need to add this part separately. Instead of that, you take it till the top only. Okay, this is my top. Now again, same thing. We know that from the ground level to the bottom of my foundation, it is 1800. But I require the height from the top of the foundation. That means 1800 minus whatever is the depth of the footing which is coming on that column, that you need to deduct, plus this height, plinth beam height. This is your plinth beam. Okay, so this plinth beam you need to add. The depth of the plinth beam should be added to this height. So how you are going to take care of the plinth beam? Again, for that you have to go back to the plinth beam. Come here, you'll get a plinth beam layout drawing. Okay, you'll get a plinth beam layout drawing. See, this is how that cross section looks. If you don't understand, see here, this was my footing. My column is coming here. Okay. Now, right now, this much part will be able to get this much part. Okay. Now, this is your plinth beam. This plinth beam also I'm going to add now. this much part of the plinth beam, I'm going to add it now. Okay, so what I'll do, yeah, so I'll come here. So this is your plinth beam layout. So it's, can you see it here? Plinth beam layout plan, right? So whatever is the depth, no, that you need to consider. But luckily, here you see everywhere the depth of your plinth beam is 500. This 300 is a width and 500 is a depth of your beam. So 300 is a width, 500 is a depth. So almost all the beams, whatever plinth beam you have, no, you see everywhere the depth is 500. So what we are supposed to do, everywhere we'll add 0.5 to that. That's it. Okay. Everywhere we'll add 0.5 to that. So that is how it works out to be. Okay, so even the cross section also will verify once again. The cross section is also correct. There is no problem, because see, soon after the ground level only your plinth beam is resting. Okay, soon after your ground level, see, this is your ground level. Soon after this ground level, your plinth beam is coming. This is your plinth beam. So this is your plinth beam. Okay, that means whatever is our depth, it is 500, that I'll add. So I'll reach to the top of the plinth beam. But these people have made one small mistake here. See, what mistake is that? In the cross section part, no, this part, they have shown GL here. If they had shown GL here and the plinth beam is coming here, see, this is that plinth beam. Okay, this is a plinth beam, and the GL is ending here. So this much portion you can see they have left it blank. That means there should be some height here, but maybe either there is a problem in the cross section or they might have not done it properly. Not an issue. Usually wherever is a ground level, no, over that only your plinth beam is going to come. So actually either this ground level should have come here, they should have shown the ground level here. Okay, then it would have been correct. But here what has happened, ground level they are showing it here, and the plinth beam cross section they are showing it here. This portion, this much space is empty, right? So we don't know what is the height of this. So either this is wrong or that is wrong. But we'll consider, exactly on the ground itself your plinth beam is coming. I'll show you one case for that. For example, just in case if you get confusion, no, I'll tell you. See, so in most of the drawings, what will happen, you get all the elevation part and all. Okay, here you can see the elevation is given. This is one more drawing for a different building. I'll show you the elevation part. Yeah, you see here. Yeah, now you'll be able to understand what exactly I'm trying to tell. See, this is a ground level. They've shown the ground level here, and they've shown the plinth beam here. They've shown the plinth beam here. Okay, plinth beam is shown here, and the ground level, I'll do it here. This is my ground level. This is my ground level. And now, from the ground level to this much height, in the bottom of the plinth beam, these people have done the brickwork. Okay, usually people do that. Usually what people do, they want their plinth to be at a, at a greater height. In that case, they do the brickwork, and over the brickwork, they'll do this plinth work. Okay, so you can see the brickwork has been done here, isn't it? The brickwork has been done here. How much is the brickwork they have done? They are mentioned here. It is 1 feet 6 inch. 1 feet 6 inch. And what is the depth of your plinth beam? It is 1 feet. Now, when I try to add, no, I can add 1 feet 6 inch plus 1 feet. It comes out to be 2 feet 6 inches. From the ground level to the top, this much height, I can take 2 feet 6 inch and I can add it. You're getting my point? For example, let us consider the same situation from the ground level to the bottom of my this thing. What is that? PCC. The height was given, let us say, the same height I'll consider, 1800 mm. So in this case, what I would have done, I would have taken this 1800 plus 1 feet 6 inch plus 1 feet I've added to this. So this would have given me the height till the top of the plinth beam. Okay, this should have been a drawing something, but here no problem. In the assignment part, whatever I've given, because sometimes in the drawing such problem occurs, you just need to ask to the consultant what exactly you want to do. So he may tell, no, we are going to do a backfilling here, or we are going to do a brickwork here for around 1 feet. 1 feet is 300 mm. Then no problem. You add 300 plus the depth of the plinth beam. Okay, but here we are just considering, because in the cross section, because this cross section what I'm showing you now, if you observe it carefully, see the cross section what it shows, soon after the ground level only they have shown the plinth beam. Okay, they have shown the soon after the ground level, your plinth beam is shown here. So that means on the ground itself, your plinth beam is happening. So there is no gap. So we are considering the same thing. No problem. I explained you both the things. Okay. Okay. Only that problem will occur just in case if you get some other drawing. Just verify with the consultant how much gap you're going to give that. That gap you just have to add it. Okay. Now I'll consider this 1800 footing depth I'll deduct, and plus this is how much 500 because depth of plinth beam was 500. So I'll go back to the Excel sheet. These things I'll let me remove it out. I'll do it. This has yeah. I need one more thing here. What is that? I require the depth of F1, F2, F3 footings and all. So quickly I'll take a screenshot of this. This depth I require. This depth I'll keep now. Okay, fine. Now I'll do that. Now this height is 1800. Yeah. So this is 1800 minus this depth I'll do. And for that I'll add 500 mm. Remember that. Okay. So equal to sign 1.8 minus depth of foundation. So this C1 column is resting on F1 footing. So what is the depth of F1 footing? 500. So minus 0.5 plus 0.5 I'll do because plus y depth of the plinth beam I'm adding. Okay, fine, done. 1.8 I got. Again here again same thing. 1.8. Okay, minus it is resting on F2 footing. What is the depth of F2 footing? It is 600 mm. So minus 0.6 plus 0.5. That is the depth of the plinth beam. Fine, equal to again 1.8 minus it is resting on F3 footing. What is the depth of F3 footing? Again 600. 0.6 minus plus 0.5 depth of plinth beam. Fine, equal to 1.8 minus this is resting on again F3 footing. Again F3 footing depth is 600. 0.6 plus yeah plus 0.5. Yeah, like again 1.8 minus this is resting on F4 footing. The depth of F4 footing is 550. 0.55 plus 0.5 is the depth of the plinth beam. I'm adding it. Okay, 1.75. Next last 1.8 minus F5 footing. C3 column is resting on F5 footing, and F5 footing the depth is 600. 0.6 plus 0.5. Done. You got all the heights here. Okay, so you got all the heights here. That is 1.8, 1.7, 1.7, 1.7, 1.75, 1.7. So depth I'll verify once again. Yeah, it is 500. All the depth is 500. Okay, fine, no problem. I think everything I have done. Answer will come automatically on its own. Since where is the answer? Yeah, this is that answer, no? Yeah, good. 68.67 square meter of a shuttering is required for all these columns. Okay, 22 columns I require 68.67 square meter of the shuttering. Now, similarly, you do the concreting also. Concreting again, same thing. What you are supposed to do, just copy the same thing from here. Okay, I'll just copy the same thing from here. Control C. I'll come here. I'll just paste this Control V. Okay, done. And now this part I need to take it out. When this I need to delete. This also I need to delete. And this part also I'll delete. And this height will remain the same because wherever shuttering is done, there only your concreting will happen. Now directly enter the size of column. All my column sizes are 450 by 450. Agree with me? It is already mentioned here. See, this is 450 by 450. Even here also you can get 450 by 450. So just your task is very simple. 0.45. Your length of the footing, I mean breadth and depth both are same. 0.45. You got the answer. Just drag it down up to here. Just drag it up to here. That's it. So you require 17.17 cubic meter. So just change this. So this is total concrete quantity. Concrete quantity up to the plinth beam top. Okay, fine. So total concrete quantity also we got. Now how you are going to do the backfilling quantity? Backfilling will be very simple. Quickly I'll tell you how it has to be done. Backfilling. So backfilling will be total excavation quantity. What is my total excavation quantity? So my total excavation quantity is 688 minus I'll remove which one? Stone soling quantity. Good. Minus I'll take out the PCC concrete quantity. Good. Minus, I'll take out the footing concrete quantity, and I'll deduct the this part, column concrete quantity. Again, remember column concrete quantity. You remember, right? What mistake we are doing? We're actually taking a, yeah, it comes out to be 588. Yeah. So actually, this column concrete quantity we have taken up to the top of the plinth beam. That plinth beam depth, whatever you have, that you need to deduct. I'll not do that. You do it on your own. Very simple. I'll tell you what has to be done. This is not actually the value. I'll tell you the actual value. From here, no, just deduct this point, deduct this 0.5 from all the table. Else I'll do that. I'll quickly do it for you. I'll control C here. I'll paste it here. Okay, yeah. From this part, and just take it out 0.5. Okay, that plinth beam top you have to remove, because backfilling will happen till the ground level only, not till the plinth beam top. Okay, yeah, everything I removed. So this is the actual concrete quantity which you have to consider for the backfilling. So here what I'll do, instead of IJ20, I'll take this part minus this part, and I'll say enter. Done. So your this thing, backfilling quantity is 588.12. I'll manually verify this once again, so that will not go wrong. Okay. Total excavation was 688 minus stone ceiling was 36.11 minus PCC was 24.07 minus footing concreting was 40.04 minus last one is concrete quantity. Okay. So this concrete quantity I have to take. Which one? 12.22. 12.22. So I'm getting 575. Okay. Then this is wrong. I'm getting 575.56. Let me do this once again. Okay. 688 minus 36 minus 24 minus footing concrete 40 minus concrete quantity, this one. Yeah, 575.90. I'm getting same thing in my calculator. Okay, good. So this is how you're supposed to understand. Again, you apply the thumb rule. We'll see whether my thumb rule will work out or not. 688 is a total quantity. You take 80% of that. That means 688 into 0.80 you do. I'm getting, okay, 0.75 you can do. 0.75. We'll take 0.80 only. Okay. So 688. I'm getting 550. 550 cubic meter is a backfilling. But when we do the calculation, we are getting 575. We are falling short by 25. I mean, it's a rough one. Okay. You cannot, but if somebody asks you, you can say 75 to 80% of that. Okay. I'll do that here also. Equal to 0.8 multiply this by total backfilling. I mean, total excavation quantity. Done. So it comes out to be 550. But while doing the calculation, we got this. Okay. Calculation is always correct. This is just a thumb rule. Okay. This is just a thumb rule for us. Okay. Got it? Yeah. So in this way, you're supposed to do the calculation for this particular building. I've done everything for you. After this, I'll give you another 2-3 different assignments. I'll not do everything now. You understood the concept. You try to do it on your own, but I'll give you a few drawings. I'll give you another project. I'll give you another 2 projects. I'll give you this particular combined footing project. Then I'll give another house project, so that you get complete knowledge regarding this. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So this is a final Excel sheet what I'm trying to show you. Okay, maybe somewhere actually there was one mistake what I did. In case of footing concrete quantity, I had got the answer 40, but I hadn't done the proper calculation. Okay, I forgot to multiply these 3 quantities, so I was getting a 40 cubic meter of answer, but the right answer is 129.374. Okay, after that I have gone through all my calculations, and this is a final calculation what I've done, and you should get the same answers. So quickly I'll run through this once. Okay, so these are the 5 footings what I had written.
So it is earthwork. The unit should be in cubic meter. The numbers are 65632, and this is length. Okay. After adding the working space and the PCC offset to that. Okay. And this is how it is. Depth, thickness, quantity. So excavation quantity is 688.339 cubic meter. Okay. Then after that come to the stone soling. Again, stone soling unit will be in cubic meter. You'll get answer of 36.110 cubic meter. Then we don't have sand filling here. Then we have a PCC of grade M10, which is 1 is to 3 is to 6. Okay. And so here also you'll get the total PCC quantity of 24.074 cubic meter. Then the footing shuttering quantity will be 160.14. So your perimeter we have got, and height we have. So the total area will be 11.6 into 0.5. And based on that, I've done this calculation. Okay. And you have got 160.14 square meter is my footing shuttering quantity. Then my footing concrete quantity, again, it's a concrete quantity. So it will be in cubic meter. So this is the answer what I've got. So quantity will be 2.9 into 2.9 into zero point 0.5. So 4.205, 4.205 multiplied by 6 will be 25.230, and when I drag it, I'll get all the answers. So the total footing concrete is 129.374. Next, in the shuttering work of neck column till the plinth beam top. So here I've written plinth beam top. Okay, so that means I have explained you how this height has to be taken. So 1.8, okay, then the footing depth I've deducted, and then I've added the depth of the plinth beam to that. So with this, I'll get 1.8 into this answer will give me 3.240, and the total shuttering will be 3.240 into 6 will give me 19.440. And if I drag it in this way, I'll get the total quantity, that is the total shuttering quantity up to the plinth beam top I'm taking. The unit is in square meter, so it is 68.670. Okay, fine. Next is, once the shuttering is done, we have to do the concreting. Again, for the concreting, your foot is this thing. The column sizes is same here, 0.45 into 0.45, and height is again same. Whatever, wherever you do just shuttering, the same height will be your concreting height. So this will be 0.45 into 0.45 into 1.8, and total quantity will be 0.365 into 6. And when you drag it in this way, it will make sure that it is taking all the answers correctly. Okay. Yeah, that's how it is. So here the total concrete quantity of the neck column you are going to get. See, one mistake, not mistake. Here I should write cubic meter. Always try to check the units and all, because while explaining, sometimes I may not write, sometimes I miss it, but that is okay. But you people should not do that mistake. So this is 7.725 cubic meter for concrete is required. So whatever we did now, so this is up to the plinth beam top. But if you remember, I told you backfilling we are going to do till the bottom of the plinth beam only. Okay. And after that, the plinth beam will be casted, then the remaining backfilling will be done. So if you take this concrete quantity also, it's okay. But if you want to be more precise, then what you should do, you should calculate the concrete quantity till the bottom of the plinth beam. So that is what I have done it here. So whatever I have written here, so this is concrete quantity up to the plinth beam bottom I have taken. So this was top and this is bottom. Nothing will change. Everything will remain the same. Only the thing is the height point. No, in the height, we had added the depth of the plinth, that is 0.5. Everywhere we have added 0.5 because this was including the height of the plinth beam. But actually when you do the backfilling, it will be till the bottom. So what I've done, from that height, I've deducted the 0.5. Here it was 1.8 plus minus 0.5 plus 0.5. So this 0.5 I've taken out. That is why I'm getting 1.3 here. Okay. And just you have to do the calculation wherever in all of the cases, deduct 0.5, 0.5, 0.5, 0.5, and 0.5. Accordingly, you're going to get the answer. And this is a real quantity. This is a real quantity of the concrete column, which will go up to the bottom of the plinth beam. If you want up to the top of the plinth beam, it will be 7.725. That's it. Okay. And after that, the backfilling quantity will be how much? Whatever is my excavation quantity. So my total excavation quantity is 688.339. From this total excavation quantity, if I deduct my stone soling quantity, if I deduct my PCC quantity, that is 24, if I meet if I deduct my footing concrete quantity, which is 129.374, and if I deduct my column concrete quantity, but in column concrete quantity, you should take the one which I've done up to the bottom of the plinth beam, that is 5.50. If you take, no, you'll get 409. Yeah. What will be the answer? Yeah, you'll get 493.284 cubic meter for backfilling will go. Okay. So this will be, wait. Got it, right? So why this 491 coming? For 491, I took off by taking column height till the top of the plinth beam. So it is little less, that is 491. Here 493 is coming. That doesn't make any sense. And this 550 is what? I've taken 0.8%. Even you can take 0.75% also. Okay. If you take 0.75, it is coming 516 cubic meter of the backfilling will happen. But in practically what has happened, it has come to 493. So this is a thumb rule. If somebody asks you, you can say 0.75 to 0.8. Okay. One more thing I want to add here. Say whatever backfilling we have done, no, this is not a compacted backfilling. You're getting my point. When you do the backfilling, you are going to compact, isn't it? You're not going to directly dump. So whatever volume I have got, no, this is actually the volume what I got when you do the dumping. But when you do the compaction, again, this quantity will increase. So remember one more thing I didn't explain in the previous lecture. So whatever backfilling you are getting, no, backfilling quantity, whatever you are getting, you add another 35% extra to that. 35% extra. So this is after the compaction. After the compaction. So if you're not able to understand, let me explain you this. Yeah. So whatever backfilling, see, once you backfill the soil, it's not that directly you're going to dump the soil. So when you're dumping the soil, it will be something like this, isn't it? You'll dump the soil, you'll do the compaction. Then again, you'll dump the soil, you'll do the compaction, right? In layers, if you remember, in the layers, we are supposed to do the backfilling. So when you do the backfilling in the layers, every time you're doing a compaction, isn't it? So when you're doing a compaction, that means more amount of soil will go. You're getting my point? More amount of soil will go. But we took that, like according to a calculation, if I come here, according to calculation, it should be 493. But this is actually a loose soil. You haven't done the compaction. Okay. So when you do the compaction, you can assume a thumb rule which says that backfilling quantity will be whatever quantity you got. No, for this, again, you take 35% extra. So that will be your actual backfilling quantity. Okay. That means 493. If you whatever answer you have got, isn't it? I'll write here. I'll do it here. Okay. Total backfilling after compaction. Okay. After compaction, because more amount of soil will go. Once you do the compaction, more amount of soil it can take, isn't it? Compaction. Okay. So, so for this, I'll write here answer. So this will be, how can I do? Yeah, whatever answer I got, I'll multiply this by 35. No, so 1.35 I'll do. 35 means 1.35. So it will be actual backfilling will be 665 cubic meter of a soil will go as a backfilling. Okay, this is on the paper, but on the practically on the site, you'll require more soil for the backfilling once you do the compaction. So why I'm taking this 1.35? Because 35%. Now, from where did I get this 35? Again, this has been observed on the site for a very long period of time. So people have seen that roughly 35%. Now you may question, should I take always 35? No, you can take 30 also. It depends on the soil also, no? It's not maybe your let us say let us say if you're taking some muram soil or something else, there the compaction may happen enough. I mean, more compaction may happen. If you're taking some other soil, the compaction may be little less. So again, everything is a project specific. Since we are doing estimate, I require rough idea. So that is why I've taken 35%. You can take 30% also, it doesn't matter. Okay. So if you don't want to do the calculation in this way, you have another way. The another way is take the backfilling quantity plus you take 35. So 35 is 0.35. Okay, 0.35 into this answer. And then close the bracket. You'll get the same answer. Same answer we got. See, 665 and 665. So this is a normal method what we adopted in our school during our school days, right? So if I want to add 35% to this, I'll take this volume plus 35% of this. Instead of that, smart work is you just multiply this value by 1.35. You'll get 665. So this is a real quantity which will go in the backfilling on the site. This is on the paper. Okay, got it? Great. So in this way, I think we have completed this assignment project, and whatever answers I have shown, that is a final answer. Okay. After checking all the calculation, I have found that this is a final answer, and you also should get the same answer. If you're getting any answer like 7 instead of 7.725, if you're getting like 7.715, that is fine. That happens due to the decimal digits that you're going to take, but you should get the same answer. Okay, great. So I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you.
Hello, civil engineers. Welcome back to the lecture. So in this project or in this assignment, this is a school building. Okay. And I'll give you this. You have to do the assignment. So here again, the same thing. Okay. Everywhere the footing is given, like this is F1 footing over that C2 column, F1 footing C2 column. Then again you have F2 footing C3 column. In this way, all the footings has been given. Try to note down, and for that particular footing, everything is mentioned in the schedule: F1, F2, F3, CF1, CF2, CF3, and so on. Okay, for combined footing CF1, CF2, the size is not mentioned here. For that you have to come here and see this is CF1, or let us say this is CF2. The size is given here in the AutoCAD. The breadth is 3250 and the this length is 6825. So based on that, try to make a note out of it and try to fill in your Excel sheet, and also if you want, you can write it down. Okay, now the main problem is with this kind of footing. You see this footing, so this is a irregular shape footing. Okay, this is neither rectangular nor it is a square shape. Then how do you find the area of such footings? That I'll teach you here. Other than that, rest all things you have to do. And here the cross section is also given. In this you're supposed to find the excavation quantity, then you're supposed to find PCC, then footing shuttering, footing concreting, and the column concreting up to the neck column, and the shuttering quantity. Okay, and the backfilling quantity. Again, this is your natural ground level. From here you are supposed to do 1.5 meter of the excavation, and one thing is that this excavation is still the PCC bottom is given, so directly you can take 1.5. Okay, and now when you try to find this neck column height, that is from here, this is your neck column height from here to here. So how we are supposed to do that? Again, we have understood that this 1.5 meter minus, this time you have to add the PCC depth also, because in the previous problems and all, what used to happen? We used to take the height from natural ground level to the top of the PCC, right? So directly this height minus the depth we were doing. But here, this 1.5 meter is shown till the bottom of the PCC. Okay, so that is why 1.5 minus 1.5 meter, yeah, 1.5 meter minus 100 minus the depth of the foundation. If you do, you will get this particular height. That is from this particular height you are going to get. Now this particular height is the depth of your plinth beam. It is already mentioned the depth of your plinth beam is 600 mm in all the cases. So directly take 600 mm from here. You're getting my point? So try to do this calculation. You're going to get. So I can explain you for one footing. Let us say this is one footing whose depth is 300 mm. Okay. Now you tell me what will be the height of your column. First, what you're supposed to do, 1500 minus the PCC thickness. The PCC thickness is 100 mm minus the depth of the foundation. Let us say for F1 it is 300 mm. Okay, so now if I get the answer, I'll reach to this level, plus I need to go till the plinth beam top. This is plinth beam top plus 600 plus 600. So if you do this, 1500 minus 300 minus 100 plus 600, I'll get 1.7 meter or 1700 mm. So this is your height of your neck column. For one I done, you do it for all other things. Okay, so you'll get hands-on practice on this. Similarly, this is a cross section for the combined footing. Nothing changes, everything remains the same. Try to do the same thing, no problem. Okay, yeah. Now after that, now again, rest things you have to note down. And on F1 footing, how many columns are coming? Like this is F1 footing, C1 column is here. F1 footing, C1 column. Again, you see for F1 footing, how many? Yeah, here you see on F1 footing, C2 column is there. F1 footing, C2. F1 footing, C2. Again, F1 footing, C1 means you'll write C1 column on F1 footing. How many numbers are there? Again, again you'll write C2 column on F1 footing. Okay, so try to do this so that you get an idea. Now I'll explain you how this particular footing area has to be taken care of. Okay, this particular footing, it's a irregular. Now for the same thing, I've kept the footing here. So this is that footing. So one best thing what you can do in AutoCAD is you have to just select this footing, and there's a command called list. I'll do that. I'll write it here first. The command is list. Okay, so what you'll do, you'll select this and write list and hit the enter button. So the moment you do that, you will get the area of that particular footing. The area is 45.882 and the perimeter is 35.694. So directly you'll get the answer. But I'll teach you how it has to be done manually also. We'll match the value. Okay. If you're using AutoCAD, directly you'll get the area. You don't have to do calculation. But I'll teach you how it has to be done. Now, this is irregular shape. I'll try to convert this shape into either a square or a rectangular part. So what I'll do, I'll take a line command from here. Let me try to make this as one part. Okay, so this part and this part. So now this got converted into square and square. Then again, here you have small portion, this portion. This portion I'll convert again from here to here. This is another portion. Okay, converted. So this is also rectangle portion, square portion. This is a kind of a trapezoid. So you can directly keep a trapezoid and apply the trapezoidal formula. That also can be done. Else I'll convert this into a this part. That is a rectangle part. This I'll convert into a rectangle. Sorry, not a rectangle. I'll convert this into triangle. Wait. Yeah. So this is done. And similarly, this also I'll convert. Done. Got it? So in this way, I have done everything. Now what I'm supposed to do? I'm supposed to find the length of all these things. Already we have done that. So you see, everywhere I have done the length, but again, I'll do it. So I'll go here. I'll take this length command. You can see this dimension option. Click on the dimension and now select it. Dimension. And from here to here, check the dimension 3275. Then again check from there here to here. So it is 3250. Then again, I want dimension from here 3250. This dimension already I know. I want this particular dimension 525. Okay. Then again, I want this particular dimension from here to here. You can take complete also, but if I get this also, it's okay. I can add and I can get it. Then I require this dimension from here to here. I think, yeah, small mistake I've done. See, this should be joined here. Okay. This should be joined from here. Yeah, now it's okay. And same thing here also. Here it is joined correctly. So this dimension and from there to here. Yeah, fine. Okay. So all dimensions I got. Now I want to find this dimension, no? This slant portion I want. So for that, again, I'll try to take this dimension from here to here, 1575, and this dimension I'll take. Yeah, it is 2475. Okay, fine. So next, what we're supposed to do? Now I want this dimension from here to here. This dimension I'll bring. I'll select here. Then I'll click on this so that I can go angle. So it is 2394, 2934, 2934. So I think this dimension, yeah, fine. So let me verify this. How will you verify this? It's a simple thing. If I want to find this particular length, I need to apply the Pythagoras theorem where this square 1575 square plus 2475 square under root if I do, I'll get this answer. Quickly I'll do that. I'll give a name to that. Say let us say this is A, this is B, and this is C. Okay. So we'll write. I want AC. AC will be square root of AB square, AB square, AB square. I'll write in this way. Okay. AB square plus BC square. BC square. Okay. BC square. Done. So now come under root, that is square root. What is your AB? AB is 1575, 1.575, 575 whole square I need to do. I'll write this thing. Square I'll write in this way. Okay. Plus again 2.475 whole square. Okay. So try to do it manually and let me know how much answer you're getting. So under root of 1.575 whole square plus 2.475 whole square. So I'm getting 2.933. Yeah. So I'm getting this answer I'm getting 2.9336 I'm getting, which can be written as how much? Which can be written as 2.934. And you can see the AutoCAD has given the same answer. That is 2934 in mm, 2.934 is in meter. Okay. You can make use of this AutoCAD and directly get it. If you don't have AutoCAD, try to do the manual calculation, apply the Pythagoras theorem, you'll get the answer. Right? Done. So once we get this, I'll delete it. Now directly, let me find the area of this. How you'll find the area? See, this is a rectangular. I mean, this is square. I'll just have to take the length and breadth. This is also square. This length and breadth. Then this is your rectangle portion, the length and breadth. This is your rectangular portion, length and breadth. And this is your triangular portion, half into length into breadth. Again, this is also half into length into breadth. If you do that, you'll get the answer. Okay. So here, this length I haven't found. Let me find that length also. Okay. Yeah, 975 and 2475. This, yeah, 2660. So try to do this also, whether, and let me know whether you are getting 0.975 whole square plus 2.475 whole square. Yeah, 2.660 I'm getting, same thing I got. Okay, fine. Now quickly let me add all these values now. So this area you find, this area I want. So how will you find? Quickly try to write it. That is 3.25 multiplied by 3.275. This is the answer what I should get. 3.25 multiplied by 3.275. So it is 10.64. Okay, this area is 10.64. Okay, now we'll be making a mistake. Okay. Okay, this I'll write it here. Okay. Yeah, done. Next, we'll find this area now. So this area will be again 3275, and this is again 3. This is how much is this? Okay, I need to find the area. I hope you are able to understand. Okay, it's very simple, not an issue. Let me find this area again. No. Yeah, 3275 and 3250, same thing. So this I have to multiply by 2, because again 3250 into 3275, I'll get the same answer. So what I can do, I'll just multiply this, or I'll write this 10.64 again. 10.64. Okay, this part. Fine. Next, we have to find this area. I'll find this rectangle area. So rectangle area is very simple. You have 525 here. This is 525, and you multiply this by this length. So this length is 3250 plus 2750 plus 3250. If you don't want to do that, directly take the values. That is also okay. So directly, I'll keep it here, and from here, I will keep it here. Okay, this I'll keep it here. 9250. This length is 9250. So write it here, 9.25 into 0.525. So how much you're getting? 9.25 into 0.525. So it is 4.85. Okay, this area is also done. Now we'll find this particular area. That is this area, and this. So that is, this is 6,700 and this is 2,475. Try to do that. 6.7, multiply that by 2.475. Let me know the answer. So 6.7 into 2.475. It is 16.58. Okay, 16.58. What, everything is meter. Okay, yeah. Now this triangular portion is left out. So this triangular portion and this triangular portion. Since triangle area is half into length into breadth, so we'll apply that formula. First, I'll do for this particular triangle. Okay, so half is 0.5. Half is 0.5. Half into length. So length you can take 2.475. 2.475 into breadth. Breadth is 0.975. Okay, this is 0.975. So tell me the answer. 0.5 into 2.475 into 0.975. So you'll get 1.20 meter. Okay, this triangle is done. Next, I'll go with this particular triangle. So in this triangle, again, this is 1.575. This is 2.475. So just try to do that. Again, half into zero point 0.5, half into length 1.575 into 2.475. So 0.5 into 2.475 into 1.575. So it is 1.94. 1.94 meter. Done. Now you add all the area. You should get that AutoCAD value what we have got. Okay. Now I'll add everything. So let me add everything. First I got 10.64. After that also I got 10.64. Okay. Then I got 4.85 plus 16.58 plus 1.20 plus 1.94. So try to do it and let me know how much answer you're getting. So it is 10.64 plus 10.64 plus 4.85 plus 16.58 plus 1.20 plus 1.94. So I'm getting 45.85. This is my area. Okay. And let me check what answer I'm getting in the AutoCAD. So what I'll do again, I'll click on this shape. First I need to select LIST. I need to write LIST. LIST. And you see how much I got? 45.882. I'm getting 45.85. Almost same. No problem. Okay. Now come to the perimeter. So what is this perimeter? Perimeter in the sense you have to add all the sides now. Okay. That is 3 to now all the sides in the sense, see, all the outer side you're supposed to add. Okay. This all the sides I'm supposed to add. So quickly let me do that. So I'll do that. How shall I do that? Very simple. I'll do it in my calculator. I won't write. So this is 3275. 3.275 plus this is 3275. No, this outer. Next, this is 525. 0.52. You have to just calculate the perimeter. Okay. Plus this is how much? 2.934. 2.934. 2.934 plus how much is this? This is 6.7. 6.7 plus how much is this? This was only outer part. Okay. 2.660. 2.660. Then again outer one. This part I want. This part is 3275. This is 3275. Okay. 3275 plus this is 3250. This is 3250. 3.250 plus this is 3275 plus this is 2750. Okay. Plus this portion. Finally we have reached now. Okay. This portion. How much it is? 3275. And finally the last one, because this we started from here. No, I reached now, and this one I need to add now. How much it is? 3250. 3250. So I'm getting 35.169 in my calculator. I'll write it here. I'm getting 35.169 meter. And let me check how much I should get. I mean, how much I got in my AutoCAD. LI, enter. 35.694. I got 169. Here I'm getting 35.694. So I think somewhere we have done a mistake. Somewhere there is a mistake. So I think we need to rectify that now. Yeah. That the mistake is I got it. See, the mistake was 2660. After that, directly I took 3275, isn't it? Directly I took 3275. But this portion I haven't added. That was some 975, I guess. Let me check. Yeah, 525. This portion I didn't add, 525. Now it will be correct. So I'll add it to this portion only. No problem. Uh, yeah, plus plus 0.525. Now I should get the right answer. 35.169 plus 0.525. Yeah, I'm getting 35.694. Now I'm getting 35.694. Let me verify the answer again. LI, enter. Yeah, you can see now. See, I got 35.694. Even in the AutoCAD, I'm getting 35.694. Done. So now you got the perimeter. Now with this perimeter, you'll find the shuttering quantity for this. How you'll find? You got the perimeter, multiply this by the depth of it. That is 35.694. Let us say this particular footing, it is CF1. Okay. And for CF1, what is the depth? It is mentioned in the table. For CF1, combined footing 1. Yeah, this is your CF1. See, this is CF1. Perimeter I got. The depth is 700. What you're supposed to do? Very simple. CF1 700. So I'll do that here. 35.694. You multiply this by the depth. Depth is 0.7. So if I do that, 24.98 square meter. So this much is my shuttering area. Okay. You're getting my point? This is my shuttering area for this particular footing. If you want to find the concrete quantity, how you will find the concrete quantity? Concrete quantity will be area. Okay. Concrete quantity, that is volume. Volume of concrete for CF1 I'll write. CF1. Okay. Combined footing 1 will be how much area we had got initially? 45.85. 45.85 multiply by the depth of it. Depth how much we got now? Footing depth was 0.7. That's it. You'll get the what you're going to get. You're going to get the 45.85 into 0.7. 32.09 cubic meter. Okay. Yeah, cubic meter or meter cube or cubic meter. This is the volume of concrete that will go into this particular footing. Okay. So that much big is this particular footing. Yeah, because it's quite big only. Yeah, I'll clear everything. So because let me check the footing. Yeah, it's quite big only because 3.8 meter, then this meter. No, area is quite big. So area multiply by depth I've done. I got the concrete quantity for CF1. In the same way, you have to do it for this footing also. This footing you try it on your own. Okay. And rest all things I've told you how it has to be done. So try to finish this assignment so that we'll have a good confidence in these subjects so that when you work anyway, you'll not face any problem after this. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So here I'll give you one more assignment. This is one of a industrial building. Okay. For this particular industrial building, they have given this foundation details. Again, if you are interested, if you want to learn, you can try to work on this also. Again, see, everywhere the footing is given F3 on that C2 column, F3, C8 column, and so on. Again, footing schedule is given here, F1, F2, F3, and so on. And now the cross section is also given. See, from the natural ground level to the depth of your this thing, bottom of your PCC, it is 1.5 meter. And to the top of the plinth beam, they are directly given. You have to take 975 mm. So when you find the height of this column from here, okay, this height, whenever you find, what you're supposed to do, 975, okay, plus 1500 minus the PCC thickness minus the depth of the foundation. If you do, you're going to get this particular height, okay, that you need to follow. Rest all things are very simple. Go through that. And only the problem is, not the problem, only the catch is, here there is one footing which is something like this. See, this is that footing, okay. So this is how that footing looks. Now, how we are going to find the area of this? Again, with the same method like I explained, you can select this and write Li and hit the enter button. You'll get everything here. The area, it is in mm. You divide this by 1000. This is your perimeter. You divide this by 1000. You get this in meter. Okay. This, you can directly take the value from here. Else, like I mentioned, you have to find the perimeter, like 3400 plus 2970 plus 2190, 3400 plus 3400 plus 2970 plus 2190 plus 3400. You do, you get a perimeter. Area, how you are supposed to find? For the area, you can break this now. So I'll select this part, Control C, and I'll say Control V. Okay, I'll paste it here. How you are going to find the area of this? Try to break it now. So how you will break it? One option is you can do in this way. Okay, this is done, and then again from here you break it in this way. Okay, so now you can find the concrete quantity. Very simple. This is one rectangle, another rectangle, and another rectangle. Try to add all the three rectangles, you'll get the area of this. Anyhow, I'll try to quickly do that and we'll verify our answers. Okay, quickly let me find the dimensions of this. 2190. Yeah, this is done. So most of the footings, wherever you are finding difficulties, I've taken all the irregular footings. Okay, after this, in your projects, if you get any irregular footings, you don't have to worry. Simply select that footing and click the list button. Okay, list. You'll get the area of that, and through that you can do it. If you're working on the site, then you don't get the AutoCAD drawing. You get the drawings in the PDF. In that case, you'll not have that liberty of finding the area. Then you go to the office, ask the quantity surveyor guy to give the drawing, or ask him to tell the area of this. And based on that, you can find the area on the site. Okay. You have got both the option. If you have AutoCAD drawing, do it in this way. If not an issue. Let me quickly find the area of this. I'll do it manually. Okay. So I'll find this area first. 2.19 into this area. Okay, 2.19 into 3.4. Okay, fine. Plus, I'll find this area 1210, 1.210 into this length. This length I written it here, 6350. Sorry, 6.370. Okay, plus this area, that is 2190, 2.190 into this one. Okay, this is 3400, 3.4 meter. So I'm getting 22.59, that is 22.60. Let me write, I'm getting 22.60 square meter or meter square. Let me check in AutoCAD how much I'm getting. Okay, Li, enter. Yeah, same thing. See, area is written here 22,599. If you want, you can note it down and divide this value by 1000. I'll do that. What is given? 22, 5, 700. I'll divide it by 1000 because it is in mm. So 22,599,700 divided by 1000. Okay, I think then this is in mm. I think you have to divide it by 10,000 then. Yeah, no problem. I'm getting the answer, but this is in I don't know what is the in which. Let me check it once again. Okay, no problem. Anyhow, see, you divide it by this thing. I'm getting 2259. Okay, I'm getting answer here as 22.60 square meter. Okay. Okay, this is in this area is in square meter, no? Then I think 1000 into 1000. Yeah, you should divide it. Let me do that once again. That is 22599, 22599 and 700 divided by this. Yeah, I'm getting. See, I'll tell you what we should do. This is area, okay? This is area. This is square. This is in square. So if I want to convert from to meter, I mean, yeah, I need to divide it by 1000. Okay. So here it is square. So I need to multiply like 1000 into 1000. So it will be how much? How many zeros will come? 6 zeros. Yeah, 1, 2, 3. Now you divide this. This value you have to divide now. This value you have to divide it by 3 and another 3. 3 plus 3. Total 6 zeros. 1, 2, 3, 4, 5, 6. Yeah, now you get the answer. Now you do it manually, you'll get the same answer. 22599 700 700 divided by, yeah. How much you're getting? Exactly 22.59, or let us say 22 points. I'm getting 22.5997, which you can consider it to be 22.60 square meter. And manual also we got the same thing, right? 20. That is how you are supposed to do it. Okay, got it. Perimeter, anyhow you calculate all the area, this outer 2190 then this part you will get the perimeter. Got it? Yeah, rest things you try to do on your own, so that there is no doubt left in this particular project. Okay, uh that's how it is. So another thing, see, in few of the projects, yeah, good, in few of the projects, no, this PCC offset won't be given. This PCC offset won't be given. Then what you do, you can usually assume, or you can ask your people, I mean the person who has given you the BOQ, or your site manager or someone, that what should be taken. But usually what we do is 50 to 100 mm. 50 to 100 mm is offset what we take. You can take 75 mm also, but 100 is a good thing what you can do. So this offset I'm speaking of. Okay, in few drawing it is not given, no problem. This you take 100, and from here also you have to take it 100 mm. Okay, yeah, this is the only catch what you have. That is what you are supposed to follow. Great. Other than that, most of things I've explained. And other drawings also which I had taught you, there also that PCC offset wasn't given. Then you have to assume all those things. Okay, fine. Assume in the sense you have to ask, and same thing you have to follow, and that is how you're supposed to do the calculation. Yeah. So I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So here, I'll give you one more assignment. If you're interested, you can do that. But my only intention is to make you get exposed to different kind of projects. Okay. So this is another G+5 building what they have put up. I have a drawing for that. See, everything is given. Okay. Footing number is given. You have 3 combined footing here. Okay. And then F1, F2, F3 different footings are given. Okay. Then column layout is also given, like C1, C2, C1, C3 and all. Okay, this much is understood. Now coming to the cross section part, you see here for the cross section they have mentioned everything. Like this is your RL level. Okay, from here you're supposed to do an excavation of 2 meter, that is up to the top of the uh, stone soling, and from there you have another 200 stone soling. So when you take the depth of your excavation, you have to take till this bottom. Okay, and then other than that, rest things you know. Okay, and yeah, then this is 75 50. Yeah, you see here the PCC thickness they have mentioned here. You can see 50 minimum, this 50 and this is also 50 minimum. PCC offset is mentioned. Then the thickness of your plain cement concrete, thickness of your is 100 concrete. Okay, where it is mentioned. So wait, let me see. Yeah, so here it's mentioned, this is mentioned here, 100 concrete you're supposed to put, that is a PCC. Okay, but they've used 1:2:4 ratio. It's okay, M15 they are using. And then this stone soling is 200 stone soling you're supposed to do. Okay, but here one mistake is that, see, here 75 projection is given. Okay, here they have given 75, and here he's mentioning 50. So see, no problem, you take 75 or 50, doesn't matter. Okay, they should make it clear. See, sometimes in drawing also there will be a mistake. Don't expect that all the drawings will be according to your need. Sometimes the draftsman may make a mistake and all. If someone who's new to this field, he may make a mistake, but it's okay. We understand all those things. Here he is mentioning that this has to be 75 mm projection, and here he is showing 50 mm minimum. Okay. So what you do, you can consider 75 mm on both the sides. This is also 75. This is also 75. Okay. This much is understood. Then your footing schedule is given. See, F1, F2, F3, F4, F5, and CFN combined footing one schedule is given. Length is known, breadth is known, depth is also known. Reinforcement don't it's not required now, unless we are touching the BBS right now. Unless, I mean, we are not touching the BBS now. And then CF1, CF2, the combined footing schedule is also given here. This much is enough. With this, you can do the estimation. You can find the excavation quantity, PCC, stone soling, and all those quantity. Okay. Yeah. So just I'm attaching this particular drawing. You go through this drawing, and you can take out the quantities of this so that you get a good exposure on this. Yeah. So most of them are isolated footings only. One is combined footing here. So this combined footing, you write it first. You do it for the isolated footing, then you take the combined footing part. Okay. Yeah. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So in this lecture, we'll see how to take out the concrete quantity and the shuttering quantity for the slope footing. So far, whatever we saw was for the combined footing, which was rectangular in shape, and the isolated footing, which was either rectangular or square in shape, which was very simple. But how do you find the concrete quantity and the shuttering quantity for such type of footing, which is called as slope footing? Okay. So we'll try to understand. For that, I'll take you to the Excel sheet, what I created already. See, this is a typical section what you have. Okay. So this is a plan of your footing where the length of your footing is 3.8 meter and the breadth of your footing. Okay. This should have been this side. It's okay. Not an issue because this should have been the length and this should have been the breadth. Okay. Now I'll do it so that there is no confusion. Yeah. So I'll make this as 2.6 and I'll make this as 3.8. Okay. So this is 3.8. This is the length side and this is 2.6, the breadth side. Okay. And yeah, give me a minute. Yeah, done. Yeah, now it is clear. Yeah. So this is my breadth, which is 2.6, and this is my depth, or let's say the length of the footing, which is 3.8 meter. Okay, fine. Now since it's a slope footing, you can see this is a kind of a slope what has been created. Okay, this is a kind of a slope. In the cross section, you can see this particular slope. You can see this particular slope. This is a slope. Okay, and then after that we have a column in the middle. So this column you can see here. So this is a column which is in the middle here. But from here, this slide from the column outer face to the this outer face, this small gap, no, this gap and this gap. This is that gap. Okay, this gap and this gap. This much you are clear. So to put it in a better way, quickly try to understand here. See, this is a slope, this is a slope, and this is that offset portion, this portion and this portion. Your column will come here, but there's small offset here. Similarly, you can see the column is only this much part. The column part is only this much. Okay, this much is your column part. Okay, but whereas this portion you can see small from here to here, this is that extra portion, this is that extra portion. So in the plan it looks like this. Okay, in the cross section it looks like this. In the plan it looks like this much is clear. So first, what quantity I'm supposed to find? First, let me find the PCC quantity for this. So PCC quantity is very simple. I've written it here. Length is 3.8 meter. I'll teach you how to prepare this Excel sheet. Okay, first you understand the concept. The breadth is 2.6 meter, it's written here, and this is overall depth, that is capital D. This is the overall depth of your footing. Okay, this is the overall depth of your footing, which is capital D, which is written 0.6, and this is small d, this much portion, the rectangular portion, whatever you have, no, this is your small d. I've written it as 0.35. Now I want this height. Okay, this particular height I want. Okay, so how do you find this height? Very simple. This overall depth 0.6 minus 0.35 will give me this height. Okay, and this is actually h. Instead of this, I'll write h here. Now h, I'll tell you what exact. So this is called as h. Okay, if you want, you can write h here. So this portion is called as small h. Okay, this portion is called as small h. This much is understood. Fine. So once you understood this much part, next we'll try to find the PCC quantity. How we are going to find the PCC quantity? Very simple. The footing length is given, that is 3.8 meter. I'll take 75 offset on the left side, 75 on the right side. Very simple. Okay. So again, same thing. I've written it here. See, PCC I've written here. Okay. I'll do it here. Hmm. Equal to sign. What is this thing length? Length is 3.8 plus on the left side. I'll take a PCC offset of 75 So I written it here 0.075 plus again 0.075. Okay, plus again 0.075. You can do it manually. You will get 3.95 PCC length one side. Breadth again it is 2.6. Again 0.075 on the right side, 0.075 on the left side. So again you see here that is 2.6 plus 0.075 plus 0.075 you do. You'll get 2.75. Now total PCC quantity will be how much? The length multiplied by the breadth, that is 2.75, into the thickness of the PCC. So this thickness of the PCC I'm considering 100 I've taken 100 here. Okay. If you want, I'll do it for you. Because PCC quantity is same thing. Okay. There's no change whether it is isolated, combined footing or whatever it may be. It's 1.09 cubic meter. That doesn't matter. Now the important portion is about the concrete quantity for this particular footing. Now this particular footing what I have, I'll break it into two pieces. That means I'll break this into one. This portion is my rectangular portion. This is my rectangular portion. Okay, and then after that whatever is remaining, no, this portion whatever is remaining, that is my trapezoidal portion. Okay, first I'll find the concrete quantity for the rectangular portion, and then I'll try to find that concrete quantity for the trapezoidal portion. Is it clear? Okay, chalo, we'll start with this now. Okay, so first, how do you find the concrete quantity for a rectangular portion? Very simple. Whatever is my length of my footing, I'll multiply that by the breadth of the footing, and that I'll multiply by the depth of this particular thing. Okay, so you can see a rectangular portion RCC, I've written it here, which is equal to, I'll make it here also, equal to, what is the length of your footing? 3.8. What is the breadth of your footing? 2.6. And what is the depth? Depth is, it's not the overall depth. You have to take only the rectangular portion depth. How much it is? 0.35. So 0.35 is here. I'll click on this. So I'm getting 3.45 cubic meter. Okay. If I detect this, 3.46 cubic meter. This is only the rectangular portion. Again, the trapezoidal portion is left out. Now for the trapezoidal portion, you have to use this formula. So note down this formula. The formula is h by 3 multiply by, see how I'll do. Yeah, how I'm going to do this? So h by 3, what is h? This is h. Okay, h already I got 0.6 minus 0.35. I'll get this h. So this h I got. Okay, multiply this by AB. AB in the sense bottom area. What is my bottom area? This is my bottom area, isn't it? This is my breadth side area, bottom area. Okay, this is my bottom area. Okay, this is my bottom area. And plus A at T, that is top area. This is my top area. I'll show you here. See, this is my bottom area, this much part, bottom area. Okay, and this is my top area. Understood? Okay, so I written AB is bottom area. Okay, A is area, BA, that is bottom area, plus top area, plus square root of or under root of AB. AB means again bottom area. This AB is bottom area, and you plus top area. It is top area. Okay, this much is understood. Now first we'll try to find the bottom area. Bottom area is very simple, because this length already I know. What is this length? This length is actually the footing length. Very simple. This length is footing length. So AB is equal to bottom area. How I'm going to find? 3.8. So this is 3.8 on this side. Multiply this by 2.6 on the other side also. See, if you're getting confusion, what I'll do is I'll take one image from here. Control C. I'll bring this image here. Okay. Now all your confusion will be gone. Yeah, and I'll keep it here. First I'm finding the bottom area. Okay. So this bottom area, AB, yeah. So it is 3.8 into 2.6. That means this is 3.8 and this is 2.6. If I multiply this, I'll get the bottom area. So AB is your bottom area. Got it? So multiply this 3.8 into 2.6 will give me 9.88. 9.88. Okay. Next is I told top area. What is the top area? This is my top area. Okay. This is my top area. That means I want to find this area now. This area we can see, this area I want. Okay, so to find that top area, I want T. The formula is top length into top bottom. That means top length, top along the length side, and top along the breadth side. That means I require this one. See here, this is that portion, this length, and this portion I require. I'll do it here. I want this length, I want this portion, okay, and I want this portion length. Okay, if I multiply this both, I'll get my top area. Okay, how we are going to do that? That is small trick in that. So right now, this particular portion is your column. Okay, and what is the dimension of the column? It is given. This is 0.5, that is 500 mm, this one, and this is your 400 mm. Okay, that is a column dimension. But I want this entire thing, no? So that is why this offset is given. This is your column. Okay, so from here, from your column outer to this part, it is 75 mm, that is 0.075, and from here to here it is 0.075. Okay, so if I add 0.5, if I add this, that is 0.075 plus 0.5 plus 0.075, am I not going to get this entire length here? Or length part I'm going to get the same thing. I've done it here. That is top length is 0.075, this one, plus 0.5. From where I got this 0.5? This one, this portion. Okay, I'm doing this side now, that is column this side. So 0.5 plus 0.075. So add everything, you'll get 0.65. So one side I did. Now this length side I did. This side also I have, no? This side also I am supposed to do. Again, I'll follow the same thing. This side also I'll do the same thing. That is top breadth side. TB means top breadth side, and TL means top length side. Okay, so again this portion is 0.075. From here to here it is 0.075. And what is the column dimension? 400 mm, 0.4. And from here to here again it is 75 mm. See, this is a cross section. In this you are going to get only one side, not both the side. Okay, so even if you want to get it more clear, it will be here. See, right now whatever I had done, no, I did only for one side. I did this one. This was my 75. Yeah, this was 75. Okay, after that I had this column dimension of 500. Okay, and then I had this 75. This much is understood. Length side I did. In the same way, breadth side also I want to do. Again here this will be 75. Breadth side, your column dimension was 400 mm. This will be my 400 mm, and then again 75. You're getting my point. And now if I multiply this portion into this portion, am I not going to get the complete area of the top side? Obviously I'm going to get. The same thing I'm trying to do it here. Okay, see now, 0.075 plus 0.4 plus 0.075, you'll get 0.55. That's it. So once you get this, your task is done. Now you just have to input this in the formula. Now the formula says h by 3. What is h? H is this distance. This is your h distance. How much it was? H was here, 0.25. That is 0.6 minus 0.35. You put this formula. Already I've done that, but still I'll do it again. So the formula you have to follow this. Okay, this particular open bracket, close bracket you have to follow. Only then you'll get the answer. Equal to sign. I'll open the bracket. Okay, h I'll take from here 0.25. I'll divide it by 3. H by 3. Okay, and then close the bracket, and then use this multiplication symbol star, and then again 2 times open the bracket. So this is called AB. AB is the area, right? So AB is your area. So what is the area you got in the bottom? 9.88. I'll select this 9.88 plus top area. 80 is top area. Top area, how much you got? So top area, yeah, top area, how much I got? I should add this, no? For top area, that is 0.66 into 0.55. It will be 0.36. You add this. Okay, you multiply 0.65 into 0.55, because for top area I want to multiply the top length, that is top length into top breadth, that is 0.65, and 0.55 you multiply, you'll get 0.66. You'll get 0.36. I'll take this 0.36. Okay, now again I'll close the bracket, plus now square root you should write in your keyboard SQRT, right? The square root will pop up. Okay, so once you write the square root, then again open the bracket. Again AB, that is a bottom area. Okay, it is 9.88. Close the bracket, plus open the bracket. Again top area is 0.36. Okay, then again close the bracket, and 2 times you close the bracket and hit the enter button. So I'm getting 1 point. Okay, this time I'm getting 1.14. No, I should get 1.01. Okay, not 1.14. If I do it manual also, I'm getting 1.01. So maybe somewhere we have done a mistake. We'll rectify that, no problem. I'll do it manually once. Let me check it out. Okay, h by 3. So h is 0.25 divided by 3. Then I'll multiply this by 9.88 into 0.36. I'll close the bracket plus under root of plus square root of, I'll open the bracket AB, that is a top area 9.88 plus, sorry, bottom area plus top area. Top area is 0.36. Close the bracket. Let me check it once again, because 1 point, see here I've done it correctly. See F6. Okay, so let me check both the formula, what is wrong. So one open bracket, here also it is open bracket, divide by 3, divide by 3 I've done, close bracket, close bracket, multiplication, multiplication, open bracket, double open bracket, C20, C20 plus D23 plus D23 plus square root plus square root. Okay, here we have done this mistake. C20. Okay, now it should come. See, C20 into D23. C20 C20. Let me check the formula. Just give me a minute, okay? Because in Excel sheet, yeah, this formula I written, this should be multiplication. Sorry for that. This is multiplication. I checked it now. Okay. Yeah, this is multiplication. Okay. So now you do it proper. This should have been multiplication and not the addition. Multiplication. Yeah, now it's coming correct. See, 320, 320, and this bracket is not required. Bracket you close. Yeah, and then uh, two open bracket. So here also you require two open bracket. Yeah, yeah, 1.0. This if I try to minimize, no, exactly. You're getting, see, trapezoidal portion I got 1.01 cubic meter of a concrete. So total concrete will be how much? The total concrete will be my rectangular portion plus my trapezoidal portion. So that is rectangular portion, how much I got? Rectangular portion concrete was 3.46. So 3.46 plus 1.01 will give you 4.47 cubic meter of a concrete. Very simple. Now coming to the shuttering quantity. Shuttering is very simple, because if I show you the image again, see, shuttering where you do, wherever shuttering you don't do on the top, like you did it normal, this length, the perimeter you multiply, this entire perimeter, and then you multiply this by the depth of the shuttering or the depth of the footing, you'll get the shuttering quantity. That means you can directly take like equal to sign. What is my this thing? I'll do it here only. Okay, it's easy for me. Shuttering, I'll do it here. Okay, equal to sign. My length is 3.8 plus 2.6 plus 3.8 plus 2.6. Okay, so you multiply this by, I'll close this. This I'll open. Yeah, this I'll multiply by the depth. So depth is how much? Footing depth. Footing depth will be how much? 0.35. Why not 0.6? Because shuttering will do only up to rectangular portion. So you have to take 0.35 and enter. 3.78. Wait. Into the depth. Yeah, this answer into E6.
So I should get 4.48. Why I'm getting 3.78 here? So length is 3.8, breadth is 2.6. So B6, B6 plus C6. Yeah, we should get the answer. Why it's not happening? Let me recheck it. Okay, no problem. See, don't get worried. When you encounter such problems, only you'll learn all these things. See, what I'm trying to tell is perimeter will be 3.8 plus 2.6 plus 2.6 plus 3.8 perimeter. We'll multiply this by the depth. So depth is 0.35, right? We'll do that. I'll do manually. We'll see what will happen. 3.8 plus 3.8 plus 2.6 plus 2.6. Let me know how much answer we are getting for this. So 3.8 plus 3.8 plus 2.6 plus 2.6. So I'm getting 12.8. Okay, 12.8 is perimeter. I'll multiply this by depth. Depth is 0.35. Multiply this by 0.35. 4.48. Exactly. I should get 4.48 square meter. And why is that I'm getting 3.78 in this case? Let me recheck this. Maybe because of the BODMAS formula, it will take that, B6 plus C6, B6. Okay, 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 fine. See, one mistake we have done. Why? B6, this is correct. Okay, see, this B6 indicates this B column and 6 row. Okay, B6. Then again, C6, 2.6. Then again, I took B6. But next, I took D6. I took 0.6 here. So that is why that error was coming. So I should take 2.6. Now the answer should come. Not the problem with the board mass. You can close the bracket. You'll definitely get the answer. Exactly. See, 4.48, 4.48. Got it? So this is how you're supposed to do the shuttering quantity, concrete quantity for the trapezoidal footing. Okay. I hope you have enjoyed this lecture. You got an idea how it has to be done. So what I'm going to do is, in the next lecture, I'll teach you how to prepare the Excel sheet for the trapezoidal footing so that you can use it in your projects. If you prepare one Excel sheet and keep it for any of the footing I give you, you can directly get your answer within seconds. So in the next lecture, I'll teach you how to prepare a beautiful Excel sheet for this so that we can use it anytime. Okay. We'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So we'll try to do a Excel sheet where we can, get the quantities for the slope footing. Okay. So what I'll do, always it's better you mention all these things here, that you will write the length here. Okay. The breadth part here, footing breadth, and then you can even tell length is over, breadth is over. This is overall depth. Then you require a small depth, isn't it? That then you mention this as small d, and this will be a h. So once this is done, you bring it at the center. Okay. And then you can you can give the color to that, and let me increase the size to that. Okay, fine. So once this is done, make it in this way so that looks good. Now if you want, you put the border there, go here and say all borders. One thing is done. Okay, fine. So first PCC, anyhow it's very simple. If you want, I can even do for the PCC also. We'll do that, not an issue. Here what we do, no, you write here PCC offset, PCC offset, so that everything we can bring in a single line. PCC offset. No, we'll not do the PCC and all, not required. We'll do the other things. Okay, because we want column dimensions also, no. So what I'll do is bring one column here. I want column dimension. I'll write here breadth of the column, uh the depth of the column. Okay, breadth is done, depth is done, and then I require that offset. I require the offset of the column, right? What offset is that? This one, 0.0.07. I'll write here column offset. Okay, for our understanding, so that you just have to input everything later. Column offset done. This much is understood. Okay, this much is enough for us. Rest things we can manage. Okay, yeah. So PCC quantity I'll not do. It's very simple. You just have to take the length, breadth, and depth, length, breadth, and thickness of PCC, and then you can do it
See, because PCC, the stone soiling quantity, sand filling quantity has nothing to do with the slope footing. The method is same. Even you do for the rough footing, even you do for the isolated footing. So not an issue. Only the problem is with the concrete quantity. We'll do that. Now, what is the footing length? So I'll take it as 3.8. Breadth, I'll take 2.6. Overall depth was 0.6. And this small depth was 0.35. And this you should not write here, okay? This h you should not write. You have to say equal to sign overall depth minus 0.35. So automatically it will take the value. Now if I take instead of 0.7, if I take 0.8, automatically it will get updated. So this is how you have to prepare the Excel sheet. So this B is a column breadth, okay? I'll take 0.4 and column depth, okay, 0.5, and that offset I'm taking 0.075, okay? This is 0.075. This much is clear? Yeah. So once these things are done, so we'll start with the concrete quantity. I'll write here. I'll write footing concrete. Okay. Footing concrete. This is rectangular portion. Rectangular. Okay. Okay. We have to. I'll do it in this way. So if this goes outside, just select that and say merge at center. And now wrap text. Okay. It will look good. If you want, you can bring at the center. Concrete rectangular portion. And this, if you want, you change it to some other color. Okay. Done. Fine. So how we are going to do this? Footing concrete quantity will be, I want the length. So concrete quantity, I'll bring it here only. I'll merge this part. Okay. Equal to sign, I'll take. I want the length. I'll multiply the length by the breadth. I'll multiply that by the, which one? Depth. Which depth is that concrete quantity? The small depth. Okay. That's it. Finish. 3.458. We got previously 3.46. Same thing I'm getting here. So I'll reduce this one and I'll bring it at the top. See, this is at the bottom, no? I want at the center. So select this, come here, this portion. You'll bring at the center. Now you increase the size. Yeah, 3.46. This is rectangular portion. Now similarly, I'll again select all the three here. I'll say merge at center. Now I'll write here footing trapezoidal portion. Trapezoidal portion. Okay, fine. And then you select here, go for the wrap text, make it bold, and this you can change. Okay, done. And then this also you merge in this way. Fine. Okay. Now how you will find the trapezoidal portion? This formula you need to put. So before applying the formula, we should know what is the bottom area, the top area and all. So directly I'll connect my formulas here. Okay. Just concentrate how it is to be done. I'll say equal to sign. First is your open bracket. What is H? H is here 0.25. You divide this by 3, write 3. Then you close the bracket. Okay. Then use this multiplication sign. Then open the bracket 2 times. Done. What is written here? Okay, I think this will wait. We'll do one thing because this will become more complicated now. So what I'll do now, I'll just make a separate this thing and we'll note down all these things. So I'll make one small thing here. Okay, I'll write here. I'll make this for bottom area and then for top area I'll make this. I'll write this as okay, 2 column is enough for me. I'll merge at center. I'll write here. This is bottom area. Okay, bottom area. Just increase the size and this you merge at center. What is this bottom area? Bottom area will be 3.8 into 2.6. Okay, bottom area I got. Now similarly, I'll take this. I'll merge it. Okay, I'll write top area. I'll write top area. Okay, so for top area, how you are supposed to do? We know that for top area, how you will do? That is this top area I'm speaking. Okay, one is towards the length side and towards the breadth side you're supposed to do. So what we can do directly here, you can do I'll open the bracket. Okay. So what is how do you find the area for that? First, you have to take this portion, that is column offset 0.075 plus, wait, why the 6 is coming? Okay. Okay. I hope you are able to understand. Okay. I'll write here. See, otherwise you can, instead of top area, you can even separate this and you can say uh, that is top length side and top breadth side. That also can be done. So I'll do that also for our easiness. Okay. You can do it the way you want. Okay. I'll make one more column here this way. I'll merge this and also I'll merge this part. Okay. I'll write this as top length side. Okay. And then this will be my top breadth side so that it is easy for you to understand. And this will merge, this will merge. Okay. So what is this top length side? Top length side will be, what is the offset? 0.075 plus, I'll consider the length side to be this one, 0.5, or even you can change it here. You can take anything, doesn't matter. Okay. I'll take 0.4 plus 0.075. Okay. So I'm getting 0.55. Same, we got it here. You remember 0.55. Next again, equal to top breadth side. Again, same thing, 0.075 plus this time 0.5 plus 0.075. Enter 0.65. You can see here we got 0.65 here. Okay, fine. Now top area will be how much? Top area will be top length side. You multiply this by top breadth side. Okay, so I'm getting 0.3575. I'll reduce this 0.36. You saw? Can you understand? See, 0.36 we had got. Now since we have made a very good table, no, that is why everything looks great now. So you can make it bold, increase the size of this. This you can, here also you can. Okay, this will merge. This also will merge. Yeah, this you can take at the center portion. Okay, and this you can give one. Okay, this portion merge at center, and then at the top, then you can give one column here, thick box girder. I mean, thick box you can give. This also you can give. Take it at the center, chain this part. Okay, so once you do this, no, everything is done. Now this no problem. Now putting trapezoidal portion, quickly we can get the answer. Okay, equal to sign h. First is open bracket. Remember the formula, open bracket. So h is 0.25. I'll divide it by 3. This is the formula. Close the bracket. Okay, then multiplication, 2 times open the bracket. So first you have to take the AB. AB is your bottom area. Okay, bottom area, and the top area you have to take, right? So what is your bottom area? So this is my bottom area. You bottom area plus top area, this one. Close the bracket. Okay, then plus square root, right? SQRT, square root, and then open bracket. Okay, it is written open bracket. So in open bracket, what you're supposed to do, you have to take again AB, that is the bottom area, 9.88. You multiply this by top area, 0.36. Close the bracket, 2 times, hit the enter button. You can see 1.009 has come. Finally, we got that answer. Exactly 1.01. So how much we had got previously? 1.01, 1.01. Now you increase this. Okay, so you understand, if you understand one, fine. So footing concrete area is done, and then footing trapezoidal portion is done. I'll make one more column here. Okay, this way I'll merge it center. I'll write total concrete. Total concrete for uh, footing. I'll write for footing. Okay, or trapezoidal footing. Anything is okay. So concrete spelling, make it as E. Done. So now you take it to the center, make it bold, wrap the text, and now change it to the way you want. Fine. Now again, select all three, merge at center, take it at the center. What you're supposed to do? Equal to sign 3.46 plus 1.01. Done. 4.47 cubic meter is the answer. Okay. So if you want, you can even mention here that it will be cubic meter. Done. 4.47 is a cubic meter what I'm supposed to get, this much concrete. Now last what is left out, shuttering quantity is left out. I'll make it bit nice. What we can do is we'll merge this part also. Yeah, and this part, this part, this part, this part, this part. Give it a column, fine. And last we'll do this thing. Yeah, total shuttering quantity. Yeah, done. Again, if you want, then you write here. If you cannot write, come here, open bracket, and write this will be in square meter. Close the bracket. Okay, and then 6 here, click here, go to wrap text, make it bold, and change the font. Done. Square meter is good. Square meter. Done. Now what is that formula? Equal to sign. Formula was 2 into length plus breadth. What is the length? 3.8 plus breadth is 2.6. Sorry, 2.6. Okay. Close the bracket. Now multiply this by the depth. So depth of the footing, that is a rectangular portion. This is not 0.6. You should not take 0.6. 0.6 is overall. You have to take 0.35. No, only the rectangular portion. Close the bracket. It's not working. Yeah, 4.48. How much we got? 4.48. Now again, okay, concrete quantity and this quantity is same for us. Shuttering quantity. Yeah, almost same, no? 1.01 and this was 3. Yeah, fine. So now, yeah, yeah. So finally, you got everything. See, now if you want, you can even decorate this part. Uh, okay, I'll share this Excel sheet. Usually I don't share. You try to prepare on your own because it's always good if you prepare. Okay, so that is why I'm not sharing. I'll select this part in this way. Now I prepared this Excel sheet. Now you give me any drawing, I can quickly do any footing, and then if you want, you can change the color of that. Since it's the input portion, then you go with a ball box, all border. Done. Finish. So now you see, we just now, for example, I have a footing which is everything is correct. No, 4.48. Let me verify that and manually done this. Yeah, it's correct. No problem in that. Okay, fine. Now let us say I have a footing whose length is 5 meter, whose breadth is, let us say, 3.2 meter, and whose that the depth is 0.8 meter, and that D will be, let us say, 0.4. Automatically this will change. Okay, 0.8 minus 0.4 is 0.4. Let us say I have a column of 600, 0.6, and the depth of my column is, let us say, 0.45. Okay, and that column offset, this offset, okay, this offset is, let us say, it is 100.0.1. Done. You don't have to do anything. You got to answer. You're footing concrete. You do it as an assignment. Try to do it manually and let me know whether you are getting the same answer or not. So footing concrete rectangular, you should get 6.40. Trapezoidal portion, you should get 2.59. Total concrete quantity will be almost 9 cubic meter, and shuttering quantity will be 6.56. Let me quickly do for the shuttering since it is easy for me to do. I'll do that manually. Let me do that. That will be 2 into 5 plus 3.2 into 0.4. Yeah, I'm getting 6.56. Same thing I'm getting here, 6.56. Even this, the rectangular portion also I can verify. 5 into 3.2 into 0.8 you do. 5 into 3.2 into 0.8. So yes, 12. Okay. No, no. Sorry, 0.4 you have to do, not 0.8, because D is that rectangular portion. No. Yeah. See, this is where we go wrong. So it should be 0.4. Yeah, 6.4 I'm getting, 6.4 I got. Trapezoidal portion, you apply the formula and do it manually. Let me know. The top area you should get. Top area, obviously, we'll get 16 only. Bottom area, okay. Bottom area will be 16. Top area will be 0.52. Okay. Yeah. Yeah. How it is 16? 5 into 3.2 will give me 16. How it is 0.52? 0.52 will be 0.6 plus, yeah, 0.6 plus 0.1 plus 0.1. And then, yeah, it is written here, no, 0.8. and then 0.45 plus 0.1 plus 0.1, 0.65. So 0.8 into 0.65 will give me 0.52. Yeah, everything I have done manually. Yeah, 0.52. This is how you're supposed to find the concrete quantity for the slope footing. Now you get any drawing here onwards. See, these are the drawings what I have, but this is in feet and inches. Now you can get everything just by looking. You got an idea. See, this is 10 inches what they have given. Convert this into mm. So 10 inches comes out to be 25. That is 250 mm. This height is 250. 2 feet, that is 600 mm. This is 1 feet, that is 300 mm. So this I can get, and with this I can find the entire area. So if you want, I can take this as an assignment and do it. I'll do it. Okay. We'll take this as an assignment, not assignment. For this, we'll try to find the concrete and the shuttering quantity. So we'll convert everything instead of 6 feet. Okay, this is 6 feet, this is 7 feet. Okay, convert 6 feet in terms of meter. It's very simple. See, 1 feet, I told you, 1 feet is 300 mm, which is 0.3 meter. Okay, that's it. You just have to multiply 6 into 0.3, which will be 1.8, 7 into 0.3, which is 2.1, and then these things you input in the Excel sheet. We'll quickly do that. So length is mine. Quickly, what is the length? Wait, I'll take this drawing only. I'll bring this drawing there. We'll find for this. Yeah, okay, fine. So this will be 6 into, if you want, I'll do it here. 6 into uh, 0.3. So it is 1.8. So my breadth is okay. Length I'll do. Length I'll take 7, not 6. Okay. Always the longer portion should be the length. The shorter will be your breadth. So this will be again how much? 6 into 0.3. So it is 1.8. What is the depth? So depth, yeah. So this depth is overall depth 2 feet. 2 feet in the sense how much it is? 2 into 0.3. So it is okay. Wait. So why these things comes? The reason is that this you are not applied the formula. So always you have to give either plus or equal to symbol. Only then your Excel sheet will work. So 0.6 will come. What is small d? Small d is 1 feet. Again, I'll delete that, equal to plus sign 0. Yeah. So how much it is? 1 feet. 1 into 0.3. So it is 0.3. Right? Yeah. 1 feet is 300 mm. So 0.3 meter. This automatically it will take 0.6 minus 0.3 is 3. And what is the breadth of your column? So breadth of the column, it is not mentioned here, but for time being, we'll consider the breadth of my column is 600. I'll consider 0.5 this time. And the depth of my column is 0.23, let us consider. Okay, well, the breadth I'll consider 0.23 and depth I'll consider 0.45. Okay, and the column offset, it is mentioned. See, 10 inches is given. 10 inches you convert in terms of this thing. So how do you convert 10 inches? So 10 into 0.0254. Now it is not 0.3. For feet, it is 0.3 conversion. For inches, it is how much? For inches, it is 0.024 because one inch is 25.4 mm or 0.0254 meter. Okay. Yeah. So it is, yeah, wait. So 10 inch in terms of meter, yeah, 0.254. So this 10 inch in terms of meter, it is 0.254. Okay. Yeah, fine. Now you see, you got the answer for this particular footing. You got a total concrete quantity of 1.75 cubic meter and total shuttering I required 2.34 square meter. Got it? So in this way, we have prepared the Excel sheet. You also prepare the same Excel sheet. And now whatever footing, if I give you, within a fraction of second, you can get the answer. That's it. So I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So in this lecture, I have given you this one project. So here, all the footings are your slope footing, right? Now we'll try to understand how the workout has to be done. Okay, everything remains the same. Only the thing is your concrete quantity and shuttering quantity I've explained you, but we'll try to do this so that you will have a good practice on this project also. Okay, this is another industrial project where a small footings are coming up. So first, what we'll do, we'll write the footing here. So I'll show you all the drawings. See, this is one drawing. After this, this is a cross section for that. Okay, your depth of excavation is 2 meter And you can see this is slope footing, what is mentioned here. Okay. Yeah. And then this is the footing plan, and this is your footing, this is your column. C1, C2, C3 are your column, and C1 column is 400 by 450. C2 column is 400 by 450. Okay. Forget about all these things. This comes under the bar bending schedule. You don't have to look into the steel reinforcement now. And next is schedule of footing reinforcement is given. Only two footings are there, F1 and F2. How many numbers? 16 number F1 and 8 number F2. And all these are the breadth, the length, D1, D2, D3, and so on. Okay. So what we'll do now, we'll quickly try to do the Excel sheet now. Only two footings are there. We can quickly finish it. So what I have done, I copied one of my footing, one of the Excel sheet like we did previously. And now I'll take out everything from here. Okay. This is not required. So only two footings we have, F1 and F2. Quickly note down the values. So my F1 footing is 2300 by 2300, and this is 2900 by 2900. Okay. So we'll write here. Yeah. So this is, yeah, 2300 by 2300, and the next footing is 2900. 2900 by 2900. Okay. And we'll see the depth part also. So the depth is okay, 23 and 20. The depth I don't know whether I need to take D1, D2, D3 or so on. So what I'll do, I'll come here. See in this part, that cross section part, it is mentioned. So D1 is your overall depth. D1 is a overall depth of the footing, and D2 is this particular depth. Okay. So now first quantity what we are finding, we are finding the excavation quantity. So I'll go back to this. Yeah. Okay. Yeah, this will be excavation quantity, but here I need to input, no? So for that, what I'm supposed to do, I have to come here. I have to take this particular portion. That means I'll tell you, see, D1 is the overall depth of your footing. Okay. So it is mentioned D1. So you, in this drawing, you have to check for D1. Yeah. Where is my D1? Wait. Yeah. Yeah. It is here. Okay. D1. So D1 is how much? 600. And here also D1 is 600. So what you can do in the Excel sheet, write this as 600. Okay. 600, whereas F2 by default it is 600. Now you'll find the excavation quantity. Before that, F1 and F2 I need numbers. For numbers again it is mentioned here. How many numbers? F1 is 16 number, F2 is 8 number. So input that 16 and 8. So we'll input 16 here and we'll input 8 here. Okay, done. Now coming to this one. How you are going to do this? Again, this will be 0.3, whereas the PCC offset, for the PCC offset I'll refer the drawing. Let me check whether in the drawing they mentioned something or not. Okay, so for that, yeah, I have to refer this drawing. So here, if you see, this is my PCC offset, isn't it? See, this is PCC offset, and this is also PCC offset. So here it is mentioned 75 typical. Okay, 75 TYP means typical. Typical means for all the footing it is same. Here for one footing they have shown that is a typical cross section. Okay, so when they write typical, it means for all the footing. If you have 10 footing, F1, F2, F3, for all the 10 footing, you have to keep your PCC offset 75 on the right side, and here also it is 75. Okay, got it? So what I'll do, I'll go to the Excel sheet. Here, let me do that. So it is how much? 75, isn't it? So I have to make this as 75. Okay, and then this also I need to make 75. You're getting my point? 0.3 remains constant for all, and this I need to make 2.3. Done. So I'll get 3.05. Just drag it in this way. Fine. Next one is 2.9. So here what you're going to do, here I'll directly change it. So I'll make it as 2.9 plus 0.3 plus 0.075 and plus 0.3 plus 0.075. Understood? Okay, 3.65, and this will be 3.65. Done. Now coming to the depth of excavation. So in the depth part, what you're supposed to do, go back to the drawing. So this is the depth. Here you see, this is my natural ground level. That is your finished ground level. From here, your excavation will start. And you see the excavation, how much it is mentioned? 2000 mm, that is 2 meter. But this is given up to the top of the PCC. We are supposed to go till the bottom. And the bottom, this thickness is already mentioned 75. That means 2000 plus 75 I need to add, which comes out to be 2075. So your depth will be how much? Your depth will be 2.075, isn't it? Yeah. So 2000 plus 75 comes out to be 2.075. Okay. Same thing, I'll drag it here also. Done. Yeah, done. You got the quantity now. So the total excavation quantity will be 530 cubic meter. So this answer, yeah, 16 plus it is 24 footing. So if you want, we'll verify it once quickly. Okay, let me verify that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Exactly, 24. And manual calculation, I mean, here also we got 24. Done. Earthquake quantity you're done. Next, what we have, you go back to the drawing again. Yeah, go back to the drawing. So in the drawing, check in the cross section whether you have any other thing. See, in the typical cross section, directly we have PCC and the thickness of PCC is 75 mm. Okay, so directly come here. So we'll go with the PCC part. We'll go with the PCC. It's given here. This entire thing I'll delete. Okay, this entire thing I'll delete, or I think I can keep it. Okay, I'll keep it. On this part, I'll copy from here. Okay, so this part I'll copy. Control C. I'll bring it here. Control V. And this from F3, it is not required. Okay, done. So F3, F1 is done. This will be in cubic meter. 16.8 is 24. Now come here. So how much it will be? So this I need to change. Okay. So I'll completely write it. So I'm calculating now. 2.3 plus 0.075 on the left side plus 0.075 on the right side. Got it? So it is this step, no working space will be added. Similarly, here also you do the same thing. So it is again 2.9 plus 0.075 plus 0.075. This is offset, okay? I'm adding the PCC offset on both the side. And now coming to the thickness. So thickness, what was mentioned in the drawing, it was 75 mm, right? So this was 75 mm. This is 75. So I'll just put here 75. That is 0.075 and this also 0.075. Done. You got your answer. The total PCC quantity is 12.78 cubic meter. Next, very important is the footing shuttering quantity. So again, footing shuttering, how we are supposed to do? It's simple, but you need to take care of the depth. So I'll copy this part. Only this much I'll copy. Control C. So footing shuttering, I'll write here Control V. The rest things not required. Okay, and this will be in square meter. And okay, you make it in square meter. Fine. Now coming to this part. So it will be perimeter now. Okay. So it will be perimeter. So again, try to do the calculation. So it will be 4 into 2.3. And here it will be 4 into 2.9. 2.9. Okay, fine. Now coming to the depth. See, this depth, whatever you have, no, this is the overall depth. This 600 and 600 is the overall depth. Now you need to be very careful. I'll explain what exactly we are trying to do here. Yeah. So this D1, whatever I written, no, this is the overall depth of the footing. But since it's a slope footing, your shuttering will be done only up to this portion, isn't it? Your shuttering is only up to this portion. This only here your shuttering will come. That means we need to consider D2 depth now. Why? Again, for the very same reason that which I've shown you through this drawing. See, this is at D2. Okay. Only here shuttering will come. Above this, there is no shuttering. The slope you are going to give. Okay. So that is why what you need to do, you need to take care of that D2 portion now. So what is written here? D2. Now what is this D2? You have to check it in the drawing where the D2 is given. So we'll check it in the drawing where the D2 is given. So the D2 is 200 mm and the D2 is 200 mm, both side, 200 and 200. So in the Excel sheet, what you do, you have to put 0.2 here and 0.2 here. And you can even put a remark here, because now people may get confused. This guy has written 600 and 600, but here he has taken 0.2. So you can make one remark here, remark. Okay. So that sometime even if you get confused, you can refer here. Okay. Since slope footing this D equal to 0.2 meter from drawing, or even you can mention the drawing number from drawing. From drawing, that's it. If it is a very big project and all, you mention the drawing number, so that directly you can come to that drawing and you can refer it. Okay, pretty simple. I think you got the quantity. So you'll get 48.48 square meter. Okay, done. Now the last point is the footing concrete quantity. Now for concrete quantity, what will happen? This portion will not work out, right? This whatever we have done, this won't work out. For footing shuttering quantity, for footing concrete quantity, we need to use this particular Excel sheet which I had created, right? Where is that? Yeah, this is the Excel sheet what I had created. So what you can do, you can add the same thing over there. I'll tell you how it has to be done. Footing concrete quantity. For that, this Excel sheet will not work out. You have to calculate the separate Excel sheet. Okay. I mean, you can use even this Excel sheet. See, you use this Excel sheet, no problem. Whatever values you get, directly you can do the input there. Otherwise, in this, you have to make a this thing. What is that? Addition you are supposed to do. You can first do the concrete quantity for the rectangular portion, then you can do it for the trapezoidal portion, then you can say total concrete. What I'm trying to tell is, I'll delete everything. Okay, I'll delete this part. This part will delete. For concrete quantity, first we'll write this. Okay, I'll write this. Control C, right here. Control V. Similarly, right here also Control V. Okay, concrete quantity, so it is cubic meter and cubic meter, fine. So number you copy from here, 16 and 8, no? So this is 16 and 8. This is also 16 and 8. Okay, this portion you take it out. So you, if you want, you can insert one more this thing here, so that you can write here. Again, one you can insert. Okay, and you can write here. Yeah, here you can write. I'll write here. This is my trapezoidal portion. Okay, otherwise, see, if you're capable, you can do everything in a single Excel sheet only. You don't have to separate like rectangular portion. I'll write rectangular portion here. Okay, I'll write rectangular portion. Just for easiness, I'm doing this. Otherwise, you can follow even that also. Okay, no problem. This is F2, no? Okay, no problem. Do. I've written rectangular portion. This is trapezoidal portion. Okay, yeah. So rectangular portion is very simple. What you can do, 2.3. Okay, and this is also 2.3. And what is the depth? Depth directly footing depth you're supposed to take. That is only the rectangular portion. That is 0.2, because wherever that shuttering has happened, no, this 0.2. I'll show it again. This portion. Right now, I'm calculating the concrete for this portion. Okay. So length and breadth remains the same. Only this depth will be D2. And D2 we already saw in the drawing now, that the D2 is how much? So D2 is 200 and 200. So directly you take 200 from here. You can input 0.2 and you can input 0.2 here. Okay, done. Now come to the trapezoidal portion. For the trapezoidal portion, what you can do, what I'll do, no, I'll do very simple trick. I'll do a very simple trick. I'll take out all this quantity. Okay, I'll remove everything. Directly what I'll do, I'll directly take this Excel sheet and here I'll input and get the value. You can create your own Excel sheet. Here I'll do that. Okay. So what is my size of F1 footing? It is 2.3. This is also 2.3, right? And this depth, overall depth, I'll bring that Excel sheet here. Yeah, 2.3, 2.3. D1 is my overall depth. So D1 is my overall depth, and D2 is my that height 0.2. So 600, 0.6, 0.6, and this will be 0.2. So this height I'm going to get as 0.4. That is, this height will be 0.4. Now, what is B? B is your column dimension. Okay, now what you're supposed to do, go back to this drawing. Yeah, go back to this drawing. See, wherever F1 footing is there, F1 footing C1 column, F1 footing C1 column, F1 footing C1 column, F1 C1, 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 then F1 C1, F1 C1, then F1 C1, F1 C1, F1 C1. That means wherever F1 footing is there, over that C1 column is there. And what is the size of C1 column? That we have to see now. So to get the size of C1 column, it is mentioned here, C1 column, okay, size is 400 is the breadth and 450 is the depth of that column, okay. So it is mentioned 400 is a breadth and 450 is a depth. So input the same thing in the Excel sheet. So breadth is 0.4 and depth is 0.45, isn't it? 0.45, done. Now this column offset I want. So column offset, how you are going to get? Again, you have to refer to the drawing, okay. So this is the drawing what I'm supposed to refer. So you see here, it is mentioned D3 or D4. D3 or D4. That means D3 is for a shorter side and D4 is for the longer side. Okay. Anything is okay because anyhow, yeah, no, then that variation will come. Wait, I'll tell you. For that, you refer this plan. Okay. So in the plan, you see, okay, this is D3 and this is D4. Okay. So this is D3. Horizontal part is D3 and this part is D4. Okay. That is, now again, in this, you have to check which is breadth and which is this thing. Okay. So this is B1. Yeah, this is breadth and this is length. See, now you may get confused, sir. D3 where we have to take. So this D3 you have to take parallel to the length side. This is length and this is breadth. Okay, you're getting my point. Now my intention is to find this area. Now my intention is to find this area of the column. Okay, in that already this column dimension I know it is 400. This column dimension I know it is 400 by 450. So which is 400 in this? Shorter side is 400. So it's given here. See, this is length portion. This is breadth portion. Okay. So length portion will be always bigger. You take this as 0.45 length portion. Okay. And this will be 0.4. Okay. 0.4. Now this is D3. This is also D3. Which is D3? How we are going to take D3? So whichever is parallel to the length is D3. Okay. This is D3. So what I'll do, D3 you won't get it here. For D3 I have to refer here. So D3 is 500. D4 is also 500 for F1 footing. Okay, you have to understand for F1 footing your D3 is 500, D4 is also 500. That means here also it is 500, here also it is 500. So my calculation remains simple. Go to the Excel sheet and here you have to write 0.5 column offset. Okay, done. So once you do this, you get all the area. So the total concrete quantity what you have got is 2.47. So in this Excel sheet, you can input here 2. Here you input the value as, yeah, directly here you input the value 2.47. Okay, and then 2.47 into 16 number of footings are there, so it comes out to be 39.52. Okay, so again we'll go back to that sheet. 2.47 and shuttering area was 1.84. We'll verify whether for F1 we have got 1.84 or not in shuttering. Yeah, you see here 1.84 we got no shuttering area for F1, and same thing through this Excel sheet we have verified the answer. Okay. Yeah, you can see 1.84, and here also we got 1.84 for F1 footing. Now we'll do for F2 footing. Okay. For F2 footing, what is the size? Should be 2.9. Breadth is also 2.9. Okay. And this depth will check 2.9 to depth 600. This is 200. Okay. This is 600. This is 200. And okay, this remains the same. 600, 200. This will be 0.4. And this B and D. B and D is the breadth and depth of your column, isn't it? So now this F2 footing, where it is lying? This F2 footing. Yeah, I want the plan now. Yeah. See, you're on F2 footing. Again, C1 column is there. Okay. On F2 footing, we have C1 column. On F2 footing, we have few C2 columns. So now what we can do in F2 footing, we have few C2 column. On F2 footing, we have few. On F2 footing, we have few C1 column. But since the column size is same, since the column size for both it is same, we don't have problem now. So I'll go here. See here. For both the column, 400 by 450. C2 column is also 400 by 450. So it doesn't matter. Directly you can input 400 by 450 here. So 400 and 450. Now column offset I require. Okay. So column offset, go back to the drawing. So in this drawing, what is the column offset given? It is given 550 and 550. Okay. Both D3 and D4, both it is 550. Okay. No problem. So come here, go to the Excel sheet, input 550. So 0.55, 550. Done. You got the answer. So the answer is total concrete quantity is 3.70. Just input here 3.70, 3.70, and 3.70 into 8 will give you 29.6. So the total concrete quantity will be 81.60 cubic meter. Now also try to see the shuttering quantity here. What is the shuttering we got? 2.32, and here you can see already 2.32 we have got, right? The manual, this thing already we had done, no? For footing separately I had done. Okay, but concrete quantity I used that Excel sheet and I did it. So 81.60. Okay, 29, 40, 40, 60, 67, and 5, 82. Yeah. So 81.60 cubic meter of concrete. This is not 48. So this will be how much? This will be 24 only, because 2 times I've added. No, that is why. Yeah. So this will be 24 only. This will be 24 only. Okay. Good. So in this way, we have found the footing concrete quantity and all those things. Okay. I hope you have got an idea how all these things has to be done. Okay. Otherwise, you can even use this Excel sheet and do it individually, and then you can link it here. That also you can do. Else here itself, I could have put the formula, but again it will a lengthy process, so I didn't do that. Try to do it manually and let me know how much answer you are getting. Okay. Almost everything is correct. There's no wrong in this. If something goes wrong, just tell me. Okay. Yeah. So after this, what is left out? After this, the shuttering work for the neck column till the plinth beam, and the shuttering work for the this thing, concreting work is left out. That also I'll explain you, but you do it on your own. See here, that part is given. Here, that part is already given. Now I need to find the shuttering quantity up to the top of the plinth beam from here. Okay. So how I'm going to do it? It's very simple. See, this is 2 meter. This is 2 meter. In this, I'll deduct this depth. This D1 I'll deduct. That is from F1 footing. Whatever is D1, that is 0.6, I guess, that I'll deduct. So I'll get height up to this portion. I'll get height up to this portion. Okay. And from finished ground level to this top, it is 0.20. TOC means top of the concrete. Plinth beam top level should be 0.20. This is 0 level. This is 0.2. That means this height is 200 mm. Very simple. You're getting my point? This height is 200 mm. This height what you have, it is 200 mm. How can I tell that it is 200? This is 0 level. This is at a height of 0.20 meter, which is 200 mm. So this height is obviously 200 mm. So just add 200 mm to this particular portion. You'll get your height of the shuttering. We'll quickly do that also, not an issue. So what I can do is I'll go here to the Excel sheet. Okay. Yeah, but for this I need to write that also, like C1 column on F1 footing, C2 column on F2 footing. What? Okay, I'll explain you that also. See, there are a lot of things to be done. I'll take it out. Okay, what you're supposed to do now? First you count. Okay, this is very important. See, F1 footing, what all columns are there? On F1 footing, C1 column is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 columns. That means you have to write here. Yeah, C1 column on F1 footing. So how many numbers are there? 16 numbers are there. Okay, fine. So next what you're supposed to find? Next you're supposed to find the shuttering quantity. So what is the size of C1 column? So I'll write here the size of C1 column is 450 by 450. Okay, and C2 column size is also 450 by 450. Here the column size is same. So I'll write, so by default 0.45, 0.45 is already written. Now coming to the, okay, I'm doing the concrete quantity. No, I have to go to the top. Wait, just give me a minute. Okay, here itself I'll change it. Okay, I'll write shuttering here, no problem. Okay, this is shuttering done. So I require the perimeter part now. So this is of no use to me. This portion and this portion is of no use to me. So shuttering part, how I will do? Yeah, shuttering how we are going to do? Very simple. Equal to 4 into 0.45. Okay, perimeter I found, and this perimeter will be multiplied by the depth. Okay, so depth I'll tell you how much you have to take now. So depth will be, what is the overall height? It is given 2 meter. See here, this is 2 meter. From 2 meter I'll deduct d1. So d1 for f1 footing is how much? We need to check that also now. So d1 for f1 footing, for f1 footing my d1 is 600. So 2 minus 0.6, I'll put it in Excel sheet. 2 minus 0.6. Okay, but I think there's one more thing we need to check out. That is, yeah, correct. So 2 minus this one I did, okay, 0.6. Okay, then I reached up to this level, and from here I'll add 0.2 to that, because your plane beam I told this is 0.2. Okay, 200 mm. So plus 0.2. Yeah, I got the height. So just multiply this. 1.6 into 1.8 will give me 2.88, and 2.88 into 16 will give me 46.08. So 16 into 2.88 will give me 46.08. Fine. Next, come to the second footing, second column. So again, you go back to the drawing. Again, in the drawing, you need to check. See, now you see. Now on F2 footing, we have C1 column, and also on F2 footing, we have C1 column also. We have C1 column. You see here on F2 footing, C2 column. So first we'll check those column. We'll check C1 column. So F2 footing on C1 column, I'll do a tick mark here. Okay. Yeah. So C1 column 1, F2 C1, I need to check. F2 C1, F2 C1. Wait, let me, yeah, this one. So F2 C1, yeah, this is F2 C1. Then again, F2 C1, F2 C1. Yeah, that's all. No other. How many are there? 1, 2, 3, and 4. So right here, C1 column on F2 footing. How many are there? 4 are there. Okay. The perimeter, of course, it will be 4 into this thing. Perimeter remains the same, no problem. And then this height. This height you need to check now. So how we are going to check? The same thing I'll bring here, and now I'll do the change. That is 2 minus, now this is resting on F2 footing, isn't it? So since it is resting on F2 footing, I need to check the F2 footing depth. That is also 600. See, this is also 600, no problem. F2 footing is also 600. So no problem. Directly you can take it as minus 0.6 and plus 0.2. So this remains the same. So this answer also we get the same thing. 2.88 into 4 will get 11.52. Next, last one we have C2 column, because there was C2 column also. C2 column on F2 footing. Okay. Again, the size of your C2 column is also 450 by 450. Okay. Just drag it square meter. And here everything remains the same because nothing will change here. Okay. C2 column size is also same. On F2 footing it is resting. So this also remains the same. This also remains the same. This also remains the same. Only the thing is the number I need to find. So number I can find easily. How? 16 plus 4 is 20. Totally we had 22. 22 minus 22 should be the answer here. So we'll see whether we are getting 2 or not. Okay. You can do that reverse calculation also. So let me check. Okay. That is, what should I check? F2 C2 I need to check. So F2 C2 1, F2 C2 2. Okay. No, I think I've gone wrong. Wait. F2 C2, no? So what is the total number of footing? Oh, it is 24. Sorry, not 22. Okay. Then I'm correct. It should be 24. So this is wrong here. This should be 24. If it is 24, then this should be 4. Very simple. Yeah. Now we'll verify. Now we should get correct answer. Yeah. See, F2 C2, F2 C2. Then again, F2 C2, F2 C2. Is there anything F2 C2 here? No. So 1, 2, 3, 4 exactly. So 4 we got. So that is why I've written 4 here. Okay. Now rest things will happen same. So total shuttering quantity. Sorry. Yeah, this is shuttering quantity. Okay. This is total shuttering. So total shuttering quantity up to the plinth beam top is 69.12. Okay. Yeah, 46 plus 11 is 57. 57 plus 11, 67. All this will, yeah, we'll check it. 46, 56, 66, 67. Okay. Done. Fine, it is correct. Now last what is left out? Concrete quantity is left out. So concrete quantity, how we are going to do? Very simple. Just copy everything. Okay. The same thing you copy. Copy. Shuttering. Yeah, concrete quantity. I'll write here. Okay. For this, I'll paste it. And this let me remove. And this I'll put it in cubic meter. Okay. And I'll drag it. So everything is correct. So what you are supposed to do? Concrete quantity is 0.45. This also will be 0.45. Everywhere it is 0.45. So just drag it. This also you drag it. Okay. And this height was 1.6 everywhere. Yeah, 1.6, 1.6, 1.6. So it is 1.6. So 0.45 into 0.45 into 1.6 will give me 0.72, and 0.72 into 16 will give me 11.52. Similarly, I did for this column also, which is lying on F2 footing. Here also it is 2.88, and this also it is 2.88. Okay. Yeah. So total concrete quantity up to the plinth beam top, this is cubic meter, will be 17.28 cubic meter. 11 plus 2 is 13. 13 plus 2 is 15. And then this all things. Yeah, 17.28. Let me verify. 11.52 plus 2.88. 2.88. Yeah, 17.28. Got it? Yeah. So in this way, we have found this thing. The entire quantity estimation for the slope footing has been done. Now, what is the last part which is left out? That is your backfilling quantity. Quickly, can you do the backfilling quantity? Let me do that. Okay. Okay. Backfilling quantity will be total excavation quantity. Tell me what is the total excavation quantity. So the total excavation is 530 minus your store. there was no stone soling here, minus PCC quantity, minus footing concrete quantity. So this much footing concrete will go, okay, minus column concrete quantity. So in the column concrete quantity, I have taken up to the plinth beam top. I need to, if you want, you can deduct it, but here I'm not doing, it's okay. So 418.33 is my backfilling soil. I'll also do the 80% of this, that is 0.8 into back total excavation quantity. The total excavation was 530. So how much I'm getting? Okay, it's not happening. Multiply by 530. 530 you remember, else we'll do it here. It's not coming. Okay, okay. Oh, okay. Wait. I'll do this 530 only directly. Plus sign I need to put. Yeah, you see 424 is coming. Okay, see that was slight variation will happen. No, not a problem. Okay. Actually, it will come almost same. Slight variation is because extra quantity we have taken. No? Okay, but almost same. Okay, 75 to 80%. I could have taken even 75% of this. It varies from 75 to 80. That is why that variation will come. Yeah, almost 400 and 418 is actual quantity what we have got. We're okay with that. Okay. So in this way, you're supposed to do the quantity estimation for the trapezoidal footing. Everything is same. Only that trapezoidal portion will come that you need to take care of. Right. So I hope you have enjoyed my lecture up to here. So you got a complete idea how the trapezoidal footing or the slope footing, concrete quantity, the shuttering quantity has to be done. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So in this lecture, we'll try to see how to calculate the concrete and the shuttering quantity for the step footing. So what is this step footing? In the step footing, I'll show you how this step footing is going to look. So if I show you one image, so this is a step footing. Okay, this one is actually a step footing. So what happens in step footing? You have one footing, and over that you put another footing, which is called as a step footing. So how we are going to find the concrete quantity and the shuttering quantity? We'll try to see that. Okay. So for that, I have taken one particular drawing. So it's very simple. Okay. There's no much difficulties in this. So we'll go in this way. So this is a cross section what they have shown for the footing cross section, and this is a plan. So in the plan, you have got the length of the footing, which is 3.8 meter. Okay. So you see, this is 3.8 meter, the footing length, and this the breadth is also 3.80 meter. Very simple. What is the depth of your foundation? See, the overall depth of your foundation is 0.90. Okay. Overall depth. When I say overall depth, it means from here it is 0.90. From here, okay, from here I'll take from here it is 0.90 up to where? Up to this level. Okay, this level it is 0.90. Okay, but other than that, they have shown another thing. What is that? They have shown another thing. This is 0.50. If this is 0.90 overall, only this first step is 0.50. Your second step is 0.40. That means, again, very simple. This first step, this is 0.50 and this is 0.40. Very simple. Okay, this much thing you have understood. The same thing is mentioned in the drawing and same thing I've shown you practically. And over that, of course, a column will come. So this is a column dimension given. Okay, now this, yeah, now you understand. This is a plan, okay, for the first footing, for the first step. Yeah. So this is a plan for the first footing. This is a complete plan. And what is the size of this? It's mentioned 3.80 by 3.80. Okay. Now we'll go with the second step. So this is my second step. This is my second step. And what is the size of this? It is mentioned here. See, they are not given the size, but this is the length what I want. This length, this is length, and let us say this is breadth. This is what I want. Got it? And then this is a column what you have. And here, I mean, I'll do in this way. This is a column what you have. And the same column can be seen here. This much is clear? Fine. Now, PCC quantity and all, everything will remain same. Like I explained, no? Same thing. Again, for PCC, you see here, These people have shown on a dotted line, no? This dotted line, can you see? This is actually a PCC. Okay. Now, how do you find that? Very simple, PCC. How do you do that? Footing size is given 3.8. Add PCC offset on the left side, PCC offset on the right side, length. In the breadth side also, you do the same thing, left and right. Now, where do you find all those things? It is given in the general drawing. Like, see, this is a general drawing what I have. But these people have not mentioned. These people have not mentioned what should be the offset from here to here, what should be the offset from here to here. So you take 75 or 100, doesn't matter. Okay, that is simple. We'll try to find the concrete quantity now. I'll go back to this. So how do I find the concrete quantity? Very simple. First, we'll do it for the first step. Then we'll do it for the second step. Okay. So for that, you have to prepare the Excel sheet. So I'll write Excel sheet, step footing I've written. Okay. Quickly, we'll do everything. Okay. You prepare on your own. I'm preparing it here. You also prepare. Length I require, breadth I require. Then I'll do this D, capital D. Okay. Or even you can write step 1, step 2. That also you can do. Step 1. I'll write step 1 here. Okay. And then I'll write step 2. This also you can do, or capital D, small d, and it depends how you're preparing the Excel sheet. Okay, length is done, breadth is done, step 1, step 2. This is enough for me. Okay, and yeah, this is enough. So I'll write here concrete quantity. This is for me concrete quantity. Okay, I'll do this concrete quantity, step 1. This is step 2. Then this is total concrete quantity. Then this is shuttering quantity for step 1. I'll do this for step 1. I'll say shuttering quantity for step 2. And this is total shuttering quantity. Okay. In this way, I selected. See. Okay. Merge at center. Got it? Now you write here. So first, step 1 concrete. Step 1 concrete. Make it at the center. Bold. Okay. Same thing we copy here. So make this as step 2. Step 2. Same thing you copy here and write here total concrete. Okay. Total concrete. See, I'm teaching you how to do it, but when you prepare, no, when you get such drawing, you have to prepare like this only. Okay. How you're supposed to prepare in this way. Yeah, where is that? In this way, you have to prepare it. Okay. No excuses. Like, you have to write here F1, F2, F3. But here right now, I'm not writing this because it's a time consuming. Only the thing is the concrete calculation will change. That is what I'm trying to teach you here. Yeah. Next. Step 1, shuttering. Okay. Make it at the center. Then pull it again, and then again you do it. So here you write step 2 now. Step 2, shuttering. And here it is total shuttering. Okay. Simple Excel sheet you can prepare. Total shuttering. Okay. Now for the length part. So length I'll write here. So what I can do now, I'll delete this part. Length, breadth, okay, I could have taken it to the top. I'll take it to the top. Okay, well, let me delete that. Why I'm doing is that I'll write length here. I'll write breadth here. I'll write step 1. I'll write step 2. Okay. Now you align that. When you make Excel sheet, no, make it look good. It's a time consuming, but still, because one time investment it is, but try to make it little good so that you also feel like inputting the values into that. Okay. And this part I'll write here. Yeah, done. Okay. This, if you want, you give border to these people. Okay, done. So step 1 concrete will come here. Step 1 concrete I'll put here. Step 2 concrete will come here. Step 3 concrete will come here. Shuttering will come here. This shuttering will, sorry, this shuttering will come here. It will come here. Merge at center. Take it the center. Yeah, and then use this. Then you have to merge this also, no? Yeah, done. Okay. Now you tell me what is the length of your footing. So what is the length of my footing?
So length is 3.80. This is also 3.80. So quickly input that. Length is 3.80. This is also 3.80. And then you tell me this part. Yeah. So length is done, breadth is done. This overall height I don't require. This is my first step. This is my second step. So first step height is 0.50. Second step is 0.40. Sometimes the second step will not be given, no problem. Overall depth minus the first step will give you this step, okay? If it's not given. So 0.5 and 0.4. So 0.5 and 0.4. So again select it, go to the center, make it bold, okay? And bring it the center. If we want, we'll color that. We can put it in red color. Yeah, done. Fine. Now, step one concrete. Step one concrete is your very simple rectangular portion equal to length multiply by breadth multiply by step one. Done. You got 7.22 cubic meter. Now, step two concrete. So yeah, we missed 1 point now. Yeah, good. So what I will do is, I should have added one more column here. I'll Okay, fine. Let me try to insert one this thing row here. Wait, want to insert one row. Insert. Yeah, possible. And insert. Okay, see, whenever you want to insert the row, like after this B, I want to insert one more row. Okay, select here, right click and say insert. So one column will be inserted. Again, select here, say insert. Two column will be selected. Okay, now I'll write this as L dash. Okay, L dash, and I'll write this as B dash. I'll tell you why I'm writing that. Okay, so the reason for that is, yeah, L dash and B dash. Why did I write L dash B dash? Because if you see the drawing, I took overall footing. This was my length and this was my breadth. Again, this is also footing. If I want the second step, I want to know the plan of this, right? So again, this will be my L dash. Say, let us say this is L dash and this is B dash. This is L and this is B. You can give any name. Okay. You can even give second step length, second step breadth. Depends on you, because you are the creator of the Excel sheet. So you should be knowing where you need to input the values. But it's okay for us. Okay. Now, one more thing. See, this length, this guy is not mentioned, but not a problem. We know simple mathematics. 3.80. If I deduct 0.88 from here, and if I deduct 0.88, I'll get this portion. In the same way, this is also 3.88. If I deduct 0.88 from here, and if I deduct 0.88 from here, I'm going to get this length. So directly I'll do it in the Excel sheet, or directly I'll do it there. Okay, 0.88, you remember the value. Okay, this portion I don't know. I'll write here. So 3 plus 3.8 minus 0.88 it is. So it is 2.92. So you input 2.92 here, 2.92, and here also you input 2.992. Okay, correct? No? Yeah, 3.8, 3.8. Let me verify. Okay, yeah, 3.8 minus 0.88 minus 0.88. Yeah, yeah, I did wrong. See, I did one mistake. From both sides, I need to deduct. No, 0.88. Now it is correct. So it is 2.04. Yeah, 2.04. This is also 2.04. Okay, yeah, 3.8 minus 0.88 from here minus 0.88 from here. 2.04, 2.0. Fine. Now step 2 concrete, very simple, equal to this L dash I'll take. I'll multiply by 2.04. I'll multiply by step 2 now, not step 1. This step 2 is for this particular concrete. Okay, fine. Step 2 is for this particular concrete. So again, if you want, we'll check it out what we have done. Yeah, this length I want, this breadth I got, and then this depth I took. Okay, fine. So I got the concrete quantity for this. Yeah, yeah. Then next is shuttering quantity. Now total concrete quantity, right, equal to sign this plus this. You'll get total concrete quantity of 8.88 cubic meter. Now come to the shuttering. Shuttering is again very simple. First bottom one will put. I'll show you that also. Yeah, I want this one. See, shuttering. This part it is, okay. Shuttering. Okay, this part shuttering. See, okay, this is not clear. We'll show here only. Yeah, this part, that shuttering. Okay, this shuttering will come, this side also it will come, here also it will come, here also, all the four sides. Here only three sides, but I'll do the three sides later. Let us consider all the four sides your shuttering will be done. So I require the perimeter multiply by the depth. So I'll come here. So step one shuttering will be how much? I'll directly take this perimeter. Okay, you can use the formula 2 into length plus breadth, or even since length and breadth both are same, you just multiply 4 multiply by wait, we'll not do like this. Since we are creating Excel sheet, we'll put proper formula so that in future also I can use it. 2 into length, okay, plus breadth, close the bracket, and then multiply by the depth. So depth is how much? Step 1, 0.5. Done. Your shuttering quantity 17.6. 7.6 equal to, again, same formula. 2 into open bracket. What is the length? This time you're doing step 2. So you have to take L dash 2.04, 2 into L plus B. 2 into L plus B multiply by depth. So again, depth will be step 2 this time, and close the bracket. Done. 3.264. Okay. Done. Now total shuttering will be how much? Equal to 7.6 plus 3.26. That's it. 10.86 square meter. If you want, you can input here. Always units is good. Okay. You practice all those things. Cubic meter. And this you write square meter. Okay. Done. Finish. Then if you want to extend this. Okay. Again, we can finish. So step footing is done. Now I'll ask you one more thing. Suppose if there was one more step, because there is every chance, I'll show you here. See in this particular footing. So I think, yeah. See here. Here it is a single step only. Give me a minute. I'll show you that part. Yeah. So you check here. See, sometimes we'll be having three steps. You can see step 1, step 2, step 3. In the same way, practically you see here. See, this is your first step. This is your second step. This is your third step. In that case, what you do? Very simple. Come in the Excel sheet. Now again, you write here step 3 part. And then this L dash B dash is over. Then again, you have to create another one. Because for the step 3, length will be there, breadth will be there, and the height will be there. I mean, the depth will be there. Okay. So you can create your own Excel sheets. I did it for 2 footing. If you want, I'll create for you. The same thing you have to do. That's it. Again, create in this way. Right here. Okay. This time I'll write here. I'll insert here only. So insert. Okay, it will come on this side. Insert. Then again insert. And then you insert one here. Okay, fine. Now this time you write this as LB, L dash B dash. You write L double dash. So that will be more logical, no? L double dash. That means your next step. And this is B double dash. You can even say first step, second step also, but it's okay. Depends on you. Next is step 3. Done. If you have a third step, then you do this accordingly and input the value here. Similarly, prepare one more thing, one more Excel, and then finally add everything. Total concrete will be step 3, step 1, step 2, and step 3 concrete. Okay. You got the shuttering quantity, you got the concrete quantity. That's it. This was the main intention. And after that, nothing problem. After that, your column and all, everything will remain same, because column, yeah, in column, what will happen? You just have to deduct the overall height. Okay. That means capital D you have to deduct. That means if I want to find the this thing, column height up to the top of the plinth beam, what I'll do, from here the height is given, deduct from here, okay, up to the top, and now you deduct the entire capital D of the footing. That means capital D, or you can add this footing step plus this footing step, and then you'll reach to this level. Okay, this is very simple. A column portion is very simple. Okay, so in this way you're supposed to take care of that. Now some of the cases you get this kind of footings again. So this is also step footing, but here what has happened, here this was exactly at the center, right? This was exactly at the center. But here, this is at the center, almost at the corner side. At the corner, like practically this is that particular image. See, you have a footing, you have a step footing, but here it is attached to the wall part. So then what you are going to do? Here also same calculation, nothing will change. Only the thing is your shuttering will change. Shuttering in the sense, this portion you will not do shuttering. That means I'll show you here.
Yeah. Now you see here. See, this is that particular thing. You just tell me how you'll find the concrete quantity. Similarly, so I'll give you this length, I'll give you this breadth, I'll give you this height. Concrete quantity you can find. Again, here also you can find the concrete quantity. Obviously, this length I'll give, this breadth I'll give this depth. Concrete quantity you can find. Shuttering quantity, what you have to do, since you see this part will not do any shuttering. That means since it is attached to the wall here or attached to this particular, yeah, I mean wall, it is, there's a compound wall. These people have directly done a PCC. Okay, no problem. So shuttering, what will happen? 2 into length plus breadth, that formula will not work out. Here, you directly take the perimeter. Okay, that means perimeter in the sense this portion you have to take. This length I'll take, this length I'll take, this length I'll take. 3 side. This side will not put any shuttering. So 3 side multiply by the depth. Finish. Shuttering you got. Similarly, on the top also same thing. Length, this breadth, I mean, and this length. You add all the 3. Here, there won't be any shuttering because it is attached to the wall. That portion shuttering you have to take out. I'll do one for you. I'll do one. This only we'll try to do. Okay. This only we'll try to do. Quickly, I'll not do in Excel. Here itself, I'll do that. Okay. Concrete quantity, quickly, I'll not do. I'll tell you. See, 3.7, 3.37 plus 3.20. Okay. Length I got, breadth I got. Depth is given here. First step, 0.45 you do. Okay. Fine. Now come to the second step. This length I don't know, but I know one thing. What I know? I know this is 3.37. 3.37 minus 0.74 you do, you'll get this length. This breadth is how much? This breadth also I don't know, but I can find the breadth. This is 3.20 minus 0.65 minus 0.65. I'll get this length. So length I got, breadth I got. Depth is second step. This is your second step. You multiply this by 0.45. You'll get the volume. Done. Now I'll teach you the shuttering quantity. Shuttering I'll do here itself. Okay. Shuttering. Shuttering for first step. Okay, how you'll do? Very simple. Just find the perimeter. It's enough for me. So what is the perimeter? 3.37. Okay. One thing you need to check which side is attached to the wall. Okay. For example, if this is attached to the wall, let me consider two cases here. Okay. Now this portion is attached to the wall. Okay. Then shuttering quantity will be this one, 3.37, 3.20 and 3.37. This is 3.37. Okay. We'll do that. Quickly do that. 3.37 plus 3.20. Here that formula 2 into length plus breadth will not work out. Plus 3.37. Tell me the perimeter. So 3.37 plus 3.20 plus 3.37. So it is 9.94. 9.94 it is meter. Okay, running meter, perimeter. I want shuttering area, no? So what will be area? Shuttering area. 9.94 perimeter multiply by the depth. First step we are doing. So first step depth is how much? 0.45. It is 0.45. Just write here 0.45 and multiply this. 4.47. So I require 4.47 square meter. Okay. Yeah. 4.47 square meter shuttering is required. So my first step is done. Shuttering. Yeah. Done. Okay. Done. Now come to the second step. Now in second step again what I'll do? Second step again this length I want, this length I know. Okay, this length also I know, and this length also I know. Add all three, multiply by the depth of the second step, which is 0.45. Finish. Add both the thing, you'll get the total shuttering quantity required in this footing. Okay, this is case 1. So let me go with the case 2. Case 2 is nothing but instead of here my wall is here. Now instead of this my wall is here. Now you tell me, I'll bring the same answer back. Okay, I'll erase this part. Yeah, my wall is on this side. That means this footing area, I'll not do shuttering here. Now you tell me the perimeter. Again, perimeter will be 3.37. Okay, plus 3.20 plus 3.20. That is 3.20, 3.37 plus 3.20. Tell me how much it comes out to be. 3720. So it is 9.77 meter. So area will be shuttering area. Shuttering area will be 9.77 multiplied by the depth. Depth is how much? Again, depth is same. First step I am taking 0.45. 0.45. So it is 4.39. 4.39 square meter. In the previous case, we were getting this as how much? We were getting 4.47. Now I'm getting 4.39. Very simple. So in this way, again, here also same thing. If you want to do the second step, this side, okay. Second step, anyhow. Yeah. So in second step, now it is very important. See now, in second step, what will happen? Shuttering will come in all three sides, all four sides, because this side also will do shuttering. This side also will do shuttering. Okay, anyhow, this side also will do shuttering. Okay. Yeah, because what I've shown is wrong here. I mean, see, what I'm trying to tell is, I mean, in the second step also, shuttering will come in three sides unless this footing is shifted here. Because right now, with the same logic, I cannot draw this. Then your footing would have been shifted something like this. Okay, this would have been your second step. Okay, this would have been your second step. Then of course, same thing. This length, and this length I would have taken. Now, now if I try to do, no, it doesn't make sense, because since wall is here, then this portion should have been, this portion should have come here. Okay, that is how it is. Otherwise, there may be one more case also. There may be one more case also where your second footing will be exactly at the center. Let us consider your second footing is exactly at the center. Let us consider the case, which is not possible. Let us consider. Okay. In that case, what will happen? Your second footing shuttering will go everywhere. That is 2 into length plus breadth. You can put this length plus this plus this plus this plus this. Okay. Usually that doesn't happen, because this kind of footings come whenever you have walls and all. So that is why it has been made in that way. But you understand the concept. This is how it has to be done. Okay. So I did a one step footing. I did this kind of a kind of eccentric footing or something like that. Okay. This is a kind of eccentric footing only. Let us consider where your second step is somewhere here. Okay. In this way, you're supposed to do the quantity estimation for the project. Okay. Resting PCC excavation quantity, then shuttering quantity for column and all remains same. Only your footing concrete and footing shuttering will change. Okay, that's it. So I think I've covered most of the part here. We have covered most of the topics here. That's how it is. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So we have seen almost all kind of footings here. And finally, the last footing what we have is a raft footing, right? So what exactly is a raft footing? We know that. So anyhow, I'll show it once again. So raft footing is something where you have a one single footing, and over that you have multiple columns. So we call it as a raft, or few people call this as a mat foundation. Like yeah, somewhere here you see here what has happened is a huge foundation what we have, and in between that you have multiple columns, something like this, isn't it? Huge foundation and then multiple columns in this way. It's called as rough foundation. How do you find the concrete quantity and also the shuttering quantity for this? It's pretty simple. Okay, nothing. I'll show you one drawing for this. So we'll go to that drawing. So you can see here, it's a huge and usually rough foundation we use when you have a huge building. For example, if you're constructing a ground plus 10-story building, okay, or let us say a ground plus 8-story building and all, and it depends on soil conditions also. Okay, but typically up to G plus 5 building, we don't use a rough foundation. We usually go with a normal isolated footing or combined footing is sufficient. Okay, but usually when you go for a very high rise building, big commercial buildings and all, the best practice or the what usually we do is we go with the rough foundation. But again, it depends on your soil conditions and all. Okay, now in this particular project, what they have mentioned, this is a footing. Okay, see here, the one which is this yellow color. No, I'll click on the yellow color. So this entire is your rough foundation. Okay, so the shape is something like this. And now the depth is mentioned here. You can see it here. I'll show you. See here, it's written 1000 thick raft, means 1 meter is the thickness of your raft. Okay, the depth of your foundation is 1 meter. So since it's a huge foundation, we'll try to find the concrete quantity. So concrete quantity is pretty simple. Now Here I'll not since it's a irregular shape. See, if this was actually a square shape, then I could have taken the length, I could have taken the breadth and multiplied that by the depth. That I could have done. But now what has happened, this is in since it's a irregular footing, irregular shape, I'll just click here. I'll click select on this. Okay, I'll select it and I'll press on Li, that is least, and click on it. Click on this. Okay, this will directly give me the area. So you see the area is 216,980,2843. So this is in mm now. Okay, this area is in mm square, but I will convert this into meter now. How shall I convert? It's very simple. I told you. So 1 meter is 1000 mm, right? 1000 mm. But here the unit is given in which one? Mm square. So if I want in 1 meter square, if I want, so if it is 1 meter square, then what will happen? 1000 into 1000 I should do. Okay, that will be conversion. That means 6 zeros will come. 1 2 3 4 5 6 zeros will come. So whatever answer I have here, no, 216,980,284, this I have to divide it by 1000. So I'll do that. This I'll divide by 1000. Okay, you can not 1000, sorry, one on this slack, I mean 3 3. Okay, 6 zeros I'll do. Now tell me what answer you're getting. You do it manually. So 216, and then I have 9802843. Okay, divided by 6 zeros, 3 and 3. Done. So I'm getting 2169.80 meter square. Okay, so this area is quite, it's a huge area what I'm getting. 2169.80 meter square is the area. Okay, fine. So I got the area. I need to multiply this area with a depth. I'll get the concrete quantity, right? So I'll write here only. So concrete quantity will be how much? 2169.80. You multiply this by the depth. Depth we have 1 meter. Okay, I'll multiply this by 1 meter. 1000 mm was there, so it's in meter. So no problem. So if you multiply this directly, you are going to get the concrete quantity. Area I got. This is my area. So this area I'll multiply by depth. Depth is 1 meter. I want the answer to be in meter, no? So 1000 mm, I put it in meter. So the concrete quantity itself is 2169 cubic meter. It's a huge amount of concrete what is required in this particular footing. Okay, so that is how you're supposed to understand. And now I'll also find the what part? I'll also find the this is what is that? Perimeter. I want to find the shuttering quantity. For shuttering, I want the perimeter. So perimeter is given 193641. So this perimeter is mm. Okay, since the sides, since, so if I not able to understand, you see here, if I take this dimension, you can see 3584. This is in mm. Okay, so if I divide this by 1000, I'll get in meter. So 1 2 3, it will be 35.84 meter. So in this way you have to add all the perimeter, that this shuttering, this part, then again this part, then again this part, this part, this. So everywhere you add it, you'll get the perimeter. So that is why what we do, since it's a irregular shape, I'll select here, I'll say Li and enter. So perimeter is 193641. So this you have to divide by 1000. Okay, why it is 1000? Because it's a meter, no? It's an mm. I want to convert this into meter. So I just have to divide it by 1000. That's it. That was area. So we had taken 1 lakh. Okay, so if you do this, tell me how much answer you are getting. So I'll do it manually. 193641 divided by 1000. So I'm getting 193.64 meter. So this is my perimeter. Okay, this is my perimeter. Perimeter. Fine. I got my perimeter. So if I want the shuttering area, what I need to do? Therefore, shuttering area. Shuttering area will be your perimeter, that is 193.64 multiplied by the depth. So depth we have 1 meter. That's it. So this itself is the answer. Okay. 193.64 is the answer what we have. So 193.64 meter square. 364 meter square of shuttering is required. Okay, so this is how we are supposed to take care of the raft foundation. Okay, very simple. So if it was instead of irregular shape, if it was here also there is one more, here also there is one more. See, here also there is one more raft footing, and here also there is one more raft footing. Okay, they have given all this raft footing, and outside it is isolated. So again, if you want to find this area, I'll select this footing. I'll say Li. Okay, it's not selected. Selected, yeah. Li, enter. So again, area you see here and perimeter is given. Okay. So in this way, you are supposed to do the quantity for the Raft foundation. So shuttering and concrete we understood. Rest everything remains the same. Whatever maybe your stone soling or whatever, if you do, it's the same thing what we did in the earlier cases. Okay. Only the thing is area you need to calculate, which will happen only through AutoCAD drawings. That's it. So it's an apartment project. So that is why we have, you can see here, B block D, then you have this C block, and you have this, maybe this is another block. Okay. That's how you're supposed to do it. Yeah. So I hope you have enjoyed my lecture up to here. You got an idea how the rough foundation, concrete, and the shuttering has to be done. So we'll see you back in the next lecture. Thank you.